Scusiamo un attimo per il ritardo nella tabella di marcia, ma stiamo aspettando gli ultimi ospiti che stanno cercando parcheggio. Purtroppo il bello delle zone storiche ha come controparte il fatto che non si trova molto facilmente parcheggio. Inizieremo fra qualche minuto. Sorry for the delay, we will start in a few minutes. We are waiting for other guests.
Iniziamo. Come era stato convenuto, diciamo, la prima parte, quella istituzionale, è in lingua italiana, quindi I apologize to your international guests, but only for the institutional greetings, I will speak in Italian. Quindi ringrazio, saluto tutti, le autorità e sostanzialmente colui che ci ospita, ovvero sia il rettore e il direttore del Dipartimento, del nostro Dipartimento, nonché il direttore generale del nostro superiore ministero, che ha creduto con noi ad, seppur un progetto regionale, renderlo internazionale ai fini di un confronto con le massime autorità scientifiche a livello internazionale. Questo è un progetto PSR, quindi è un progetto regionale che ha delle radici estremamente importanti a livello territoriale, ma che vuole confrontarsi su due livelli, a livello internazionale, per mutuare esperienza, competenze e conoscenze. A questo punto chiamerei il padrone di casa, il magnifico rettore Gerardo Canfora, per un saluto istituzionale.
Grazie Carmine, visto che partiamo con qualche minuto di ritardo sarò veramente breve e sono veramente felice di ospitare questa manifestazione oggi. È molto bello vedere, diciamo, così tanti esperti da provenienze diverse, da esperienze diverse, confrontarsi su un tema importante. Ovviamente io non sono un esperto della materie di cui parlerete oggi, mi guardo bene dall'entrare in una qualunque considerazione, però diciamo da quello che ho compreso è un convegno, come si dice in inglese, quanto mai timely, legato a un'esigenza di questi giorni, perché è un convegno che mette le basi scientifiche per la valorizzazione del rapporto che esiste fra cibo, cultura e territori, la tipicità dei diversi territori. E questo è un fatto importante che ha sempre più attenzione da parte anche del grande pubblico. Io so che ci sono ospiti e relatori che vengono da varie parti d'Italia e non solo d'Italia, per cui diciamo da bravo padrone di casa, oltre a ringraziarvi per essere qui con noi, vi dico: trovate il tempo per visitare la città di Benevento. È una città piccola, ma è un piccolo scrigno, ci sono bellezze inaspettate, è una città che ha una stratificazione di tre grandi epoche, quella dei Romani, quella dei Longobardi e il lungo periodo della dominazione papalina, ed è una città, visto che parliamo di caratterizzazione di ingredienti e il rapporto con il territorio, è una città che ha fatto del proprio cibo e della propria tradizione e del rapporto fra cibo e territorio un suo punto di forza. Quindi trovate anche il tempo magari di assaporare il cibo beneventano e il vino beneventano. Questo ovviamente dopo le sessioni di lavoro, perché vogliamo che le sessioni di lavoro siano di alta qualità, come sono sicuro saranno. Il mio augurio è di avere qui 2 giorni di confronto vivo, vivace, che possa arricchire tutti quanti e soprattutto che possa far nascere idee per nuovi progetti, nuove relazioni, nuove networking, perché la ricerca non si fa da soli, non si fa in un unico laboratorio, ma si fa lavorando in rete. Buon lavoro a tutti quanti.
Grazie Rettore, anche per il tuo marketing territoriale per quanto riguarda Benevento e le sue emergenze. Lascio la parola al professore Vito, direttore del Dipartimento di Scienze e Tecnologie, che insieme a noi insomma, c'è sempre vicino quando ci sono queste iniziative. Prego Pasquale.
Good morning, everybody. Welcome in Benevento. As Carmine did, I will speak in Italian only for the institutional welcome to the audience. È veramente un piacere ospitare come Dipartimento di Scienze e Tecnologie, che forse è quello culturalmente più vicino alla tematica del convegno, un evento così prestigioso e di così alta levatura. Devo dire, con Carmine noi abbiamo spesso delle lunghissime discussioni sul tema della biodiversità e della ricchezza del patrimonio genetico della natura che abbiamo ereditato. Io ricordo, forse qualcuno più giovane in sala non avrà questi ricordi, negli anni 90, quando si cominciava a parlare di globalizzazione e dei movimenti di opposizione ad essa, che si organizzarono subito i famosi black bloc, se vi ricordate, che erano queste rappresaglie quasi contro i grandi eventi internazionali che in qualche modo applicavano o cercavano di organizzare questo fenomeno così ampio che è la globalizzazione. E tutti quanti ci ricordiamo delle scene di una violenza inaudita. Forse non molti sanno però che uno degli ispiratori era un signore, un sindacalista francese che si chiamava José Bové, che difatti una mattina dalle campagne francesi si sale sul trattore, arriva a Parigi e con il trattore entra dentro un McDonald's perché accusava McDonald's di aver causato l'estinzione di circa 600 varietà di patate, perché in tutti i McDonald's del mondo viene usata la stessa varietà di patata e questo aveva fatto sì che diventava poco conveniente o difficilmente praticabile coltivare altre varietà dello stesso vegetale. E questo ci spiega come già la sensibilità, allora parliamo praticamente di 30 anni fa, verso il mantenimento della biodiversità e della ricchezza delle varietà sia animali che vegetali fosse uno dei patrimoni dell'umanità. Ed è importante che questi temi vengano affrontati e ne venga esaltata l'importanza. Per cui vi lascio ai lavori e spero che sia un meeting enjoyable per tutti quanti.
Grazie direttore. A questo punto chiamiamo il dottore Consoli, il direttore dell'internazionalizzazione del nostro Ministero, che ringrazio ancora ulteriormente per la sua disponibilità a recepire come un progetto regionale possa essere così, diciamo, inteso anche in termini di internazionalizzazione.
Buongiorno a tutti, è un piacere essere qui con voi. Ringrazio innanzitutto l'Università del Sannio e il Rettore Canfora per questo convegno, per ospitare questa conferenza così importante. Ringrazio l'amico Carmine Guarino per aver animato questo progetto e per il cortese invito, ovviamente. La mia presenza qui mi dà l'occasione per dire in estrema sintesi quanto il Ministero dell'Università e della Ricerca tenga a questo campo scientifico e questo è certificato attraverso gli ingenti finanziamenti che in qualche modo il Ministero dell'Università e della Ricerca eroga, ma anche e soprattutto dall'attenzione che il Ministero ha nei confronti dello spettro europeo e quindi del programma quadro di ricerca e innovazione. Si è deciso recentemente di investire 17 milioni di euro per una partnership internazionale Biodiversa Plus. Già c'è stata la prima call, stiamo sempre molto concentrati su questo settore scientifico. Mi piace anche rimarcare la costanza del finanziamento e dell'attenzione del Ministero dell'Università e della Ricerca nei confronti di un altro partenariato particolarmente rilevante, che è PRIMA, il partenariato che si occupa di food and water nell'ambito del bacino del Mediterraneo. Stiamo investendo in questi anni 50 milioni di euro, adesso siamo concentrati nelle discussioni europee circa la continuità di questo importante programma. E all'interno di questo programma ci sono una serie di progetti davvero pregevoli anche nel campo scientifico di vostra pertinenza, cioè nella valorizzazione delle risorse genetiche. E poi evidenzio anche con piacere non solo quello che è lo spettro di natura internazionale ed europea, ma anche lo spettro di natura nazionale, quindi i notevoli investimenti che il Ministero sta conducendo con le risorse PNRR. Faccio riferimento innanzitutto ai grandi centri nazionali che si stanno via via strutturando in questi mesi, ovvero quello sull'agritech e quello proprio sulla biodiversità. Da ultimo mi piace moltissimo evidenziare, soprattutto in questa sede, la necessità, l'importanza e il rilievo delle grandi infrastrutture di ricerca. Nel campo specifico voglio citare Emphasis, su cui il Ministero sta investendo, ma anche LifeWatch ERIC. Sono questi investimenti su cui a cui il Ministero tiene particolarmente, perché, come diceva molto giustamente il Rettore, è necessario che le comunità scientifiche lavorino insieme, che producano dati sulla base del principio FAIR, cioè della riutilizzabilità del dato, sulla base dell'affidabilità del dato. E per questo il Ministero sta molto lavorando proprio alle infrastrutture di ricerca che operano come veri e propri repository di questi dati. Mi piace anche da ultimo evidenziare come sia sempre più necessario che comunità scientifiche come la vostra operino nell'ambito delle grandi organizzazioni internazionali, e faccio riferimento soprattutto all'NBL, che costituisce uno dei grandi investimenti annuali che il Ministero dell'Università e della Ricerca opera. Non vado oltre perché credo di aver parlato già troppo. Ovviamente auguro a tutti voi 1 o 2 giorni di proficuo lavoro e ovviamente un grande in bocca al lupo per il proseguo delle vostre attività scientifiche. Grazie.
Allora chiamo il dottor Luca Sgroia, presidente del CRA, ovvero sia del consorzio tra la Regione Campania e le università campane, capofila del progetto PSR che ha di fatto finanziato questa iniziativa e che, come me, anche lui crede in questa internazionalizzazione. L'azienda in prosta, solo per dire 2 parole, è l'azienda dove c'è la collection per quanto riguarda i fruit trees. Quindi pertanto è il custode in questo momento di questa collezione esaustiva per quanto riguarda gli alberi da frutto meritevoli di conservazione e o a rischio di estinzione. Quindi pertanto è il nostro centro, tra virgolette, di germoplasma. Ecco, quindi do il benvenuto al Presidente che anche lui vuole porgere i suoi saluti. Prego.
Sì. Grazie, buongiorno a tutti. Innanzitutto un ringraziamento sincero al professor Canfora, al magnifico rettore dell'Unisagno, e al professor Vito, direttore del Dipartimento di Scienze e Tecnologia, che ci ospitano questa mattina in questa bella cornice. E un ringraziamento sincero, non formale, va al mio amico professore Carmine Guarino per il lavoro che ha svolto non solo nell'organizzazione di questo appuntamento, di questo convegno, per il quale si è speso e di cui le presenze autorevoli internazionali presenti ci onorano, ma in generale per il lavoro che ha svolto in questi anni sul progetto di Covale, di cui lui è meritatamente il nostro responsabile scientifico del progetto collettivo. E vi anticipo che a breve dovrebbe anche raggiungerci, ci sta raggiungendo, l'assessore regionale all'agricoltura, l'onorevole Nicola Caputo. Questo convegno, Carmine, tu sai, avremmo dovuto inizialmente svolgerlo all'estero, poi diciamo anche per le dinamiche relative alla questione del Covid abbiamo chiesto opportunamente una variante rispetto a questo progetto e abbiamo pensato di svolgerlo qui a Benevento e di svolgerlo in questa splendida cornice proprio per dare da questo punto di vista a questo tipo di appuntamento internazionale il rilievo che esso meritava. Ritengo da questo punto di vista di dovervi dire proprio due parole sul progetto di Covale, che è il progetto su cui noi stiamo lavorando già da molti anni. Abbiamo di recente ricevuto una proroga, il progetto arriverà fino al 31 gennaio 2024 per completare alcune attività ed è un progetto a cui io come Presidente del Centro per la Ricerca Applicata in Agricoltura ci ho fatto una buona presentazione, Carmine, delle nostre attività, ci teniamo veramente in maniera particolare, perché tra le attività del Centro per la Ricerca Applicata in Agricoltura, che unisce la Regione Campania con 4 delle università della Campania, probabilmente l'attività più importante che svolgiamo è proprio la gestione dell'azienda agricola regionale in prosta e il progetto di Covale è un progetto che in gran parte è costruito sulle potenzialità, sulla funzione dell'azienda in prosta come straordinaria banca del germoplasma della Regione Campania. Vi dico veramente in maniera velocissima, considerate che delle 174 RGV inserite nel repertorio regionale come a rischio di estinzione, noi ne conserviamo ben 158, di cui 155 alla sola azienda in prosta, per poi essere replicate 101 al CREA e 57 al Portici presso l'Università di Napoli. Delle 253 RGV meritevoli di tutela ne conserviamo 241 complessive, di cui 225 all'improsta, replicate poi al CREA di Caserta e a Portici. Dicevo, uno straordinario patrimonio della biodiversità frutticolo, un lavoro immane e meticoloso che si è svolto in questi anni, a cui si è coniugato, oltre a questa conservazione ex situ che noi facciamo, la conservazione in situ che facciamo con la nostra rete dei coltivatori custodi, con gli innumerevoli stakeholder che anche qui devo dire e devo ringraziare Carmine per lo sforzo che ha fatto di rendere questo network amplissimo, che oltre una trentina ruotano attorno al nostro progetto. Non mi dilungo sulle azioni perché saranno oggetto, da questo punto di vista, del dibattito della conferenza che andiamo a svolgere. Dico che questo non è l'unico convegno nell'ambito delle iniziative che abbiamo svolto, ne abbiamo fatti diversi, ne abbiamo fatti forse, Carmine, qualcuno anche in più rispetto a quelli che erano nel progetto, perché riteniamo che i risultati, le azioni, le attività di Covale debbano essere portate a giusta conoscenza e a giusta divulgazione. E mi permetto veramente di fare una considerazione velocissima sulla biodiversità. Mi sembra che lo accennava in maniera assolutamente proficua il direttore del Dipartimento, il professor Vito, mi ha convinto su alcune sue considerazioni che svolgeva. Noi viviamo in un periodo in cui ci siamo scoperti incredibilmente fragili, vuoi per la crisi pandemica prima, vuoi per la guerra poi, vuoi per la crisi energetica e l'incremento dei costi ancora, che hanno fatto scoprire delle importanti fragilità del sistema Europa, dell'Italia, della Regione Campania, dei nostri territori, anche sul piano dell'autosufficienza, quando Quante cose abbiamo scoperto negli ultimi mesi rispetto a certe nostre non autosufficienze anche alimentari dovute alle dinamiche della guerra. Quindi la biodiversità diventa anche un tema credo io, di ricchezza e di competitività. Ne parlavamo, Carmine, ti ricorderai, al convegno che abbiamo tenuto dal professore Di Vaio a Portici. Se noi domandiamo a un consumatore medio quante varietà di frutta conosce, probabilmente le risposte che ci fornirà sui tipi di frutta che conosce anche all'interno della regione Campania o nel paese ci darà un elenco assolutamente limitato, e la nostra capacità di scelta dei prodotti spesso dipende da questo approccio, che è un approccio innanzitutto conoscitivo, che si basa sul marketing come è attualmente. E credo quindi che progetti come il progetto di Covale possano essere alla base della costruzione di un nuovo marketing anche della territorialità, della biodiversità, come sinonimo di eccellenza e di qualità. Quindi un progetto che ha sì nella ricerca scientifica uno sguardo importante, ma che ha i piedi, come dire, ben piantati a terra e nella prospettiva di quello che i risultati di questa attività possono rendere anche in termini di competitività dei territori. Dicevo, il progetto di Covale, e concludo, ha avuto di recente una proroga e proseguirà fino al 31 gennaio 2024. Ovviamente c'è l'auspicio che questo straordinario patrimonio di lavoro che abbiamo svolto, io, Carmine e tutti i responsabili scientifici delle varie azioni, non termini lì. Cioè io mi auguro che uno spazio nella nuova programmazione per un prosieguo di queste attività, per un approfondimento, per un lavoro ulteriore su ulteriori varietà, per un incremento delle tabelle, dell'elenco delle varietà da tutelare, sia lo sforzo che dobbiamo augurarci e che dobbiamo svolgere insieme. Vi ringrazio.
Bene. Professore Testolin, lo perdoniamo all'avvocato Sgroia, essendo un avvocato e il presidente, quando parla di tabelle, è anche un modo per stemperare, perché ovviamente siamo tutti un po', stiamo cercando di capire quando arriva l'assessore. Io sinceramente propongo, innanzitutto voglio, ribadire due considerazioni che sono funzionali a quello che ha detto adesso il dottore Sgroia. Allora, erano due considerazioni che avevo in mente di dire quando c'era anche l'assessore, ma purtroppo, essendo in ritardo e comunque noi abbiamo una giornata estremamente impegnativa, molte delle cose che noi diremo adesso, oppure abbiamo accennato, le vedrete poi nell'ambito proprio della conferenza, tutti i contributi che questo PSR, che questo progetto ha dato. Ma due considerazioni le vorrei fare. Il motivo per cui noi rendiamo questa struttura così territoriale, quindi questa permeazione, questi progetti che sono estremamente applicativi sul territorio stesso, li rendiamo internazionali, e il nostro PSR abbiamo inteso intenderlo internazionale su due momenti e livelli diversi. Il primo è quello che vedete adesso. Mi fa piacere che ci sono tanti giovani, stanno ancora arrivando tanti giovani, perché il carattere della biodiversità e dell'agrobiodiversità è un qualche cosa di importante. Noi qui abbiamo la massima autorità di policy per quanto riguarda i caratteri della biodiversità, ovvero sia la FAO, con un altissimo rappresentante, così come abbiamo tantissimi ospiti che della biodiversità e dell'agrobiodiversità in particolare ne fanno la loro professione. E in tale contesto, quindi, questo è il primo livello, e noi con loro ci vogliamo confrontare, perché, come diceva Luca, noi vogliamo andare avanti su questa vicenda. Ma per andare avanti dobbiamo anche sentire gli altri, quindi dobbiamo ascoltare chi più di noi ne sa, al fine di determinare questa esperienza con grande umiltà e con applicazione. Il secondo livello è quello di comunque metterci in discussione, perché a questo progetto hanno partecipato tutte le università campane che si interessano di questi argomenti, dalla Federico II alla Vanvitelli, a Salerno, l'Istituto delle Ricerche, il CNR, il CREA, ovvero sia tutti gli attori che in qualche modo in questi anni hanno reso possibile queste, diciamo, banche del germoplasma e gli studi su queste banche del germoplasma. E quindi in tale contesto abbiamo inteso un altro momento internazionale, che è il momento di chiedere ad una rivista di altissimo livello per chi lavora in plant science, ovvero sia sul circuito di Frontiers in Plant Science, un numero speciale per il quale venivano, in effetti saranno adottati una serie di nostri contributi che derivano dal progetto di GLOBALE, ma altri contributi si sono aggiunti, moltissimi altri contributi si stanno aggiungendo a questo numero speciale, che arrivano un po' da tutto il mondo, dal Mesoamerica al Sud America, al sud-est asiatico e del bacino del Mediterraneo. Quindi sono tutta una serie di esperienze a livello diverso, a livello globale. Qui ne abbiamo qualcuno che in definitiva ha proprio accettato questo appello, il professore Raggi per esempio. Quindi pertanto noi su questo siamo molto contenti, perché riteniamo che il momento di discussione scientifica e di condivisione di una serie di analisi e risultati possano essere importanti, diciamo, la loro diffusione e poi il confronto internazionale, perché ovviamente da ricercatori non possiamo sfuggire al confronto internazionale, diventerebbe estremamente riduttivo per noi. A questo punto, anche se noi fremiamo nei saluti dell'assessore, io direi che facciamo per il momento il coffee break e dopodiché, quando verrà l'assessore, lo faremo aprire prima che il professore Testolin dia inizio al Scientific Committee per quanto riguarda la conferenza, il prosieguo della conferenza. Grazie. Bene, se ci accomodiamo per favore, visto che abbiamo tanto atteso l'assessore, è qui con noi, ma ovviamente essendo questa una regione che ha moltissime attività, bisogna poi di andare via il prima possibile perché ha, credo, un volo, un aereo. Allora ci ponevamo il problema, cioè, diciamo, della rappresentanza istituzionale della regione. Ci fa piacere in questo momento che l'assessore è qui, ma oltre all'assessore c'è anche un'altra valida, come dire, presenza per quanto riguarda la politica regionale, e questo ci fa molto piacere. Ovviamente purtroppo l'assessore per diversi motivi non ha seguito ciò che è stato detto nella prima parte un po' istituzionale, soprattutto quello detto da Luca Sgroia e poi successivamente ribadito un po' da me. Ripeto quello che ho detto prima, Assessore, perché un PSR finanziato dalla Regione Campania, quindi un progetto estremamente pervasivo dal punto di vista del territorio e quindi così ben strutturato dal punto di vista, diciamo, anche estremamente ambizioso da parte della Regione, abbiamo inteso due momenti internazionali proprio perché noi riteniamo, per quello che stiamo facendo, vogliamo condividerlo con delle persone che hanno una grandissima esperienza in questo settore, al fine di mutuare conoscenze e quindi fare in modo che questa nostra rete di conservazione dell'intera regione possa dialogare con il Mediterraneo e poi a livello globale, perché l'agrobiodiversità noi la intendiamo come bene comune, anche se è un'espressione di oligopoli naturali e culturali, però ovviamente ha una, come dire, è un bene collettivo che dobbiamo tutelare a qualsiasi livello. E quindi questa, diciamo, idea di fare in modo di portare qui coloro che a livello, diciamo, di conservazione sono ai massimi livelli, come la FAO, come l'USDA, cioè vale a dire il Dipartimento di Agricoltura degli Stati Uniti, con la Cornell University, la UK, ovvero sia il Core Coalition del Regno Unito. È collegata con noi la Spagna, con Angelina Belay, la quale è la massima esponente della conservazione del germoplasma dell'ulivo stesso. E poi ci sono tante personalità italiane, le quali sostanzialmente risultano essere veramente estremamente incisive nell'ambito della conservazione. E quindi noi senza problemi ci confrontiamo, perché rendiamo questo nostro progetto ambizioso perché credo che sia giusto che la Campania, con il suo oligopolio naturale, con la sua diversità dal punto di vista morfologico, ambientale, culturale, debba avere questo tipo di palcoscenico per quanto riguarda le prospettive della conservazione delle piante legnose da frutto. A questo punto, proprio perché i tempi stringono, chiedo all'assessore di prendere la parola. Prego.
Grazie, buongiorno e scusatemi per questo contrattempo, ma ho questo volo. Dal Covid in poi i voli per Bruxelles sono stati ridotti al massimo e c'è un solo volo al giorno, quindi, ma ci tenevo ad essere qui, ci tenevo soprattutto per il professore Guarino, per questo progetto che osserviamo con grande interesse dalla Regione, un progetto ambizioso che vede coinvolti moltissimi partner di grande livello, a partire ovviamente dall'Università del Sannio, ma diciamo, c'è anche l'azienda Improsta, un'azienda regionale, un'azienda sperimentale che stiamo cercando, grazie al lavoro anche che sta mettendo in campo Luca Sgroia, di diciamo, incamminare verso una nuova mission. È fondamentale questo progetto perché l'agricoltura moderna richiede soprattutto una forte interazione tra ricerca, innovazione, applicazione, ma anche strategia, visione. Tutte queste cose le ritroviamo in questo progetto che auspico davvero possa diciamo, come dire, avere anche una continuazione nell'immediato futuro. Da questo punto di vista ci vedremo a strettissimo giro col professor Guarino, con Luca Sgroia, con tutti gli altri partner per cercare di individuare anche modalità operative per dare seguito a questo progetto. Intanto la Regione Campania ha già dimostrato massima vicinanza anche nel comprendere le difficoltà operative che ci sono state in questi ultimi tempi tra Covid e guerra, quindi concedendo ovviamente tutto il supporto necessario. Dicevo, il progetto è ambizioso ed è un progetto che dobbiamo come dire, far divenire davvero un nostro core business, no? Un core business del nostro assessorato. Non è un caso che io oggi, diciamo, sebbene con pochissimi minuti di disponibilità, ho voluto essere presente personalmente per come dire, rappresentare una vicinanza non solo come dire, proclamata, ma anche fisica, e complimentarmi con quanto state facendo. Questo è il futuro dell'agricoltura, l'agricoltura che deve saper guardare al futuro e deve saper anche immaginarsi una nuova strategia. Noi stiamo lavorando molto al concetto di funzionalità alla salute dei prodotti agroalimentari della Campania, e quale migliore diciamo, base di partenza di questa conoscenza scientifica che voi state mettendo dentro questa banca dati sul campo, in improsta, ma anche, voglio dire, diffusa sui territori. Davvero è quello che è l'agricoltura che io ho in mente, un'agricoltura che sa confrontarsi con il mondo, e da questo punto di vista auspico, e per questo vorrei incontrarvi a breve, per cercare di capire anche delle possibili interazioni internazionali che possiamo mettere in campo. L'agricoltura di questa regione è un'agricoltura vivacissima, ci sono bravissimi imprenditori, ma dobbiamo fare ancora un piccolo salto in avanti, soprattutto applicando diciamo, le conoscenze che la ricerca ci sta mettendo a disposizione. Quindi complimenti a tutti quanti voi per quello che state facendo. La Regione è qui al vostro fianco per accompagnarvi e davvero spero che possiamo insieme costruire le basi in questo settore, nel settore del frutticolo, ma perché no, estenderlo anche alle altre attività per diciamo, segnare davvero un passo in avanti dell'agricoltura della nostra regione. Vi ringrazio tanto e vi chiedo scusa per se devo lasciare i lavori, ma diciamo, dovrei arrivare a Napoli entro le 12:15, è abbastanza dura, ma ci tenevo davvero, non solo per Carmine, ma diciamo, per la bontà di questo progetto. Grazie mille.
Bene, allora adesso arriviamo per la seconda parte, quindi chiamo il professore Raffaele.
Mi ero riservato il saluto finale ad una persona che è molto vicina al progetto e che è un po' di fianco, l'onorevole Venanzoni, consigliere regionale della Campania, che più volte mi ha sollecitato questa attività e mi faceva piacere salutarlo. Grazie Diego per quello che fai.
Purtroppo Diego ogni sabato e domenica insomma, era un martello per quanto riguarda questo progetto, quindi Nicola era ben consapevole. Detto questo, io chiamerei il professore Raffaele Testolin, che non ha bisogno di presentazioni, il mio maestro anche, grande biologo molecolare, e quindi lascio a lui tutta la prospettiva e da questo momento in poi finisce la parte istituzionale, quindi il linguaggio è tutto in inglese, quindi si speak English. Grazie.
Thank you very much for the invitation and welcome to everybody who came to attend this interesting meeting. I think that the Nagoya Treaty has put in trouble many breeders because it made difficult any exchange of plant material. I don't know about animals, but probably they have the same problem. So, welcome to everybody. Let me invite the first speaker, Dr. Kent Nadogie. He is Secretary of the FAO, International Treaty on Plant Genetic Resources. He has a great experience in law and business administration, and so he is a great specialist on legal issues related to genetic resources. Please. The lecture is the International Governance of Plant Genetic Resources for Food and Agriculture, the role of the International Plant Treaty. Please.
Okay. Thank you very much. I have a presentation. I can speak from.
You can. Okay. Okay.
Yeah, thank you very much, Chairperson, and thank you so much, Professor Guarino, for inviting me to this very timely and important conference. I think it's quite important in a lot of ways, and the location as well is also significant because the Campania region is one of the very, very rich regions of Italy in terms of the diversity of crops that they have and the culture as well and traditions that are linked to those crops and the diversity. While a lot of the activities related to agrobiodiversity is location-specific and local in nature, but the issues surrounding them are international and global. And the processes that go on in the international arena also affect what is done locally. So in the brief period that I have, I'll just have a quick look at some of the issues that will affect researchers, breeders, farmers, as well as local communities in the work that they do related to agrobiodiversity, at least from the perspective of the International Plant Treaty on Genetic Resources for Food and Agriculture. While, of course, most of the participants here probably know more about genetic resources than I do, I come from more like a policy, legal perspective, but just a quick rundown of some of the reasons why we're here today and why agrobiodiversity and genetic resources in particular are important and significant in the, in the world today. First and foremost, while, as I said, agrobiodiversity issues are local and location specific, but at the same time, there's a very broad base of interdependence among countries, among regions, regions as well. Well, of course, we know a lot of you also are quite aware of the origin of crops, where they come from, where they got that, their diversity from, and how they moved around. And the usual practice in the scientific community is to exchange and to share those resources. So you find that, of course, some of the staple crops that each country depend on must have arisen from somewhere else, whether it is rice from the Southeast Asia, wheat from Mesoamerica, potato from the Andean region, or or even some other minor crops that are consumed widely in certain regions. Tomatoes, for instance, didn't originate here. So see that level of and depth of interdependence, and that is why it's so critical, that the work that you do, it takes into account the international processes and ramifications of the work that you do. In this context as well, you find that the world population is growing at phenomenal rates. We have limited land and physical resources, to plant and to grow food. So how do you feed that growing population? With the estimate that we have in the next 50 years, we're going to reach almost 90 and by 2050, we'll reach almost 9 billion. All those mouths have to be fed one way or the other, but with limited capacity. And how do you increase productivity to be able to meet that, anticipated growth in consumption? And it's, genetic resources are going to contribute significantly in doing that, in being able to grow more and in different environments, but also at the same time, adapt to the, rapidly changing climatic conditions that we currently face. Even in the context of all this, many of your courses in your research, your activities are aware of what the trends are. There is really decline, very rapid decline in diversity. We're losing some of the very rich diversity that we have and are used to form the basis for agriculture in so many regions. There's continuous, uniform use of certain varieties, even crops as well. And that makes us very, very vulnerable. That when there is climatic conditions, when there is disease or virus or other environmental conditions that could affect certain varieties, then there's, the impact is much more widespread with the reduction in diversity that would have provided the resilience and the buffer that the system needs. So in the context of a climate change, for instance, with the rapid changes in, in planting conditions, so you need to have that fall back of the diversity that will provide the buffer to meet the needs of the new changes that are arising. And the changes in the eco-geographical zones where crops or varieties that used to grow in certain zones are no longer suitable for that. You need to be able to have access to a broad range of diversity to be able to meet these new challenges. At the same time, we have this narrowing, not just genetic erosion, but also narrowing down of the number of crops that we all feed on. You find that very, very few crops constitute a large proportion of the cultivation, but also consumption, and provide the calories that the world needs. That also increases our vulnerability, to shocks, either environmental or those that arise from diseases and pathogens and viruses as well. So when you look at the proportion of that globally, that's a huge, issue that needs to be dealt with. And that's, I guess, I share your concern, many of you who are so concerned about the loss of diversity, how that would impact our future and our needs, meeting future needs. So in this context, while at the same time, of course, we face those real physical, practical, and real life threats, the issues concerning genetic resources, have also become so globalized. As the chair mentioned before, issues arising from Nagoya Protocol, for instance, that are making it much more challenging for researchers to access the material they need for breeding new varieties, or to exchange information as well. The question of ownership, the question of who controls that information becomes very critical. So in this regard, there's that continuous expansion of issues that are being discussed at the global level. There are new players that are coming up and playing very significant roles. Previously, in your field, used to be geneticists or direct agronomists who are playing, but now you find new players that are coming into place, from bioinformatics to a whole range of other players who have critical interest to play here because of the way that science and technology is evolving. So the dynamics of the interrelationships between the different sectors and different stakeholders have been changing as a result of that as well. And that we need to keep track of. And the rapidity of that change is also quite significant. So it is proliferating and fragmenting at the same time. And it's quite difficult to keep track of these changes. And then, so that's why we should keep, be conversant. While, of course, your main concern for a lot of the researchers is in the laboratory, but the issues that are arising from the global political landscape affect the work that you do very significantly. This started when the Convention on Biological Diversity was adopted, which became one of the original, internationally agreed and binding agreements that govern how genetic resources are accessed, exchanged, but also issues relating to how the benefits are shared, benefits that arise from those utilization. And the Convention on Biological Diversity led to the adoption also of the Nagoya Protocol, which became a much more specific application of issues governing access, but also genetic benefit sharing that arise from the use of genetic resources. So the convention, when it was adopted, re-emphasized national control over genetic resources, but sometimes this control creates obstacles and limitations and difficulties for scientists to access the material that they need, creating unnecessary hurdles. And then issues arising from intellectual property rights have also arisen in that regard. And more recently, digital sequence information has become a very major flashpoint of debate in this arena. Then, because the Convention on Biological Diversity and its Nagoya Protocol created difficulties for the agriculture sector in particular, where the culture and the practice is freed and rapid exchange of materials without, because you need the greatest range of diversity for your breeding activities. So it was decided that there's a need to negotiate and agree on an internationally agreed framework that addresses the interest and the specific issues that arise from agriculture sector. And that is why the International Treaty on Plant Genetic Resources was negotiated and agreed. First, it was based on the recognition that all countries are interdependent, that no country is self-sufficient when it comes to the genetic resources that it needs for its agricultural production. And that also issues that relate to it, because of the interconnection and the need to continuously exchange material across borders and across regions, then a multilateral approach is needed that creates an international standardized approach that will make sure that there is certainty for those who are engaging in exchange and use of genetic resources for food and agriculture in particular, so that breeders are not hampered in the way they're able to access the genetic resources. So the international treaty was adopted in 2001, came into force in 2004. And since then, we have over 149 contracting parties or countries that have signed on to it. So which is an indication of the interest and the importance that the countries attach to the treaty, and the recognition of the significance, what it holds for agricultural production and food security in the world today. So the range of countries, from developing countries to the biggest countries and most, largest agricultural producers, from the US to Brazil to Australia to Italy, of course, which was one of the original signatories to the agreement, and the host government to the Secretariat, have all joined and realized that they need to continue facilitating the continuous exchange. But the thing is not just focused on exchange and access, but also it tries to address the concern that we have with the loss of diversity. So there's a major component of the international treaty that deals with conservation, ensure that we do not lose that diversity that we have, which creates the buffer and the foundation of our food production. And this conservation, not for the sake of conservation alone, but conservation for use, and ensuring that we conserve through use. So at least the formal objectives of the treaty, you can see, are three pillars in nature, which is conservation, as I said. Second is sustainable use. Use these resources available in a sustainable manner to ensure that they are conserved and for future generations to use. And at the same time, it addresses the issue of equity, recognizing that not all countries or regions or stakeholders have similar capacities and resources to use the genetic diversity. So it creates a system where, for those who are able to use the genetic diversity, commercialize and sometimes make profit from them, are able to share some of that benefit with those that are not able to do so, or from the regions where the diversity arises from. And the main focus, of course, is on sustainable agriculture and food security. So going back a little bit on the aspect of the on the Convention on Biological Diversity and the Nagoya Protocol, which is quite topical and concerning for at least those in the agricultural sector, I try to draw a little bit of distinction between what it provides, because the Nagoya Protocol deals with all genetic resources in the different sectors, but mostly for those who concern medicinal, for chemical, for industrial uses. But for agricultural, plant genetic resources for food and agriculture, the international treaty applies. They have different approaches. The international treaty looks at and creates standardized format that is multilateral in nature, so that there is a pre-agreed standard, which is the standard material transfer agreement, through which materials are exchanged. And there's a certainty in that. But with regard to genetic resources that fall under the Nagoya Protocol or the Convention on Biological Diversity, you have to negotiate each time you want to use that material, while the treaty provides a very standardized, predetermined process for access. And it also recognizes that access itself is a benefit. The main basis for establishing the system is to ensure that facilitated access is granted to those who need to use the material for that breeding. So to be able to do that, the treaty creates what we call the multilateral system for access and benefit sharing, which is a notional or virtual gene pool that encompasses a number of crops that are contained in the Annex 1. Currently, 64 crops and forages, which the terms and conditions of the treaty apply. So the multilateral system also combines and multilateralizes the benefit sharing as well, so that where there are benefits or profits or sell from material that is used from the system, the money is paid back into a multilateral fund, which is the benefit sharing fund, from which development projects are carried out in developing countries. So at the same time, it's not just facilitating access, but it also creates an international legal framework that links the local to the global, in such a way that there is a continuous exchange and facilitating flow of genetic resources, whether it's from the local community seed bank in Zimbabwe that stores its genetic diversity in the National Gene Bank, which links to the International Genetic Resources Centers of the CGIR and the Global Seed Vault in Svalbard. So that cycle, continuous use and exchange, creates an international conservation system and framework that shows that there's always a backup and that ensures that we do not lose that diversity. And as I said, it's not conservation for the sake of itself, but it's conservation for use. So the treaty creates a framework that facilitates that transition from what I call from fridge to fridge, the refrigerator in the gene banks to the refrigerator in your kitchen. And that is some of the things that we lose sight of, that's just beyond agricultural production. There's also some upstream activities that includes breeders, conservators, gene banks that play a critical role in facilitating the food that we have on our table each time. So the role of conservationists and people who are involved in conservation, whether in situ or ex situ, should be recognized, because I think in metaphorical terms, I would say it is a spring from which the stream flows that comes to your table as the fruits and the vegetables that we eat on a daily basis. At the same time, articles of the treaty provides, as I said, for conservation and sustainable use, which includes very clear, directions to countries and to stakeholders on how to structure and facilitate that conservation and facilitate the sustainable use, which includes strengthening capacity, network of collaboration among scientists and researchers, also broadening the genetic base, because we have to continue evolving and developing new varieties and diversity that meet new conditions and new needs of the society. Another unique aspect of the international treaty is the recognition of farmers' rights and the contribution that farmers have made over the millennia to conserve, to develop and evolve the crops that we use and that we feed on today. So it creates a situation where that contribution is recognized, and also calls on countries to recognize those rights, which includes sharing of benefits, participation in national decision making, and also protecting the traditional knowledge that farmers have developed over the years. Whether it is here in Benevento, or of course part of the region of Campania, or whether it is a small local community in Peru, that knowledge that they have accumulated over the years in how to conserve, use, and develop these crops should be protected and continuously recognized. From some of the reports, of course, we get from different governments and from Italy, for instance, we have experiences that from the Campania region that there are activities that they have been undertaking, and I think they are pioneers in ensuring that local diversity is maintained and not lost, but also used as part of both the traditional processes, but also as part of the food culture they have that becomes so unique to the region. And these activities, including creating food districts, network agreements, and things like that, are part of the activities that I said that are very unique to this region. And that's something we very much appreciate and hope that it is maintained and continued to be protected and promoted as well. This region also, of course, leads in terms of organizing like this conference, for instance, which brings knowledge, creates a platform for continuous exchange of information and knowledge and capacity building because it's directed at the students as well. So, before I conclude, there was some of the questions that I believe that some of the other presenters and experts here today would address. That in the light of all the challenges that we're facing globally, the thing is that how do we continuously ensure that this diversity is maintained and enhanced as well, but also at the same time include and increase the collaborative multidisciplinary approaches that is required. Ensure that taxonomists, geneticists, agronomists, information technologists are all involved in the process and brought together, because these days, while previously, of course, we have very standalone scientists who are able to carry on a lot of activities for themselves, but the vastness of the challenge and the needs call for greater collaboration across disciplines and across institutions and across regions. At the same time, it's not just carrying out the scientific activity, but how do you translate that science into policy action? How do you facilitate that transition, where the activities that science and real science informs policy making in the society? And that's a very critical aspect of it, because science and scientists are not isolated from the society that they exist and they operate in. They should be an integral part of it and should be the basis for policy decisions that affect food production and also how the activities related to agrobiodiversity is carried out. And that is, at the end of the day, something that will benefit all of us. So in conclusion, I'll say, at the end of the day, it's important to facilitate international cooperation, which is what I think this conference is looking at, and based on the activities of the university, bringing people from different parts of the world and different regions to be able to sit together and discuss these issues. And the importance of that collaboration that's built on this network is quite critical in addressing some of the complex and interconnected issues of food security, addressing climate change, but also improving livelihoods of local producers as well. I think one of the things that this global pandemic, even though of course it has impacted agricultural production in very significant ways, has shown and re-emphasized is the interdependence that we have globally, not just in production, but also the interdependence in our common vulnerability to global shocks. And that's something we need to bear in mind at all times, and hopefully that we're going to cooperate to address. So I'll leave you with this small nugget from Nature editorial, I think it was sometime last year, that links to the issue of collaboration that I was talking about. That while individual scientists can do and make progress in their own laboratories, but it's not sufficient. You must collaborate with others. You must, go across disciplines, go across regions, across institutions to be able to make progress, to address the very complex and rapidly evolving problems that we have in society today. So with that, I thank you very much, Mr. Chair, and for your opportunity.
Thank you very much for your interesting talk. The organizer told me that we have time for questions at the end of the section when all speakers will sit here and the audience will be allowed to make questions. The second speaker is Ben Gutierrez. He is a plant geneticist and curator of the apple, pear, tart, cherry collection at the USDA. He did He studied biology and botany in Utah, and then he moved at Cornell University, where he was allowed to drink alcoholic beverages outside of Utah, and he got a master in plant genetics and breeding, a PhD in plant breeding and genetics at the Cornell University, and he placed it in Ithaca. His colleague Gang Yuan Zhong is a scientist, a colleague of Ben Gutierrez, and the talk will be balancing accessibility and vulnerability, managing the United States Department of Agriculture apple, grape, and tart cherry collections. Please, Ben.
Wonderful. Thank you for that introduction, Raphael. And I am humbled to be here. This is this is my first time to Italy, and this is when I now think of Italy, I'll think first of Benevento, and I've been introduced to Strega chocolates, which is legendary again. So I'm so pleased to have this opportunity, and I can't think of a more idyllic place to give this talk except for in my own collection. So that's my preferred site, and so I know Raphael has been there, so if you're ever in Geneva, New York, come by and see us, and I'll give you the real version of this talk. Besides just me, it's a team of people, so just highlighting Tori Meekum, Aaron Galarno, and our research supervisor, Gamwan Zhang. And as we're talking about strategies for global conservation, I'm just taking this opportunity to just introduce myself and the work that we do. And I think that that's the big gap, is we have treaties and we have all these laws that now help us and facilitate exchange of plant genetic resources. But if we don't know each other, right? If we don't know what resources we have and what makes us unique, that there's little that we can do to make progress and gain access to these unique resources. Again, and nothing happens alone, right? We have a whole team of technical staff, of farm managers, purchasers, and all the wonderful people that make our magic, right? That make the work go forward. And we're not just a tree fruit site, but we also have the world collection, or the national collection of tomatoes, brassicas, squash. We recently, United States is new to cannabis sativa for hemp. And so we recently started a hemp collection at our site as well. And so there's a lot of activities, a lot of collaboration for the seed genetic resources, and also our group with the clonal genetic resources. And just taking a step back, what we do is beautiful, right? It's so enjoyable, and it delights the soul to look at the genetic diversity that's out there and kind of behind the scenes of what you see at a grocery store. And so here's just some nice array of some corn, some maize, carrots, squash, and tomato. And then these are my crops. So I get to work with, I think I have the dream job of the curators within our system, of working with tart cherry and apple. And my collaborator Aaron Galarno manages the grape collection. Just taking a step back too, and this is from Aldo Leopold, one of my favorite authors, and one of the founding fathers of American conservation from the early 1900s. And he taught there are two spiritual dangers in not owning a farm. One is the danger of supposing that breakfast comes from the grocery, think of Carrefour, right? And the other, that heat comes from the furnace. And in the US, in the United States, only 2% of the population is involved in any way with agriculture or food production. And that's a very small proportion, whereas we're all consumers, right? Like, we all depend on agriculture for our livelihoods. And so just for making that connection back to people. And I think that's changing a lot as smaller markets and consumers become very deliberate in what they buy and where they spend their money and how their food is grown. But I see, as a germplasm manager, educating the people that there's rich diversity behind our food, right? It's not just beautiful scene at a grocery store. There's a lot of work and a lot of research and development that goes into production. As part of our United States National Plant Germplasm System, Geneva, which I can highlight here is just one of 20 sites within the U.S. dedicated, and each one has a special assignment of crops. Again, we have the best assignment, but other tree fruit crops are maintained in Corvallis, Oregon, Davis, California, Parlier, California, Riverside, California. So that's where our major citrus, our vitis, our European wine grapes are maintained there. And very unique sites are found in Miami, Florida, Hilo, Hawaii, and Mayaguez, Puerto Rico. And these are somewhat interesting because they're redundant sites because of how volatile their climates can be with hurricanes, tropical storms, and everything else. We have a tremendous network within the MPGS, the National Plant Germplasm System. And so really just looking at these numbers, it's just so impressive. And I know that Kent highlighted some of that natural diversity that's found. Most importantly, right, is this number here that we distribute almost 250,000 samples internationally every year. And so it's not just conservation for the sake or only benefiting the United States, but it's really to redistribute that. And we have a really simple mission to acquire, maintain, characterize, and distribute plant genetic resources. And again, more philosophy, a French geneticist, famous, Francois Jacob, diversity is a way of coping with the possible. It acts as a kind of insurance for the future. And I kind of hold on to that thought because sometimes we don't know what the value of our collections or what unique trees or fruit crops might be. And you really have to see the potential in some of the interesting things that we maintain. So I'm just going to walk through our core mission and kind of highlight some of our unique activities, starting with acquisition. And the beauty of true fruits is that we're preserving this heritage, right? It's not just cultivars from modern day or the past. It's really this cultural heritage that makes what we collect timeless. And I should have highlighted some of the Italian cultivars that are there, but I thought share some of like our American heritage here. So Roxbury russet is the first named apple cultivar from America. And so settlers brought over what they loved from Europe, but Roxbury russet is when like American apples really began. Montmorency is a really important tart cherry from France, and it dominates the U.S. market still today. So the 17th century cherry represents 90% of American production, which I'll highlight as why that's kind of a bad idea. And Concord is famous because this is, again, it's not a true European wine grape, but it's a hybrid between American grapes and a European grape. And you get this really distinctive, punchy flavor that's kind of a classic American grape. What's a little bit unique about our collection versus others is we're one of the largest apple sites, gene banks in the world, but it's the composition of our collection that really is unique. And so in terms of number of species, we have about 56 different Malus taxa, which is quite incredible when you think of kind of the broadness of the genus Malus. 30 grape species and 15 tart cherry wild relatives as well. So when you look at just the percentage, 71% of our apple collection is diverse, is wild, right? So that's things either hybridized or just right out of the wild. And so it's kind of interesting and not what you'd immediately expect or see value in for fruit quality, but that's where we find a lot of the disease resistance, the climate adaptability traits, and kind of the sometimes unique, that crunchiness that we get from some of the modern cultivars comes from a wild apple, and that trait was introgressed. The grape collection's really challenging because it's mostly a hybrid collection. And so the composition of how much cultivated Vitis vinifera versus how much of the wild Vitis is kind of difficult to say. But I estimate over 90% of the grape is wild. And tart cherry is about 30% wild. Looking at the acquisition history of the collection, we began in the 1980s formally. And a lot of the founding material came from breeding programs in the United States. So here the blue bar represents Malus domestica. These are cultivars of apple that came from all over the world, right? And were advanced breeding lines, heritage cultivars, advanced cultivars, you name it. And then really in the 1990s, we set out on several explorations to acquire the wild progenitor of apple. And this became a famous story and was featured in books and television shows, at least in the United States. But these genetic resources of the wild progenitor help piece together the genomic story of apple. And you can see we've kind of trailed off because as you can fill your collection so quickly, right? And then you don't have the capacity to maintain or hold anything new. And so really our focus has been on targeted wild apple germplasm carrying out. And most of it comes in as clones, right? So they're perpetuated as clonal material, but a lot of it is seed. So you'd go out into the forests, find apple seeds, harvest the seed and store that. And then what we also do at our site is we'll germinate the seeds, right, and evaluate the seedlings and then make selections from those. So most of our collection is still as tree collections. And here's an example of, in 2018, my colleague went to Vietnam and collected Malus dumeri, which is this fascinating tropical apple which has 0 cold tolerance, so we keep it in a greenhouse. But within 1 generation, you can introgress cold tolerance into this. So unique attributes of Malus dumeri can be utilized for breeding and for research purposes. Here's a unique challenge for grape germplasm, is that we have this beautiful distribution in North America and in Asia. So 2 centers of diversity for grape, and here we have the European grape, right? Vitis vinifera is distributed all through here. But again, a lot of those interesting traits for powdery mildew resistance or cold tolerance, for cold adaptability, are found in Asian and North America. And so we really have a passion to exchange with our Asian colleagues, and they want our material equally, but finding that balance and overcoming those kind of administrative obstacles, even with the treaties, it's still a challenge to share the genetic resources. And then there's a story of North American Malus. So even though apple originates from Asia, as we know, the domestication story, out of Asia through Kazakhstan into Europe, where it hybridized again, and then Europeans domesticated it, Americans domesticated it again. But there's 4 native North American species which are fascinating for disease resistance, particularly for fire blight, which is a devastating disease in apple. And these have really unique qualities, greasy skins that kind of make you feel like you've just put on lotion when you feel them. It's kind of a strange sensation. And there's a lot of potential here, and a lot of ploidy variation. But a lot of our more recent explorations have been focused on these native North American species, just to enrich our collections with those. Moving on to maintenance, again, we've spent the last 40 years acquiring material, and it's a challenge to maintain some of these crops. And I think Kent showed this picture as well, the Svalbard seed vault, right? And so sometimes when we talk gene banks and genetic resource management, this is what we think of, right? Like safety and security, and things are well maintained and preserved. This is our view of genetic resource management, right? So this is trees grown in a field that are fully accessible. You can go every fall, right? We harvest fruit, we taste, we evaluate, materials there for harvesting pollen so breeders can do their crosses, DNA, you name it. They're out there and accessible, but they're also tremendously vulnerable, right? And so you can imagine we're sitting on a 50-acre farm with, again, there's technical errors that sometimes trees get damaged, or heavy wind, rainstorms that bring in a lot of challenges for us. But this is simply how we have been propagating the collection so far. There's a lot of techniques out there, but we just use good old-fashioned grafting, right, to perpetuate our material. I highlight this because it's maybe unique for Europeans that we have self-rooted grapes. So one of our gifts to Europe was the pest phylloxera. I'm sorry about that, by the way. So phylloxera is a North American pest that devastates the European wine grape. It just demolishes production, but we have a native resistance to it. So because our composition is so heavily on North American or Asian species hybrids, we can just self-root, which makes it really easy to perpetuate and to clone. material, and then when we have winter dieback or other issues, they can grow back from their roots. So it's very fortunate for us. This was during the COVID-19 outbreak, right? The pandemic. We had our own little mini pandemic in our collection with fire blight. So fire blight is a bacterial disease in apple, which can really quickly destroy a tree within a season. And this is why that native resistant to it is so important and interesting to us at this point. But we had just this terrible outbreak of antibiotic-resistant fire blight go through the whole collection, and you can see severity. So this is a kind of a grid of our block, every apple tree in their permanent collection. And the color denotes disease severity. So with increasing disease, you see increasing purple color, right? And so there's a lot of purple. And this is really sad for a germplasm manager to have to see in their collection. So here's actually, we did an evaluation of all of the disease for that year in 2020 and made a small publication, but this was a nice view of a completely diseased tree, a heavily severely infected tree, right next to a resistant tree, which is just fascinating to see. So even though we were seeing such devastation in the collection, it was nice to see, like, well, okay, we have a novel source of resistance maybe. This is a nice evaluation opportunity. But keeping this in my mind it's never easy, and your work is never done. No matter how healthy your collection is today, like, there's new challenges, again, as the environment changes, as new pests come in, right? We talk about global strategies. Well, there's these global problems that we also now have because of trade and other issues as the world gets smaller. So what we're doing in response to that outbreak and this new challenge with fire blight is we're really modifying our horticultural practices. So we have a rootstock breeding program, the Geneva Rootstock Series for apple, and really simply by modifying what we graft our trees onto. So having a smaller tree reduces the growth and the vigor of our trees, reducing the fire blight susceptibility. And so this is one option that we're pursuing as management changes. Not only are we forced to apply new and more diverse chemicals to maintain our trees, but now shifting horticultural practices to include higher density, so we can keep more trees on smaller rootstocks. So instead of 2 trees, we're keeping 4 potentially. And this is all in the works, so I'll let you know in 5 to 10 years how this worked out for us. And so as a backup system, we have our colleagues in Fort Collins, Colorado, which manage cryopreservation for all of our crops in the National Plant Germplasm System. So cryopreservation for apple is really simple, just taking dormant scion-wood, drying it down, desiccating it, and then it can store in liquid nitrogen vapor indefinitely, right? We don't know the limitations of it because we haven't been doing it for very long. Grape and cherry are a little bit more complicated. Grape is likely to be successful with droplet vitrification, so taking the plants first into tissue culture and then using liquid nitrogen to store the droplets from that, and then rescue would include tissue culturing to bring back those cultivars. But this is not just doomsday storage. We rely on this method to rescue all of our, many of our trees whenever we have disease or that they age out. The life expectancy for modern trees maintained in a modern orchard is only about 20 years, and we're at that life expectancy anyways. And so this is a wonderful insurance policy that helps us maintain and keep our materials safe. Highlighting the characterization, I think this is one of the most important activities that kind of gets overlooked because of the maintenance challenges of the clonal tree sites. But characterizing is what brings our collections alive, right? Like researchers, we can't use anything if we don't know anything about it. And so understanding its genetic diversity, collecting genotyping information, what fruit color, what does it look like on the inside, how does it taste? All of that is so important. And Tori Meekins, our molecular biologist, who leads a lot of this effort. And I mentioned that our explorations into Kazakhstan in the 90s. From that, we have a tremendous amount of information that came from international collaborators and many others that have pieced together the history, not only just what makes sense geographically, right, but also the genomic composition. And so here we just have a nice display of apples with Domestica, the domesticated apple on the top, the wild progenitor Malus sieversii in the middle, the European Malus sylvestris, for which apple hybridized, and then here's some North American representatives. And so when we genotype our collection, it's not just for the sake of getting the information or fingerprint, but we can use it now to piece together how our collection is interrelated. And this is fascinating as a curator, right? Because you can find redundancy or duplication or overlap. And so here is this plot on my right, or my left side, is showing how the clonal relationships, so these tightly clustered regions here, are showing Golden Delicious clones, and so there are about 30 in our collection at a time. And sometimes when you bring something in, you don't know if the name is true or not. So if I import something from Europe, maybe you call it something different, and we don't know until we can get a genetic fingerprint on it. This is a little bit more devastating, I think, on the right-hand side, because it's showing the first-degree relationships. So whether something is a parent or an offspring, and 827 out of 2,000 accessions have this type of relationship. And so it's a lot of redundancy, right? And the challenge with clonal propagation is sometimes both parents are important, and you need to preserve both. But really, if you're concerned about space, allelic diversity is what you should be passionate and focused on, right? So some of these parent-offspring relationships might not be as valuable, and you can exclude those from conservation. But the clones can be valuable. So this was a study I did for my PhD thesis, looking at clones of Golden Delicious and russeting, this beautiful trait that causes the skin to rough a little bit, and I think it's really desirable. It changes the flavor profile of the fruit. But I was looking at phenolic composition, and the phenolic composition for the metabolite floridsin drastically increased from, almost 4 times from a smooth surface Golden Delicious to a russeted Golden Delicious. So these sports, even though these clonal families may seem like they're taking up space, sometimes if they have unique traits, they can be valuable for other genetic discoveries. And phenolics in apple, and so this was, again, more of my PhD thesis and a passion of mine, because we talk so much about genetic resources for disease resistance, for climate adaptability, but also it's important that we're enhancing and enriching the nutritional profiles of our fruit, making them more dynamic, right? And so these are some of the red-fleshed apples that are in our collection, and that's such a beautiful trait. When apples competing for market space with so many other crops, right? Having something distinctive like a red-fleshed apple or a russeted apple in the US would really be a novel trait that I think consumers could really get a hold of. And that phenolics have such an important role in cardiovascular disease, diabetes, cancer, really in a lot of degenerative diseases. So increasing our phenolic intake really couldn't be bad. And I always love showing this for students, because when we talk phenolics, humans have a draw to just red. Red color, that is a signal to us of maturity, of vitality. It's going to be a healthier apple. But when we actually look at the phenolic composition, right, Surprise over here is surprisingly more phenolic rich than even Durman Delicious, which just by appearance, it kind of is this nice red color, draws you in. And so this phenolic diversity could be really explored for breeding purposes, and it's a highly heritable trait. I studied a lot of dihydrochalcones, and so floridsin is a uniquely apple dihydrochalcone, just a phenolic compound that helps regulate our sugar balance in humans. But other species of apple produce these alternate forms, trilobitin and sibolden. And I know commercially people are really interested in trilobitin because of its sweetening effect. And so PepsiCo, Coca-Cola, all of them want to find the next great sweetener. And what's interesting in apple is that hybrids can produce not just one, but combinations of them, which again, when we think about enriching the nutritional profile and bringing in introgressing wild species, this is one exciting opportunity. Genotyping also reveals maybe some mistakes, or kind of pulls apart some of the story that I was telling you about Malus sieversii. So Phil Forsland in the 90s went to Kazakhstan and collected lots of material 30 years later, we had the genomic capacity to evaluate what he had brought back. And so these are the original sites in Central Asia that he explored. And now these pie charts show the composition of how much Cerevisiae or domestica or hybrid that we found. And surprisingly, we found a lot of hybridization, a lot of admixture, because apple will just pollinate quite openly. And a fascinating example was that we found in Kazakhstan, they collected Rosmarina bianca, an Italian cultivar. And at first we're like, okay, this had to have been a mix-up because there's no way that like this Italian cultivar would be in Kazakhstan just hanging out. But no, it had offspring that had intermixed with this Italian cultivar. So somehow this thing was truly there in Kazakhstan, spreading pollen and hybridizing with Malus cerevisiae. And so it's kind of an interesting story, maybe a cautionary story for any of us that go out into the wild and collect germplasm, because it's not always what you think it might be. And again, what's in a name? What is a name or a taxon even matter? Because these are all Malus prunifolia, and so there's so much in the literature about what Malus prunifolia can bring, right? But which one is true? Which is it, the small fruited one, or is it this large fruited one, or anything in between? And so a lot of the time people are hesitant to utilize your genetic resources because they don't trust that you truly have what you think you have. And so here's another example of genetic profiling that helps us clarify the hybrids from the more pure species which would be found here. We have the same challenge in grape. As I mentioned, most of our grape are just called grape hybrid, Vitis hybrid, and it could be a vinifera, a European American hybrid, a French American hybrid, or it could be any number of species. And so these two grapes, Stout Seedless and Napka, are both called hybrid, yet one is 90% vinifera and the other is 10% vinifera. And so again, using genomic resources, I was able to piece together the ancestry of what a hybrid might be and kind of give it a number, from 0 to 100%. And what was interesting is when I compared bloom date, or the growing degree days, or how many heat units it needed, a particular accession needed to bloom, we saw this increasing trend with Vitis vinifera, right? So if you increase the percentage of Vitis vinifera hybrid, you see an increase in growing degree days, which again, it's kind of pulling together how much of that species really has an impact on phenological traits. And if you start to look at even the color distribution, so Vitis cinerea, right? Like you see distinctive blocks of what species is contributing to these phenological traits. We spent a significant amount of time, and nothing compared to what Europeans have done, looking at phenological traits over time in grapes, but this was our attempt, and to look at broad genetic diversity in Vitis species. But again, you see a lot of potential for bloom variation and for verism, right? That color change moment in grape. And this is really important for cold climates, where in New York State, we want to delay bloom or to delay bud break as long as possible, have an early bloom and early verism because we have such a short growing season. And so here's like just the distribution of these unique traits. So you can see already that there's a tight connection between, if you're early bud break, you're probably going to be early bloom. And so breaking that genetic linkage is kind of a challenge. But there are examples of early bud break or late bud break and early bloom. And not many, but there's at least genetic resources that we've profiled that researchers could pull into their program and explore more genetically. The same case for early bud break and early verism, or late bloom, early verism. And so we can look at now our collection is much more characterized, allowing others to have access to that. We really do have a unique climate in New York State. If you look at the map and the cold, or the climate distribution of the United States, right? So our California is quite similar to the production region in Italy, and this is where most of our grapes are grown. But unfortunately, we have a water issue, and so that's really driving production north and into regions like Minnesota or New York State, where things are not as well adapted to European grapes, but at least we have the climate or the water resources to better manage that. So what sets the limit for New York State is just cold adaptability. And we've been working with a plant physiologist, Jason Londo at Cornell University, to really understand the endodormancy and ecodormancy, right? The controls of what keeps a grape dormant, right? And what releases that dormancy. So it's not so much how cold hardy is something, how much cold can it handle, but it's that release of cold dormancy that's become really important that we characterize in our collection. Because what's happening is that our springs are becoming so volatile that our grapes and our cherries and our apples are leaving that dormancy phase and blooming, and then you're going to have a cold winter frost. So we're getting a lot of frost damage, which devastates our industries. So having characterized and understanding that in grape quite extensively, we're moving into tart cherry. So tart cherry and cherry production was really heavy in New York State, and all of that moved westward because of cold. And now because of drought, it's moving back eastward. And so this time, hopefully, we can be prepared with better genetic resources that are characterized for specific cold environments, right? So not knowing just how cold can they get. I mean, you can see some of these are cold hardy down to -20 Celsius, right? But you can see this quickly, how soon that they leave. This is a plot over time, right? So this would be October through March. And just how quickly a particular accession leaves cold dormancy is important, as that's what's critical for us. Finishing up with a tart cherry, we did a thorough evaluation over 6 years of tart cherry fruit quality. And again, our industry relies solely on a single cultivar, Montmorency. And so this horizontal dashed line shows where Montmorency fits in terms of the sugar content, the acid, the weight, the pH, the phenolic composition. And for most traits, it scores really low. So the U.S. could really benefit from just adopting, simply changing cultivars, right? And so that's especially true for Montmorency tends to bloom really early, and then you're just going to lose your crop. And this happens almost every other year in our northern climates where tart cherries are mostly produced. So all of that characterization, right, like feeds into distribution. So hopefully all of that effort in characterizing doesn't just die there with a publication, right? But it lives on so that researchers actually access and request material from us. And so this is just showing briefly our footprint, right? So this is heavily in the United States, over 100,000 items shipped, within the U.S. Obviously, we're limited because of plant quarantine, but we've had an impact almost on other major regions where apples, cherries, and grapes are grown. And so this is a matter of pride for us, and we want to build this up so that we're actually sharing more of what our unique resources and our unique collection holds with the rest of the world. Apple is by far our most popular crop, and in 2020 we saw a severe decrease due to COVID-19, and then an even more dramatic decrease because of our fire blight challenge. So we didn't want to distribute fire blight to anywhere in the US or in the world, so we really have restricted the distribution. And again, it's not just plants, but it's data that we share and we try to distribute with the world. And so we have a central database for all of our material, and maybe some of you have used, this is GRIN, the Genetic Resources Information Network. It's kind of clunky, it's kind of difficult to use, but it's there, it's transparent. And I wish other collections would kind of adopt similar type platforms, because it's really frustrating to read papers and they make novel discoveries and you can't find where is this thing held, what is it called, how can I get access to it? And so this is our central database for not only holding the unique characterization information, but making those requests as well. And just finishing with our distribution, this is some of the end products. These are some beautiful grape hybrids bred by Gallo Winery in the United States from our unique resources. And so you take some of our pretty inedible North American grapes and you hybridize and you work with them back crossing to Vitis vinifera, and you can develop some pretty beautiful products from them. Again, then these hold improved yield, environmental adaptation, disease resistance, and then there have been so many studies of inheritance and gene functions for countless traits from our collaborators. It's so important that we share what we have with the world, and so we share it with students through internships. We do open houses, public tours, just to get people excited, get the next generation interested in plant genetic resources. Here's just some of our intern highlights, studying melatonin, looking at more phenolics in apple, chemical analysis of Vitis vinifera, and trunk diseases in grapes. So they kind of work on any number of products. And a few acknowledgements from our team at the USDA and Cornell University, and I'll save questions for later. Thank you.
Thank you, Ben, for your exhaustive lecture, which addressed so many issues about the conservation, maintenance, and the vulnerability of such collections. The next speaker is not here, and she is Angelina Belai. She is an Albanian brilliant olive geneticist, and she is the curator of the World Olive Germoplasm Collection of Cordoba, Spain. He will be connected with us. I can see what happens. We must wait.
Good morning, buongiorno. No, posso non vedere. Non sé, non lo vedo. Buongiorno, good morning.
Who is speaking? Angelina?
Yes.
Okay,
good morning.
welcome.
Welcome. Can you see it? Buongiorno, professore.
We don't see you.
Okay.
We see the presentation. I don't know if it is enough. We keep going. Please.
Okay, let's go. Good morning. Buongiorno. Can you see the presentation well? Yeah, no? Okay. So I'm going to talk about olive germplasm collection, mainly our germplasm collection. But I'll go through the germplasm collections and the network of olive germplasm collections in the world as well. We do believe that olive germplasm collections are and should be a bridge between the past, the present, and the future of olive growing. I don't know what's the problem. Just can you see the next slide?
Not
okay.
Now, yes.
Okay. Sorry, I don't know what's the problem. It doesn't work very well. As you may know, and I'm sure that you all know, that most of olive cultivars are very traditional ones, adapted to that old olive growing system with very high, with very low density orchards, and they were picking by hands and so on. And most of, in olive, differently from any other fruit tree species like apple or grape, we do have very few olive cultivars that come from breeding programs and are adapted to the new changes of olive growing system. Most of the cultivars that we already have in olive are very ancient. In fact, in recent studies in many archaeological sites, there have been found stones and the other data that indicate that most of the cultivars that we already have in olive, they are centennial or probably millennium ones. And in any olive countries, Mediterranean or beyond Mediterranean areas, you'd find that most of the cultivars traditionally were found diffused around their original area of origin or diffusion. You have the example of Spain. You can see that the different colors represent different cultivars, but that could be the same image for all Mediterranean countries. In any area, in any region, you'd find local and traditional cultivars typical of the area. that probably indicate a possible local selection of the cultivars, which was followed with the distribution of the cultivars from the East Mediterranean area, where they were selected around both the sides of Mediterranean south and north. In addition, another characteristic of olive cultivars, which I think it's also common also in other fruit tree species like grape or probably even apple, is the fact that very generic naming has been used to name the cultivars. Normally, cultivars are named according to their area of origin, shape, size, color, and that has led to the presence of different denominations or different namings for the same cultivar, which means synonymy cases, or the same naming or denomination for different cultivars. And that has led to the presence of homonyms. This is the reason that we have a huge number of cultivars. We have a huge genetic patrimony in olive, and we are very lucky to have it. And you can see that the number of the cultivars estimated in the world is more than 2,000 according to FAO data. And according to the IOC data, around 1,200 cultivars have been catalogued in germplant collections of around 54 countries. But these cultivars have more than 3 different names, probably because of the general criteria of naming that I mentioned before. This structure of olive cultivars and the olive orchards in general is an old one. Olive growing is living a new area of changes, and nowadays most of the olive orchards are mechanized. They are harvesting in mechanized. We have more and more the introduction of new olive growing system with high-density orchards, hedgerow orchards, and there is a globalization of the industry of propagation, greenhouses, and the cultivars that are propagating are almost the same in the whole world. All these changes have led to as olive cultivars, as I said, they were not adapted to this kind of olive growing, and only a handful of them can fulfill the needs of this olive growing industry. I mean, cultivars that can be harvesting mechanically, they can be adapted to high density orchards and so on. That has led to the demand and dissemination and propagation of the most interesting cultivars, which are a handful. This fact, together with the globalization of the markets and the need for breeding of new cultivars, is leading to the low cultivar diversification in olive orchards. This is the example of the production of plants in olive nurseries in Spain and in Andalusia, which is the most olive growing region in Spain and in the world, probably. And you can see that most of the cultivars that are propagating are only 3 or 4, and the rest of the cultivars represent a very few percentages. The case of Spain, at national level, we have Arbequina, Picual, and Hojiblanca, which is the majority, and the rest is around 5%. And in the case of Andalusia, we have Arbequina, Hojiblanca, and Picual, and the rest represent only the 8% of the plants that are being propagated. But it's not only in Spain that scarce cultivar diversity in the field. In the case of Italy, most of the olive orchards, the new ones, they have Coratina, Frantoio, Lecchino, Peranzana. Portugal, Greece, Morocco, and Croatia are also examples where main cultivars are being propagated and planted, but the local ones are playing a very local game and are not found so easily in olive orchards. This scarce cultivar diversity is leading to a situation of genetic erosion, which is very dangerous because that is leading us to the disappearance of local cultivars, which would be very useful for any new phytosanitary threats like the case of Xylella in olive, unforeseen climate changes as well, because local cultivars come from very different areas and they are growing in very harsh conditions in many olive growing countries. But they can also give a new additional value to the market, because many of them may have sensorial qualities that makes it different and unique, especially for monovarietal olive oils. And we need to have a huge diversity and to fight against the genetic erosion for breeding, because if you have a vast genetic base, that it's going to be much better for breeding. So knowledge and conservation of genetic resources is of paramount importance, and that's something that in olive, which is a clonally propagated species, is performed in ex situ fields by ex situ conservation in germplant collections. In olive, we account for around 100 olive collections distributed in 54 different countries. And many of them have been joined in the network of International Olive Oil Council, IOC. And in fact, nowadays, this network of germplant collection accounts for 24. Well, lately, Georgia is also included, and some new countries, maybe around 26 different countries. And this national this international network of IOC has permitted the creation of national banks of reference with autochthonous healthy representative material from each country, and has led to the establishment of international banks of reference. There are 4 nowadays. The latest one was recognized only a few days ago in San Juan, Argentina. But the first one was the collection of Cordova in Spain. Then 2 other international collections were established in Marrakesh, Morocco, and Izmir in Turkey. The awareness of the importance of conservation, maintenance, and safeguard of olive genetic resources led to the establishment in the 70s of the first World Olive Germplant Collection, the first international effort to maintain, preserve, and evaluate olive cultivars at international level. It was an initiative of FAO in collaboration with the National Institute of Agriculture in Spain with the support of IOCs. The objective of this international collection is the same as in any other collection: to preserve and evaluate in the collection all plant material considered to be different on regional, national, and world level, to document and use this diversity for selection of interesting cultivars to be used in comparative trials and genetic breedings as genitors. Our international germplant collection is located in Cordova. Here you have our coordinates and some of our facilities. Nowadays, in terms of maintenance, we are maintaining in the field around 1,200 accessions from 29 different countries in around 13 hectares. All our collection is under irrigation, and we also have a backup collection in another center of our regional institute. We belong to IFAPA. IFAPA is a regional institute in Andalusia, aimed to agriculture, fishery, and ecological production, and also to transfer of technology and outreach activities, but at local level in Andalusia. Actually, at the backup collection in Mengibar, Jaén, which is around 70-80 kilometers from here, we maintain around 900 accessions, 2 trees per each accession, while in Cordova, we are maintaining around 3 trees per each accession. Here you have a map of the accession that we are maintaining in our collection. You can see that we have accessions from Mexico to China. We have from obviously most of our material is from Mediterranean olive growing countries and beyond, like the case of Iran. And we are working and we are trying to include countries that we lack material, like is the case of Libya. And in the down part of the slide, you can see a view area of our collection and how it is distributed, and it is going bigger. Most of the plant material that we have from abroad comes from the network of olive collection coordinated by IOC, but also from the relationship with different olive growing countries that have been established during the 50 years of existence of our collection. But we are also trying to enrich our collection through international collaboration, because this is an everlasting task. You can never consider that your work to access plant material is finished in germ plant collection. So we have had some prospecting survives in Albania, Croatia, Uruguay, and Bosnia. But we are also working with olive cultivars from local cultivars from other national research centers, in collaboration with other national research centers, but also in Andalusia. And here you can see some of the prospecting survives that we are surveys that we are performing in collaboration with our institution like IVIA in Valencia, IRTA in Catalonia, and the other centers in La Rioja and northern Spain. As in any other collection, we need to, all the information that has to do with the accessions is maintained in a register book. Passport data are very important. We have to be very careful to update the data. And nowadays we are working, I completely agree with a colleague that talked about before about having databases to be more or less uniform or to have the same criteria. We are working on the establishment of a database here with all the FAPA germ plant collection, but in collaboration with the network of germ plant collections here in Spain, where our collection belongs, because we also are in charge of the national collection of Spain. And a very important work is the genetic characterization, identification, and authentication of our cultivars, and we have dedicated a lot of efforts on that. And in fact, the story of the identification of our collection could be the story of the use of different descriptors in olive. At the beginning, we have been working with morphological markers. That has been a huge work done by the University of Cordova in collaboration with our collection. Then we used molecular markers, FLP and rabbits, and we passed and used SSRs. I still remember my first time working with microsatellites at the lab of Professor Testolin, and I can never find the words to thank him, because I learned how to use and how to work with those markers with him. And we have used DART markers, and lately we are working with EST SNP markers. Nowadays, we are using 96 EST SNP markers genotyped by FluidGene that were selected from a previous work that we did in our collection with more than 1,000 EST SNP markers. These markers have been selected for their discrimination capacity, their amplification accuracy. They are very accurate as far as as their identification. This is permitting us to have a practical, reliable, and cost-effective technique. You have to imagine that we have more than 1,200 accessions with 3 trees per each accession. Then we are also trying to identify the backup collection. So to fingerprint and to identify all these plant material, you need to have something which is reliable, but also cost-effective. And this number of SNPs is permitting us to meet all the management needs of our collection, which is growing every day. In our case, in a very recent work that we did in the collection, we identified not only plant material that we already had in the collection, but we tried to identify a priori the plant material that we had in different propagation facilities in our collection, because we wanted to know if they were different or the same that the plant material we had in our collection, in order to avoid as much as possible the duplicates or the redundancies. And the identification with the 96 EST SNPs permitted us to identify 668 different cultivars, which comes from 1,272 accessions. 520 of them were already planted in the field, and 148 belong to the new plant material that we had collected in the last years, which means that we still need to continue with the prospecting surveys, and we still need to go there and to try to find the plant material that we do not have yet in our collection. We found, and it was a really nice surprise, that even in Andalusia, where a huge work of prospecting surveys have been done in in the previous century, in the last century, in the 20th century, we still have uncatalogued cultivars that were not included. We find very local cultivars that were maintained in very specific areas of Andalusia, and here you have some examples. And we also found some cases where we have found bibliographic references of local cultivars that we didn't have in our collection, and one of them was the cultivar Tacciuno. You can see that it was a publication of the 19th century, where the name of Tacciuno was mentioned in different parts of Cordova, the province where we are living and where we have the collection, but we didn't have it in our collection, and through the collaboration with farmers and different greenhouses, we were able to find that cultivar, to identify that it resulted to be totally different from the rest of our germ plant collection. But we also, as you can see, as we are talking about more than 1,200 accessions, and the number of cultivars was around 670 different cultivars, which means that we found a huge level of redundant accessions, which were grouped in 204 different genotypes or different groups in this case. And the kind of redundancies that we found were, some of them were redundant from prospecting surveys, others would be some mistakes from either from the donor collections or during the different phases of introduction in our collection. And in some cases we were also other types of redundancies. But the most important ones were synonymies, which means different names for the same cultivars. We found 510 different synonymy cases, which belong to 140 different cultivars. And we are continuing this study with other genetic relationships and parentage between cultivars, but I'll focus my study more on the identification, because it is still a huge work to be done in olive, and that's why I'll focus my talk on it. You can see that most of the redundancies were synonymies, but the fact that they belong to a low number of cultivars may probably indicate that only the most important and probably the most interesting cultivars and the most ancient ones were distributed within the same country, in neighboring countries, but in some cases even in far distant countries. This is probably due to the fact that from the original area, the Eastern Mediterranean, where it is supposed that it is well known that it is domesticated olive, the farmers that they domesticated from the wild olive woods, they propagated them, and the outstanding genotypes. And that moment, the vegetative propagation, and especially the grafting, was a very important moment probably in the history of olive domestication and diffusion, because it permitted to distribute the cultivars from one area to the other area and so on. And probably in that distribution from the area of domestication through the south and the western and the northern part of Mediterranean through different civilizations like Phoenician, Greek, Romans, and Arabics as well, cultivars were receiving different names, probably for facilities of language, or also because they had some different characteristics like the fruit size, the color, and anything that called the attention of the farmers. And this is the case, for example, of Frantoio, which is a well-known cultivar, and our colleagues from Italy, they know much better than me this cultivar. Frantoio is the main olive cultivars in Italy, and we found that in the plant material that we have in our collection, that we had synonyms of cultivar Frantoio all around the country, in the islands, but we also found some synonyms in the Eastern Mediterranean area. It is very difficult to decipher the migration direction of all cultivars, and in this case, being so important, we cannot exclude the fact that the Romans, who knew the cultivar and knew how important it was, may have distributed the cultivars in the Eastern Mediterranean, although we cannot ensure, as I said, the direction of migration. It is also found in California under the name of oblonga, so you can see how the same cultivar receives different names in different parts of the country, nearby country like the case of Cailletier in France, but also far olive growing countries like Lebanon and Syria in this case. Another example of synonyms in neighboring but also different countries is safrawi. Safrawi means yellow in Arabic, and we found 17 accessions that belong to that cultivar. Most of them were from the Eastern Mediterranean area. We also found olive trees from very ancient orchards in Jordan and Lebanon, which belong to that cultivar, in Turkey as well, which can which can mean that this cultivar is very ancient and was very well known there in this area. You can see that from Syria, it was distributed in the whole area, and then you can see that it was almost expanded through the coastal area of Turkey. In all these parts, receiving a different name, and then in the islands of Greece, where it is called Trovolia, in Albania, where it is called Marci, in Italy, it is known as Grossolona, but I know that there is another synonym there, but we do not have it in our collection. If I'm not wrong, it is called Sant'Agostino. And when he arrived in Spain, in the islands, Balearic Islands, and the northeastern Spain, it was named like Cirujal, which means plum, or plum shape in Spanish. That's an amazing example how the same cultivar was distributed around all Mediterranean area, receiving different names. But we have it also in our neighboring countries, neighboring areas. One case that called my attention was the case of Ulyri tiranus, which means the white olive from Tirana. Tirana is the capital of Albania, my country. And we found synonymous, different names of the same cultivar in our country, but we found this cultivar with the name Žutica, which means yellow in Montenegro, with the name Bjelica, which means white in Croatian, and like Majatica di Ferrandina, with the name Majatica di Ferrandina in Italy. In the case of Croatia and Albania, you can see that it's directly a translation of the name in a different language. Probably it was very difficult to say Ulyri Bard in Croatian, so they called it like Bjelica, but that means that they knew that it had that name. As I said, it's difficult to know the migration if it came from one side to the other, but the fact is that probably they had the know-how of that cultivar, and they knew that it was important for something, and they renamed it. The same case can be said for Bianchera, which is a cultivar from, if I'm not wrong, from Venezia Friuli region, and Bianchera, it is known as Istarska Bielica or Plementa Bielica in Croatia, or Istarska Bielica in Slovenia. Again, it is the same the same name. Bianchera means white in Italian, and in Croatian and Slovenian it means the white olive from Istria. Istria is very nearby Italy, so it's very that can give us an idea of the interchange of plant material and information between neighboring, but also between very far away olive growing countries. To me, that also means that olive genetic resources are a human patrimony. I mean, they do not belong to any particular country, and borders in agriculture are really artificial. We have always been interchanging plant material and information in olive, and that's, a lesson for us, the scientists, because farmers have done it all during the centuries of cultivation, and we should do between us as well. This is another nice example of that case. I'll go very quickly through it. This is known as Grossa di Spagna in Italy, but in Greece and in Turkey they know it like, or they call it Gaidorelia and Esceitini, which means the same, big donkey olive, because the fruit of that cultivar is really big, and it has got another name in Dužica in Montenegro. We also found a lot of cases of homonymies in our collection, and again we found that it was the same genetic criteria was used in olive countries. Olive cultivars were named according to highlighting traits like the color of the fruits or the leaves. You can see here different denominations or different names of cultivars in different languages. I talked before about the white and the yellows. It was the case of Safrawi, and Safrawi is found with different names in every different country. The green or color is also especially for cultivars which are late ripening cultivars. It is called verde verdale, which means green. In different
Angelina,
languages.
sorry.
Yes.
You have 2 spare minutes. I saw you have 73 slides, so I'm afraid.
I'm going quickly. No, I'm going to do it.
Okay.
Sorry, Professor. We have homonymy cases again here. That the identification of cultivars have permitted us to the correct identification to do an ambiguous agronomic evaluation, which is a complex, multi-annual, and costly task in olive. We have evaluated for different traits like vigor, resistant to verticillium. We are working on Xylella fastidiosa, searching for resistance and tolerance sources. We have found some interesting cultivars and some interesting results, but it's still very early to talk about it. We are working both in Italy and in Spain in this case, because we have this disease even in Spain. We are working also on quality traits like tocopherols, phenols, and other traits. We are also working on sensorial analysis, and we organize outreach activities like open panel day tests for olive growing sector, industry, and for the citizens. Here you have some examples of it. And this is an example of interesting traditional olive cultivars with good sensorial traits. And, but we are aware that in order to suggest cultivars, we need to do agronomical evaluations in different comparative trials, because with only 3 trees per cultivar that we are maintaining in our collection, we can give only a general idea of the diversity that we have. And here you have different examples of comparative trials that we are performing. And they indicate that there is a genotype and environment interaction in some traits. We are also using our genetic diversity for breeding, and you have here the example of some of the crosses, and 6 new olive cultivars resistant to verticillium or adapted to high density orchards have been obtained from their crosses. We are working
Angelina,
on,
sorry, you must go to the end.
Yes, and we are also to finish it, we consider that the agronomical and technical evaluation permit us to evaluate many cultivars in the same environment, give us a general view on agronomic diversity. It is a diversity source for breeding. It contributes to diversify the varietal offer in olive orchards and to resolve problems, actual and future problems in olive. That's why we consider that our olive germ plant collections are and should be a bridge between the past, the present, and the future of olive groves. We owe it to future generations. And thank you so much for your attention.
Thank you, Angelina, for your topic on olive. Most of people didn't know so many problems that has the conservation of such a germplasm. We move to the next speaker, who is Matthew Ordage, Matt for Friends, and he is a scientist at the Department of Crop Science in Reading, UK. He is also the curator of the National Fruit Collection at the same university. The topic is the UK National Fruit Collection Experience of Collaboration at a Local and International Scale. Please, Matt.
Okay. Thank you, Raphael, and thank you firstly to Professor Garino and the organising committee for inviting me here and helping me get here yesterday as well. I wanted to really just reflect in my presentation. A number of the other speakers have already talked about the issues of collaboration and the importance of collaboration in germplasm management and what we do as a community. I thought it was an interesting component that will be relevant to the project here as well. So I just wanted to reflect on a few things that we've been involved in the UK collection, and hopefully there might be some useful parallels that people can identify with. Firstly, I just wanted to give a brief. I'll try and keep looking forwards and using the pointer on here, perhaps, because else I'll turn away from the microphone. I just wanted to give a brief background into UK fruit production. Again, just really to draw the sort of parallels and consider whether or not there are differences in the sort of context that help us understand potential for different types of conservation strategy and so on. And there's two things really that I wanted to highlight on this slide. Firstly, down in the map, these are government statistics, and the nature of government in the UK is that some of our things are done across the whole of the UK, some of the things are done in England only, some of the things are done in England and Wales. It depends on which department you're working with. In this instance, these statistics, I think, both just come from England and Wales, so I haven't forgotten about Scotland, but they're not included in the figures, and actually they're not particularly relevant in this instance. But the thing I really wanted to highlight here is that the map, I've lost my pointer, sorry. The map down, yes, it is showing. The map down on the bottom right-hand corner is a map of the distribution of commercial orchards in England and Wales. And it hopefully highlights, it's not incredibly clear, but it hopefully highlights this dark colour in the key is over 40%. And I think the figure down here in Kent is about 43% of the commercial orchards in the UK are all situated down in this bottom corner. There's another approximately 30-something% are associated over here. And certainly in the world of apple production, there's a general split between these two areas in that most of the dessert apple production is produced down here and most of this is cider production, partly because there's a lot more rain. It's a wetter area of the country and they tend to suffer from one or two more diseases that you can get away with if you're making cider. But actually the key point is that a lot of production is focused in a relatively small number of areas. The other statistic that I wanted to point to was this is just a chart of home fruit production relative to import-export. the key message here really is just to highlight that the UK, in the UK, in terms of apple production, dessert and culinary apple production, we produce about 40% of the apples that we consume in the country. We produce almost all of our cider apples because it's a specialist crop and not many people grow cider apples, apart from the other significant cider growing countries, and I suspect they grow their own as well. Less so for pears, plums and cherries. We're down in the region of 10-15% of consumption is produced in the UK. That means two things, I think, in my mind. It doesn't necessarily mean the first, but it is a reflection of, it is a fact in the first, that a lot of our production is on a relatively modern commercial scale. We produce a lot of relatively intensive fruit, the fruit that is produced. We produce a range of international cultivars, so increasingly over the years, I haven't put the statistic in here, but increasingly the UK produces a lot of Gala, a lot of Braeburn, a number of other international cultivars from international breeding programs. We still produce Cox's Orange Pippin, but we produce a relatively, as with many countries, a relatively small amount of diversity in the main commercial production, and a lot of our consumption is based on international export, which will again feed itself down to big international cultivars, the things that people are exporting. I just wanted to then talk about the collections, and the background to our collection is a thing called the what was called the UK National Fruit Trials. It was formally established in 1922, so we were talking about the 100th anniversary last year. Some of the collection actually dates prior to that. And the fruit trials itself was a ministry-funded activity. The objective of the fruit trials was to test new and diverse cultivars from all around the world, actually, with the view of identifying things that were useful for the UK growers or would be useful for the UK growers going forwards. The trial was first established actually somewhere else, but it was moved to where we maintain the collection now at Brogdale Farm in 1952 as part of the establishment of a ministry-funded horticultural testing station. And this is just this is an image from the 70s actually, but this is an image of the bases of the station and an older image of our apple collection. The site is based right in the middle of the prime apple growing part of the country, so it is in the middle of commercial, where the commercial producers are, and this is just an image of the farm itself. Surrounded in red dots is the farm that the collection stands on. This is a slightly old image actually, and our apple collection, for instance, was cited here. We've since repropagated it and condensed it in size but not content, and it largely sits in this field here. It expands into where the old pears used to be. But you can't really see on this image because I've shrunk it and the quality is probably not good enough, but it is surrounded by commercial apple orchards, so it is very much in an area that is growing the fruit for production in the UK. What came out of the National Fruit Trials was the development of the collection, and so the collection we hold was not really built in the terms of gene banking as a gene bank. I suppose it depends what you consider a gene bank to be, but it was built as a collection of cultivars that were of interest to commercial users. It certainly wasn't built for the purposes of breeding, and if I had any criticisms of the collection, it is a bit cultivar rich, and it's not necessarily, we don't have a lot of wild collected Sieversii and so on in the collection. There's a lot of named cultivars in there. But over the years, it's transitioned, and it is now very much maintained as a field gene bank. Part of that is political and is to do with the reason why we now maintain genetic diversity, and a lot of that comes down to things like the international treaty and the government commitments that we have to these international, high-level international agreements. The basis of the collection, we hold about 3,500 of accessions now at Brogdale, largely 2 trees of each accession. Seems to be a reasonable sort of standard for a lot of gene banks. I haven't put the numbers in here actually, but these are just some of our images off our website. The bigger part of the collection is apple. We have about 2,200 accessions of apple in the collection. We hold about 550 accessions of pear, mostly communists. We have 1 or 2 Asian pears, but it's a small number. We have about 350 accessions of plum across a range of the different plum types, but mostly European plum. And we have about 400 accessions of cherry, mostly sweet cherry. We have some sour cherry, tart cherry, as in the States, and we have a few hybrids, but the majority of it is based on the things that are most relevant to UK production, and we only produce sweet cherries in the UK these days. Just to run through a quick sort of summary of what we do in terms of curation, as with many germplasm collections, the sort of underlying basis of a lot of what's in the collection is verification of trueness to type. And a lot of that work was done, I confess, before my involvement as curator. But there's been a significant amount of work done comparing back to these classic old, this is an image from the Heritage Pomona, and confirming the trueness. I've lost the marker again, sorry. I'll point at it. If I can hit it, here. The Heritage Pomona, and we have a whole set of descriptive information that confirms that our things are what we believe them to be. We have a program, relatively small program of characterization. Here we are, thank you. We collect characterization data in line with international standards. This, I'm sorry, hasn't replicated very well, I don't think. It's marginally visible, but it's an SSR fingerprint. We use SSR fingerprinting partly in the maintenance of the collection, partly to check trees in, and we've done some bits of diversity study, and I'll talk a bit more about that in a moment. We then run a database, a publicly available database on the collection, and the objective of the database is to house all of the information that comes out of these curational programs and make it available to people. It doesn't show here very well, but it is a searchable database. You can search for characteristics, and you can search for accession numbers and names and find all the information that we have online. We did have a program of cryopreservation. We put an end to it some years ago, really for purposes of funding. The government funding was being reduced. It was the first thing that we could remove at no expense to the main collection. So I think we saw it very much as an insurance policy, and it was less critical than the fundamental maintenance of the collection. So when we had to reduce the cost of running the collection, the first thing that went was the cryopreservation. And I think it is slightly notable that there isn't yet, I know there's some discussion about it, but there isn't yet an equivalent to Svalbard for the clonal tree crops. And there is discussion out there, I understand, on whether or not there might be an international cryopreservation bank being developed. The fundamentals of all that we do really are about making the collection available, and this is just an image at the moment. My colleague, our horticultural curator, is down at Brogdale collecting graftwood. We're in the process of trying to send some to Ben, for instance, as a complete coincidence that I found out the other day. But we supply graftwood out from the collection on an annual basis, twice a year actually. We supply budwood and graftwood, and we do that in line with the treaty commitments and or otherwise if it's not relevant to research, breeding and training. I just really then wanted to talk a bit about the collaboration that we've been involved in and my sort of experiences. And a lot of that comes down to ECPGR, the European Cooperative Programme on Plant Genetic Resources. I'm sorry, I didn't expand it because I suspect many people will know the acronym. And we're involved in both the Malus Pyrus Working Group and the Prunus working group. I haven't put the Vitis working group here, which I am actually involved in technically, although we don't actually do very much in Vitis because we have a very small collection of Vitis, and other people in Europe have much more to do with Vitis than we do. We feed everything we have into Eurisco. All of our listings are in Eurisco as the European database, which in turn forms into Genesis, I think, and therefore links up with GRIN Global and the other international databases. One of the things that I would sort of like to flag up, and a small project we've got that's supposed to be starting this year actually with ECPGR, is part of the objective is to try and have a quick consideration as to what's in Eurisco from various different countries. And increasingly I find myself speaking to colleagues in ECPGR who say, we have a collection that is in the public domain, it's effectively a national collection, but for some reasons of national politics or reporting, it's not listed in Eurisco. And I sense there's a lot of important material out there that is really public domain, nationally run collections that are not currently listed in Eurisco. I'm not going to resolve that in this project, but we will open a window on that, I think, and I think it's certainly something that people need to think about. And I don't know the politics behind it. I suspect there's various things to do with regionality and what gets recognised as national in terms of Eurisco listing, but it seems to me that there's material missing from that system all around Europe, I would say. We've been involved in a couple of projects, certainly in the Malus Pyrus network, and I'm a bit limited what I can point to these because they haven't been written up yet properly, but two projects, one EcoHIS-PY, which was a Pyrus project, and a second project called Pomefruit CNE, and that's characterization and evaluation. The two objectives or there's a running theme through a number of the ECPGR projects that have been run in the last few years that is to do with trying to identify, partly as an example, subsets of local cultivars from a range of different countries and generating some coordinated characterization data and usually fingerprint data. And that's exactly what's happened in EcoHIS-PY for pears, and there's a small booklet being produced at the moment that will describe those. The other component of the Pomefruit CNE projects were two things. One was up here that we re-evaluated and republished as an update to the standard characterization and evaluation descriptors for both apple and pear. And the second thing was to do with aligning SSR fingerprint data across collections across Europe, and I'll talk a bit more about that when I come further down, but this is just a presentation on pear that Caroline Denance presented, I think, at UCARPIA in Prague a couple of years ago. The Prunus group, similarly, have had, I didn't mention, sorry, on my earlier slide, Daniela Giovannini, who I don't think is here, but many of you will know, heads the Prunus group. The Prunus group have done quite a lot of interesting work over the years. At PruneDoc here, I think possibly came before EcoHIS-PY, but followed exactly the same model of identifying a set of example local cultivars from a range of different countries, characterizing them, bringing the data together, and doing some initial genetic fingerprinting work as a sort of as an example of working together in a coordinated way in this sort of area. We then had a project. I wasn't actually involved in PruneDoc, but I was involved in a parallel project, EU Cherry, which did a very similar thing for cherry. Again, it's the same model. We brought together a set of examples, we fingerprinted them, we characterized them. We also developed the passport descriptors. One of the things with ECPGR is it's a fantastic network for bringing people together. There's not a lot of money in it. So projects tend to be relatively focused on building on what we're already doing. I think it's a hugely valuable network, but there's a limit to starting any significant new work in it. So a lot of these projects, we tend to use the same model for repeated sort of things. But it does get people together, I think, and that's highly valuable. The other output from EU Cherry was a genetic screen of a series of material that's also linked to a cost program. This is just a couple of shots from Teresa Baranesh and co.'s paper. The first image is just a pie chart of the unique accessions. They were already screened for things that we believed to be unique, so it wasn't hugely surprising that we found a lot of unique material. And the duplicated in twos, I can't remember the exact numbers, but it's 2s, 3s, 5s and 7s or something. The things that there were multiples of anyway. And then we carried out a basic genetic diversity screen of some of that material. I don't think it was incredibly clear and sort of revealing, but it was a start, and it was a point of reference for looking at diversity in cherry. We then tried to build on that with another project that brought together some of the prune doc data and some of the EU cherry data, and we had a project called Prunus Alignment. This I did actually act as the project leader on, and one of the things we did from that was we built an aligned set of SSR fingerprint data for cherries from using the national data from Italy, Sweden, France, Switzerland, and the UK. I think that's all of us. And we built a reasonable data set that we could do comparisons between collections, which is something that ECPGR had been talking about for 10, 15 years, but nobody had ever actually got around to doing. So it was a good starting point, and we made a lot of useful comparisons. We made a recommendation of a standard set of plum primers, again to try and keep people working in a coordinated way that could be compared at a later date. And we did an initial screen of diversity and a study on the diversity within the plum material held in local accessions in a series of different countries. The other element of international collaboration that certainly that we've been involved in has been through European funded projects, and we were involved in the Breedomics project. The initial point of the Breedomics project was to try and look again at diversity across different countries, and this is in apple, and we focused on again identifying local holdings of things that had arisen in each country. So I'll raise a query of that in a moment, but there was at least some sort of partitioning of diversity that could be identified across regions of Europe if you look at the material that originates in each of those countries. And like I say, I'll come back to that in a moment. One of the interesting sort of sidelines that came out of that work was there's an image here from a study led by Helen Moranti and the team at INRA, where we started looking at parentage, and Ben highlighted there's a lot of parentage relationships in these collections. This was a method to look at errors if one assumes everything to potentially be a parent or offspring of everything else, and then counts how many genotyping errors would arise if that was the case. You can then try and identify those with a lot of things have a lot of errors and clearly aren't parent-offspring relationships, but there's a set of things that came up here with extremely low error rates, and we determined all of these to be genuine identified parent-offspring relationships. That then developed into another bit of a sort of sideline in some ways, where certainly from and it might be a UK specific sort of interest, but ultimately we identified the parentage of Cox's Orange Pippin, which is a big international cultivar, and the parentage had not been known or it had been incorrectly documented for many years. But that came out of an extra piece of work that Scholl-Erik and the team presented, I think, at the Rosacea's conference in China, I think, and that was finalised by a paper led by Nick Howard that was looking at triploid pedigrees. I won't go into the detail of it, but it was an interesting thing that span out of these initial data and collaborative efforts. The last thing I want to talk about is to do with local collaboration, and really one of the interesting things we've been involved in recently has been to do with UK local fruit enthusiast groups. There's been a whole set of groups developed over the last 20, 30 years or so in regional groups. They're largely amateur groups, but a lot of them behave in a very professional manner. And they've developed collections, they've collected material, they've identified things, they've done all sorts of work, all on a morphological basis in the past. And what came together a few years ago was a chap called Peter Laws was developing a website called Fruit ID, and his objective was to try and support some of these local groups with the ability to store data and identify their material through web-based sort of systems. Excuse me. But what actually ended up coming out was there was an interest in doing DNA fingerprinting, and NIAB, EMR, East Malling Research, as many people will recognise them, were offering a DNA fingerprinting service. And what Peter really did was bring the groups together to commission that fingerprinting service in a number that made it economically viable. The data they were comparing to was on our national fruit collection. All of those, there was a first data set generated at NIAB EMR, but we share all of our data with them. And they fingerprinted a whole set of material from these local collections and some other material that was included alongside it from private individuals and various other findings. The original objective, I can remember the first conversation I had with Peter, and his concern was whether or not he could bring enough of the groups together to run a 96-well plate, because his understanding was that the economics would drop significantly in price if they could get 96 samples together from amongst these groups to try and put one whole plate together, and then they could afford the reduced price. I published a paper last year, and at that point they'd analysed 3,373. I think they're now up to about 6,000 samples. It expanded hugely when the technology became available to people. And the study that we carried out on this material, and I thank Raphael actually for some advice on how to deal with some of the data in this. The first thing I suppose we identified was that, not hugely unsurprisingly, about 2,000 of these 3,000 things were matched to something in the National Fruit Collection. And a lot of those were sent in for the purposes of querying things that people weren't sure whether they were something different or not. So they weren't all believed to be something else necessarily. But actually what surprised me, amazed me really actually, was that about 1,200 of them, 1,200 were not matched to the National Fruit Collection. And of those, there were about 982 unique profiles. So apples, this is a study on apples, sorry, apples that were not held in our collection and were held by various people around the UK. And we wanted to try and do a quick sort of diversity study on this. This is only using 12 SSR markers. There's not a huge amount of information in there. But I got, and I'm still a little bit unsure as to how we understand this really, but we tried to run a diversity study, as many people have done in similar sort of attempts. I generated, this is the main figure from the paper, it's a principal component coordinate analysis. The amount of variation it explains is very low. It doesn't explain very much at all, and I think that's probably one of the problems in it. But actually, the two components here, the white triangles are the National Fruit Collection holdings, and the grey squares are all of the local cultivars, and they just sat squarely on top of each other. I was hoping, naively, that we would have some nice outgroup that as a curator I could say, right, we have to bring those into the collection, and that would make my job easy. It just didn't happen for us. So I think there is a challenge out there in identifying the value in some of this local material, and it might be that a lot of these come back to, we talked about first-degree relationships in some of these fruit. Many of these will be seedlings from established cultivars. We also have a big international collection of 2,000 cultivars, and we represent quite a lot of diversity. So I don't know whether that's another issue of how we find where the specific value, at least at a genetic level, in some of this local material is, but it's not straightforward, I've found. One of the other things that came out of that, though, was that we had all of these new findings and people valued them, so somebody needed to do something with them. So we developed a thing called the Register of Local Cultivars to just try and get them documented. And we commissioned an expert panel. There's a picture down at the bottom of me talking to them in one of our meeting rooms. We've hosted the meetings at Reading. And we went through a process of allowing people to name and get these things documented and written down somewhere. At the time of putting this together, I think we've possibly got a few more, but there's currently a document online with, I think there are 310 apples that have gone through a naming process. If they are suggested to be an old cultivar, they have to give evidence as to why they believe it to be true, and it has to be strong enough to get past a whole set of experts in the UK for our own purposes. But we've got these things named. A number of them, I won't go into detail on these because I'm running a bit short on time, but a number of them, interestingly, are out there in commercial nurseries at a relatively low level, but Don's Delight is a seedling apple that's gone through the Register of Local Cultivars. Christmas Pippin is another one. These are seedling apples that have been identified as valuable and put into the nursery trade. Frank Matthews is a big nursery that propagates for home growers all around the UK. Macon is a Welsh cultivar that's, again, is available from nurseries in the UK. It's a sport of another Welsh cultivar, actually. And this is a cultivar called the Doddin. And all of these have interesting characteristics, sufficiently interesting that the nurserymen are putting them in their catalogues anyway. So there is value in them, even if the genetic diversity is difficult to determine. I just wanted to mention briefly in situ conservation, and my experience in the UK is that where we come closest to in situ conservation tends to be what I would consider ex situ conservation, but at an different institutional level. So there are collections, in my mind, of trees planted by the RHS, the National Trust at they manage a whole set of old properties and so on. But it's questionable as to whether they're there for farming or whether they're for collection purposes. And I think that's an interesting component in the fruit tree world, that the nature of our collections is that many of what I would consider to be ex situ, others might be considered to be in situ. I think it's a very grey area as to whether you're in situ or ex situ in the field gene bank. And the last thing I really wanted to just talk about was to do with the bringing together of this SSR data. There's been a whole set of work, largely led by the team at INRA. Charlotte Durrell and Caroline Denance has done all the really hard work on it. But we've generated a big database of what are called MUNC, Malus Unique Genotype Codes, about 30,000 samples aligned, with about 10,000 unique codes in that from a whole series of collections across Europe, and a similar but smaller effort on pear, and the publication's not out on Apple, so I've highlighted the pear poster again. And I just wanted, if I've got 1 minute left, to highlight two immediate examples. One of them comes back to Ben, actually, again. A thing called Sherrington Norman we have in the UK. We have it in the National Fruit Collection. We had denamed it because we had it under a different name that we didn't believe it was right, but we didn't know what it was. A number of the local groups have got the same thing. The best name they had is Sherrington Norman, and it's in the USDA collection as Sherrington Norman, which we need to talk about at some point. It was supplied from the UK in 1949, I think, from your database. It's been identified to match a whole set of holdings in France, where we believe it probably comes from. They've got 10, 12, 15 different names for it, but I think they're centering on possibly Panettiere as the most likely probable candidate. But we've been able to identify this as an unknown cider apple in the UK and hopefully give a name to it. And the last one is another example, which is, again, slightly fascinating, that this is an apple that was entered into the system. There are three, sorry, you can't read this, but there are 3 trees at an old blacksmith's cottage in Herefordshire, 3 matching trees. The only identification within the whole of this European database is one accession called Pipendorf Faux, with Mark Latour in Belgium, which is obviously not golden pippin, but he doesn't know what it is. I haven't spoken to him properly. And the only other holding is an accession called Citronable in Denmark that came out of a private collection in Denmark. So we don't know what this is. It will get resolved at some point, but it is a great way of being able to bring together these distant things. There's 3 trees in the UK, 1 in Denmark and 1 in Belgium that we know of. Nobody would have brought those together without this sort of work. So it's an interesting sort of area. There's a lot of people involved in it. I haven't got time to mention them all. And I'll bring that to an end. Thank you.
Thank you, Matt, for your appreciated lecture. I appreciated especially your effort to make harmonization of different fingerprinting from different collections. We have, I think, a few minutes for discussion. If there is any question, please, I would suggest to come here to have a microphone. Well, I start a question for Kent. I think in the international treaty there is an important philosophy which is, you call it equitably sharing of benefits. I would say mutual benefit between people who provide germplasm and people who receive germplasm. Can you comment on this?
Yeah, thank you. As I had indicated in that, when it comes to the use of plant genetic resources, food and agriculture, there are, of course, different capacities, different resources, and availability of resources, and access to both technology and facilities to actually use it. And there are also those who have, over time, through traditional means and through local activities, conserved and developed varieties that form the basis for new varieties. So the basic, philosophy of, I think, of the treaty is ensuring that while those who have developed and, who have been custodians of these resources over time, make it available to others to use, that those who use it also share the benefits that they derive from it. And that those benefits are not just merely monetary benefits or money or sharing profits, but also making sure that whatever they develop is also accessible to others, and also share the information they develop from it, as well as the technologies that they use in developing that. So that's the basis of that, of the equity we're talking about. And it's not necessarily equality, as or sharing equally, but it's a matter of equity to those who need and to what they need and what they are able to use.
I have a question. Thank you everyone for your presentation, really interesting everything. I have a question for Dr. Gutierrez and Dr. Ordridge. So in your presentation you talked about a sort of in situ conservation network, sharing and distributing your plant genetic resources that you conserve in your collection. So my question is, are you interested in your activities, and have you some methods to check the healthy status of these in situ conservation networks?
Yeah, thank you, Ben. I'll go first, shall I? I think in terms of the UK, we were talking earlier actually, I don't think we really talk about in situ conservation in that respect. It's something that falls below the radar largely in my experience. And I think with the local groups, I said I'm not quite clear whether they are, I see them often as ex situ conservers. Within some of those are small commercial specialist producers, but quite a lot of those are actually planted collections rather than farms necessarily. And I think one of the things we lack in the UK is a clear networking opportunity for those sort of those conservers. I think it's partly because I don't actually think there are very many of them. And I think the vast majority of people who who farm apples are farming on a strictly commercial, they're only interested in commercially viable top sort of level cultivars. But actually there are quite a lot of organisations who maintain orchards and things like the National Trust and the RHS, which are, the National Trust maintain lots of old houses and interesting historical sites in the UK. And a lot of those old houses used to have orchards in the days when people used to produce at home. So there is opportunity for them to have a more recognised role in maintaining some of these more diverse varieties. But I think they will always tend towards historic rather than any modern things, I think, in some ways. So they will look to the cultural sort of heritage varieties, I suppose, rather than engaging in gene banking, I suppose, in some ways.
I would say from a perspective of the crop wild relatives, there is a pretty substantial network in the United States to conserve in situ conservation. However, for apple, it's because it's so highly heterozygous and outbreeding, that in situ conservation is insufficient, I think, for conservation, because of just the longer they sit out in the wild, the more highly likely that they'll be inbred with, or they'll be interpollinated with domestic apple, and then kind of diluting that native species, which is having as pure of species as possible is what's ideal for us. The same for grape, wild vitis. The major challenge is just urbanization in the United States. I mean, so wild grapes are pretty weedy, and they are just easily removed or readily removed rather than conserved in the United States. So it's unfortunate, but so the target is to conserve as much land as we can, but also harvest as much of that native diversity and bring it into collections.
More question?
I have a question for Angelina, if she can participate.
Yes, Maria.
Okay. Yes. First of all, thank you for joining us. And I had the opportunity to visit Angelina last year in Cordoba, so I know how hard and amazing is her job. I have a question. Do you think that produce and share database could be an exhaustive strategy to solve the issue of synonymies?
Yes, it would help a lot, and we have had a huge discussion with that. We did some work with, in fact, Professor Testolin was part of it, in order to establish at the beginning, a common set of microsatellites in olive. But the problem is that the germ plant collections are so different. Their structure and experience and plant material is different. So nowadays we are, through IOC and other collaboration with other germ plant collections, especially worldwide, international germ plant collection, our proposal has been to use the set of ESD SNPs that we already have for the international collection, to have information, general one at the Mediterranean level, because, for example, I was surprised by myself as well. I didn't expect to see so many synonymies from such distant countries. So that's something that it is very important to share. But we are at the beginning, to be honest. I mean, we need to establish at first at the international level, in the 3 or 4 now international collection, and then on the national collections, and we are working on that. But in olive, we are behind, to be honest, about that, and that's something that we should prioritize now, yes. good question. Thank you.
More questions? We are becoming angry. Okay.
Thank you, everybody, for your presentation. They are all very interesting. I have a question for Gutierrez. You talked about the fire blights, that is a disease that spread among the malus families. There is some phenological traits that may cause this spreading of this disease in malus genera. For example, I don't know, why malus genera is affected, especially affected by this disease?
So you're asking, why is malus so susceptible to fire blight? It's also prunus as well, and a few other things, but it's, what? Empire, yeah, so pyrus, impair. Yeah, so it's a challenge, except it's really not much of a challenge for growers because we know so much about the phenology and the climate conditions and the modeling for predicting when exactly to control for fire blight is well understood, except with genetic diversity. So when every single individual in your orchard is different, they all respond differently to the applications. And so that's our biggest challenge, is that we've got to maintain, we treat each block as the same when really each tree needs individual love and care. And that's near impossible. So again, so controlling the growth through rootstock is probably the easiest option. So rootstock can also delay bud break and bloom, which can kind of get the trees more in sync rather than, I mean, it's beautiful because you come and it's blooming for about 2 months some years, with the earliest starting in April, the latest going, sometimes into early June with some of those North American. So during the bloom stage is when they're most susceptible. So how do you manage for a disease when one's already started and the other is, 2 months delay? So it's fun. It's part of the challenge and job security.
More questions? Yes, please.
Hello, and thank you to be here, and thank you for your very interesting presentation. We listen about in situ and ex situ conservation, but we also know that social memory is very important, is fundamental to face loss of biodiversity. So my question is for Dr. Nadozzi, and I would like to know something more about the actual and the future programs or strategies of FAO to support the link between local knowledge and agrobiodiversity conservation.
Yeah, indeed, a very good question, but also complex. But first, let me start address this issue of ex situ, in situ conservation, which I think is a very, very false dichotomy. Trying to distinguish between those. I think they overlap and are interdependent, and they're both very necessary elements of the conservation strategy and system that we have. So, trying to create that, this demarcation is usually not very helpful, at least not in practice. The treaty has quite a number of programs where it tries to address that the issue of both community knowledge and social knowledge, as you said, but also indigenous knowledge. Part of that is linked to the issue of farmers' rights, where there's a request and there's an expectation and a call on governments to ensure that local knowledge and traditional knowledge related to plant genetic resources is protected and promoted in such a way that it comes back to ensuring that diversity is maintained, because that local knowledge is what keeps the diversity at that local level, because a lot of times it's not because of their commercial value that they are maintained and kept, but because of the cultural value that they have that are important to the society and the local society, but also over time also has that spillover benefits to the broader global community, because they provide some of the buffer and also certain threats that could be useful to address either future diseases or climate change that arises. So that's one of the fundamental areas of work that we do, trying to encourage, local activities that maintain that local tradition and local resources and practices that support those resources.
I think we can stop here because we must keep the time. And I wait. Thank you to the speakers for the information they provided, very interesting. Thank you to everybody who attended the meeting. I wait for you 2:30. we start again the new section, and I will check if you are awake. Good afternoon to everybody. We start the next section, and let me invite Professor Rosario Schicchi. He is Professor of Systematic Botany at the University of Palermo and the Director of the Botanical Garden of Palermo University. He will give the lecture in Italian, but you can see the slides are in English, so it could be easy to understand also for people who is not familiar with Italian. The topic of the lecture is the monumental fruit trees as a biocultural heritage of Mediterranean landscapes. The case of study of Sicily. Please.
Thank you.
Non si sente.
Non si sente? Ah sì, ora sì. Gli alberi monumentali hanno sempre affascinato l'uomo e caratterizzato i paesaggi in cui insistono. Parliamo di alberi monumentali con riferimento a quelle piante straordinarie per età, per dimensioni, per forma, per rarità botanica, per il fatto di caratterizzare i paesaggi o per l'interesse storico, culturale o religioso. Gli alberi monumentali che abbiamo studiato in Sicilia sono oltre 1000, di cui 367 olivi e 700 piante appartenenti a 45 generi diversi, di cui quelli di interesse alimentare afferiscono ai generi Arbutus, Castania, Ceratonia, Fraximus, Malus, Pistacia, Prunus, Pyrus e Vitis. Si incomincia a parlare di alberi monumentali in Sicilia, ma anche in Italia, con riferimento al castagno dei 100 cavalli, su cui esistono dati a partire dal 1500. Una pianta straordinaria rappresentata da tutti gli artisti che nell'Ottocento venivano in Sicilia, una pianta che ancora oggi presenta dimensioni ragguardevoli, anche se la vetustà sta tutta in questa foto. È una pianta di età pari a circa 3000 anni, ma questa pianta ha rappresentato l'interesse per la protezione della natura. Nel 1750 il viceré di Sicilia emanò un editto che paragonava gli alberi monumentali alle antichità del teatro greco di Taormina. Pensate, quando nessuno parlava di protezione delle piante, in Sicilia 250 anni fa si proteggevano con il carcere, non con pene pecuniari, questi alberi dal danneggiamento. Il paesaggio agrario italiano è il frutto dell'armonico sviluppo delle attività umane in un contesto ambientale molto vario ed eterogeneo. Mai come per l'Italia valgono le parole di alcuni studiosi che dicono che il paesaggio è modellato da generazioni, dall'attività di generazioni di agricoltori, oltre 300 generazioni, e praticamente le informazioni relative all'antichità della coltivazione degli alberi da frutto risiedono nei reperti palinologici, archeologici, nelle evidenze storiche, artistiche, letterarie. Ecco, le piante da frutto per i paesaggi italiani hanno e svolgono un ruolo di notevole importanza. L'Orto Botanico di Palermo è stato sempre sensibile alla catalogazione del germoplasma delle piante frutticole. Già circa 15 anni fa abbiamo svolto per conto della regione siciliana 2 ricerche volte all'individuazione delle specie arboree da frutto della Sicilia, e poi abbiamo prodotto forse il primo catalogo pomologico degli antichi fruttiferi di Sicilia. Ma facciamo un viaggio attraverso gli alberi monumentali da frutto, che sono beni unici e irripetibili. Il patrimonio genetico di queste piante difficilmente potrà essere replicato, quindi come i beni marmorei hanno bisogno di manutenzione e anche di adeguati interventi di valorizzazione. L'immagine precedente si riferisce agli antichi carrubi che permeano il territorio di Siracusa e di Ragusa. Questa pianta probabilmente rappresenta il carrubo di più grandi dimensioni del Mediterraneo. Ha una circonferenza massima di 18,50 m e, come potete notare dalla chioma, ci sono 2 varietà innestate. Nella parte centrale la chioma è più scura, lateralmente è più chiara, quindi è il frutto dell'innesto di 2 cultivar. Anche questo carrubo di dimensioni eccezionali, di 16 metri di circonferenza, caratterizza gli agrosistemi di Modica, delimitando appunto queste proprietà che sono l'alternanza di seminativi e di arboreti discontinui. Con riferimento all'olivo, dicevo poco fa, abbiamo censito 367 piante, tra cui 3 olivi selvatici, Olea europea Val Silvestris. Questa è una pianta di olivastro di 5,50 m di circonferenza che si è salvaguardata, pensata all'interno di un seminativo per una leggenda legata a quest'albero. Chiunque raccolga frutti o rami dalla pianta muore, per cui nessuno osa toccare da almeno 600 anni questa pianta. Altrimenti cosa ci farebbe un albero del genere in un seminativo? Nei templi di Agrigento abbiamo censito degli ulivi monumentali. L'olivo della Colimbetra è una valle incassata nell'Agrigentino risalente al tempo degli Arabi. Ci sono resti di canalizzazione degli Arabi e alcuni olivi hanno veramente dimensioni straordinarie. Ma gli olivi più grandi li abbiamo nella città di Agrigento. La città di Agrigento addirittura esportava olio a Cartagine. Pensate, questa pianta di 8 metri di circonferenza, l'olivo di Bonamorone, è uno degli individui più grandi dell'Agrigentino. Passando nel territorio della provincia di Messina, a Caronia, quest'albero plurisecolare, accreditato di circa 1200 anni di vita, presenta una circonferenza di quasi 13 metri. A Noto abbiamo censito questa pianta, olivo di Busulmone, così chiamata, dalle cui foglie ho potuto risalire che si tratta di un'antica cultivar greca, la calamata, ma se riflettiamo, Noto, come tutta la provincia di Siracusa, è stato oggetto di dominazione greca. Ci vuole l'analisi genetica qui per dimostrare se effettivamente è vero. Ecco, altri olivi straordinari, ma vi prego di guardare soprattutto la lettera B stampigliata sul fusto di questo olivo, che testimonia la proprietà promiscua, cioè in Sicilia, a partire dal 1400, i baroni, i principi autorizzavano i contadini ad innestare gli olivastri e il contadino diventava proprietario dell'albero, mentre la terra rimaneva di proprietà del marchese, del barone, del principe. Quindi è nata una sorta di proprietà promiscua che arriva ai nostri giorni. Quindi l'olivo, essendo plurisecolare, rappresenta un bene immobile, non un bene mobile. Sono tutte cultivar che abbiamo censito, che abbiamo documentato e che fanno parte della nostra banca dati. Ma l'olivo più grande che abbiamo censito, della varietà sant'agatese, si trova a Pettinevo ed ha una circonferenza di circa 20 metri. È una pianta straordinaria che ha sfidato gli incendi, più volte è stata interessata dal fuoco, ma l'olivo è una pianta che non muore mai o quasi, cioè ci vuole veramente tanta fatica per farla morire se non viene attaccata alla xylella. Ma un paesaggio particolare, unico a livello mondiale, è quello espresso dal frassino d'Amanna. Il frassino d'Amanna viene inciso durante la stagione estiva, da luglio a metà settembre, e produce questo liquido che, rapprendendosi all'aria, solidifica e forma la manna. Esistono dei frassini monumentali, come quello che si trova a Castelbuono, il mio paese di origine, che ha un'età di oltre 500 anni, il cui fusto è cavo e contiene comodamente 2 o 3 persone. Ecco, questa abbiamo censito anche la cultivar, viene indicata con un nome dialettale di inserillo, quindi è una cultivar d'Amanna tardiva, quindi entra in produzione tardivamente rispetto alle altre. Passando alle piante afferenti al genere Pyrus, abbiamo descritto delle specie nuove come quella in esame, che è il Pyrus vallis lemonis. Questa pianta, che presenta un frutto piccolissimo, grande quanto una ciliegia, forse meno di una ciliegia, è monumentale, abbiamo stimato che possa avere un'età di oltre 500 anni e rappresenta sicuramente un elemento che esprime la grande biodiversità che il genere Pyrrhus presenta in Sicilia. Abbiamo noi descritto recentemente 3 nuove specie di Pyrrhus e quindi il germoplasma afferente a questo genere è veramente notevole. Abbiamo censito alberi di pero straordinari per dimensioni, per vetustà, spesso ai margini dei boschi, praticamente erano dei peri selvatici che venivano innestati, come questo in provincia di Agrigento, o nel territorio di Castelbuono queste cultivar lucciardone o lazzuolo d'inverno, che sono delle cultivar locali, delle pere tipicamente invernali. Ma passando, il genere Pyrrhus è stato oggetto di selezione dai contadini perché a partire da questa pera piccola di colore giallo, che viene chiamata con il termine di pero maiulino per sottolineare il fatto che è matura già a maggio, si arriva poi gradatamente alle pere invernali. Quindi il pero era una coltura che doveva produrre frutta da maggio all'inverno inoltrato, in modo da fornire vitamine. Quindi abbiamo censito in Sicilia oltre 180 cultivar differenti di pero. Ma l'antichità di questa coltura quindi è dimostrata sia dagli individui monumentali sia dal notevole numero di cultivar che si riscontrano oggi sperdute nelle campagne, soprattutto negli agrosistemi tradizionali, quelli localizzati nelle zone collinari e pedemontane.
Rosario,
Sì.
one minute.
Sì. Passando al genere Malus, vediamo alcuni individui straordinari, questo è Malus silvestris, ma poi 2 individui afferenti a una nuova specie di melo, Malus crescimannoi. Questo è un individuo che si trova nel Parco dei Nebridi, come anche questa pianta. Sono piante straordinarie. E poi mandorli, qui siamo ad Avola, è un individuo straordinario di Pizzuta d'Avola, un mandorlo amaro e poi un individuo di ciliegio. Per ragione di tempo, ometto di presentare altri generi, ma volevo concludere con questa pianta bizzarra che è frutto di cultura e di natura. Vedete, la pianta è Pyrrhus valles demonis, ma all'interno è cresciuto un faggio, all'interno del fusto cavo, per cui questa è una pianta straordinaria bimembre. Quindi la natura ci riserva emozioni e sorprese veramente ragguardevoli. Grazie per l'attenzione.
Thank you for such exciting presentation. The next speaker is Ignazio Verde. Ignazio Verde is a scientist of the Research Center of the Ministry of Agriculture in Rome, and he is a coordinator of the national project for the implementation of the FAO Treaty in Genetic Resources. He will give the lecture through the web.
Good morning, can you hear me? Hello, can you hear me?
Yes.
Okay.
Keep going.
Thanks, Raffaele. Good afternoon to everybody. Today I will illustrate an issue, the digital sequence information, DSI, that for sure will have important effect on the exploitation of the genetic resources, but it can have also importance in a very important issue on the advancement of science, knowledge, and innovation, not only in agriculture. Sorry, okay. Okay, I won't speak about the. Sorry, I see something I don't want to see. Okay. About the importance of agrobiodiversity, I'm sure that this morning you discussed well. But I will say that agrobiodiversity to be used, they need to be preserved, of course, and characterized, but it need to be used. To be used, we need to warrant access to everyone that won't have the genetic resource, to use the genetic resource. But as well, we need to warrant the benefit sharing. We need to share the benefit with the local community that preserve important genetic resources for food and agriculture. Sorry, but sometimes it doesn't work, the mouse. In the international arena, there are two treaties that are in force for plant genetic resources. One is the Nagoya Protocol of the CBD, the Convention for Biodiversity, dealing with biodiversity in general. The other is the International Treaty on Plant Genetic Resources for Food and Agriculture, ETPGRFA. I don't want to speak about these two treaties, but just stress one important difference. Nagoya Protocol for warranty access and benefit sharing needs the signature of bilateral agreement, while the ETPGRFA has a simpler and fast multilateral system that we need to sign only one SMTA, Materials Transfer Agreement. One example to stress this aspect. Let's take a wheat variety obtained at Chimete in Mexico that it arose from about 3,000 crosses from 50 parental lines that are held, that the rights are held by 26 institutions, countries. If a third party wants to access to this resource, according to the Nagoya Protocol, we need to sign 26 different transfer bilateral agreement. This is some practical. This is because the agricultural genetic resources have an important, some uniqueness and peculiarity. They are coming from one center of breeding, so it's a peculiar particularity. Let's see when the DSI, the Digital Sequence Information Issue, start. It started at the CBT conference in Cancun, the COP13 in 2016. Some developing countries bring on the table the issue that the sequence data associated with the genetic resource should follow the rule for access and benefit sharing of the Nagoya Protocol. A new term was coined, Digital Sequence Information, or DSI, not yet definitive, is a placeholder and not defined. An ad hoc technical expert group, ATEC, was set up to study the implication of DSI on the Nagoya Protocol and define its purposes, application, and rule. As a domino effect, this issue come to the FAO, International Treaty for Plant Genetic Resources from Food and Agriculture, to the pandemic framework that deal with influenza virus and coronavirus virus, and with the Convention of the Law of the Sea. This is strange. Why we should equate the genetic material to a genetic sequences? In fact, the Article 2 of both ETPGRFA and the Convention on Biological Diversity say that genetic material is something that contains functional units of heredity, and of course, a genetic sequence is not a functional unit of heredity. This equation is because the enormous development in genetics and molecular biology, for example, recombinant DNA, CRISPR-Cas technology, with this technology we can move gene from not related species and we can modify gene in a targeted and precise way. On the other hand, some argue, okay, it's true, we can move it, but to associate, for example, a function to a genetic sequence, to a gene, it's important, it's not important, it's necessary to compare this sequence with the whole database, maybe thousands or million sequences. Think, for example, a genome-wide association study. Then there is the promise, in my opinion, still distant and utopian, of synthetic biology to reconstruct an organism starting from its crude sequence. For example, it was accomplished with a virus, but in my opinion, with a cellular organism like an eukaryotic, as a plant, it would be quite different. All this brings to the dematerialization of genetic resources. It will no longer be necessary to possess the material, but only the associated information, the sequence. Let's see what's the situation nowadays. About a couple of years ago, 1,700 databases with free access, open access, were surveyed. We have the most important one in CDI, ENA, DBJ, and its consortium ENSDG. For example, this is the number of bases in database through the year. As we can see, we have an exponential growth with the base double approximately in 18 months. It's a huge amount of information. Then we have the specialized database. For example, phytosomes for green plant, ZDR for heterosage, Solanaceae, then grain genes is for the cereals, and also we have GCIDES for the virus, that it's important as well. This database do not display only the crude sequence information, but give us information and offer also the visualization of the gene that we are, of the element that are in a genome. For example, this is a gene that controls fuzziness on pitch. If you eat a nectarine, the third exon is truncated, for example. You can find this on database. Moreover, scientific journals and funding agencies oblige to deposit the sequences on public database before gaining the publication or before having the funds. Moreover, assembled genome drafts are made available, publicly available to scientists even before the results are published in a journal, according to international agreement. To see what's the importance of this, what we have now, let's think the last 3 years, the pandemic of the last 3 years. In January 2020, a new emerging virus was sequenced. This virus was the one that caused the COVID-19 pandemic, and after the sequence, every scientist in the world can have access to the sequence and start studying. For this reason, we have, in less than 1 year, we have sequence, vaccine, and tampons to track and trace the diffusion of the virus. On the other hand, the developing country and local community want to share the benefit that derive from the genetic information associated with their traits. We can argue that open access is in itself a non-monetary benefit. But for example, an international institute in Kenya was able to eradicate virus, an endovirus, banana streak virus in the banana, using the CRISPR-Cas technology. And this was, of course, possible because the sequence of the viruses and the sequence of the banana genome was freely available on online, open access, so they can perform the virus eradication. But there are limiting factors. The institute in Kenya is not the normality. In this country, we have a lack of infrastructure, technology, skills, economic availability, the so-called digital and technological divide. So they are not able to apply this technology and exploit the information that are available freely for everyone. All these opposing interests block negotiation in the various fora. For example, 3 years ago, in 2019, it was the strengthening of the multilateral system of the international treaty was blocked also because we have opposing view on this aspect, on the SI. I will skip the digital, the issue of the name. It's not so important, and I'm going on to see what the SI should include. It's not clear yet. The ad hoc technical working group present this table where we have 3 groups plus the associated information. Group 1 deal with DNA, the RNA sequence. It's all the information about the DNA, genotyping, marker, structural annotation are included in this group 1. Then we have the group 2 that includes group 1 plus the protein and the epigenetic modification. This is okay, of course, but we need to know, because of the redundancy of the genetic code, we have that a single protein sequence can be codified by different DNA sequence, for example. In group G, in my opinion, start the problem, because in this case, DSI would include also phenotype. We started for metabolites, and we arrive at associated information. We have also the phenotype and even the passport data. Of course, if this will be the future reality, we can have serious problem with the germplasm collection, the gene bank. Gene bank will become a mere list of a number and code, because we can access directly to the phenotypic information. If a plant is resistant or not, is tall, or if it's late or early ripening. Before signing the agreement, we should know. What are the options on the table?
1 minute.
See. Okay, I try to start. The options on the table, the status quo is not acceptable. It's not acceptable because many countries start to include the SI rule in their legislation. Bilateral approach, as I showed you before, with the agreement of the Nagoya Protocol, it's not acceptable as well. The multilateral approach is acceptable, but we need to decouple the access from the benefit sharing. And also we need to increase the capacity building. This is the same situation as before. The European position is clear, open access, not negotiable. The multilateral approach and capacity building are important. We are here. COP15 was held in the last month after being delayed several times for pandemic. We have more expectation on this conference, but usually I think they don't take any important decision. But something important some important issue were taken. They recognize the divergent view. They recognize that other fora, as FAO, can have a specialized approach. They recognize that tracking and tracing is not practical. A multilateral approach would be better because it hinders research and innovation and would guarantee open access and the capacity building as well. Scientific community has not been involved in this process. Scientists barely know about this issue, in my opinion. Recently, a DSI scientific network present an open letter to CBD. What they ask is the same that I told before. You can access this information at this website. They publish also a paper. I invite you to read the paper and read also the open letter. If you agree, please sign it, because it's important that science start to be involved in this process that is still on. COP15 is over, but the project is still on. Thank you. I finish. If you have a question, I'll be happy to answer your question.
We collect all questions at the end of the session.
Okay.
Thank you, Ignazio. Next speaker is Lorenzo Raggi. He is a plant geneticist at the University of Perugia, and he is expert in genetics resources of annual crops. The talk is analysis of landrace cultivation in Europe, a mean to support in situ conservation of crop diversity. I must recommend to all speakers to keep the time, because please.
Good afternoon to everybody. First of all, I would like to thank you, the scientific committee, and in particular Professor Guarino, for inviting me to present some of the results we got in this analysis of landrace cultivation across Europe. So before I move to the result of our study, I would like very briefly to remember you that we are, at the moment, we are really experiencing a high rate of loss in biodiversity. And for what regard the part of biodiversity related to cultivation, so plant genetic resources, this is mainly due to the fact that modern agriculture mainly relies on modern cultivars that are basically without any genetic diversity, so mainly hybrids or pure lines in allogamous and autogamous species. However, landraces are still over there. They are still cultivated in Europe. There are several reasons for this, but the most important are that they can be very good in low input environment, where they can perform better than modern varieties. And also because, especially in countries of the south part of Europe, like Italy, for example, it's very common that these products from landraces can reach very high price in the market. So this is another reason why they are conserved. So we think that if we make a rational use of agrobiodiversity, we can also help to conserve diversity in a general meaning, and also we can help agriculture to cope with, for example, climate changes, because one of the consequences of climate changes is climate unpredictability. And what we can do, we can increase the diversity of our cultivation to respond dynamically to these traits that are coming from the climate change situation. But we have a big problem, I would say more than one problem, because it is quite difficult to track landraces in situ. There are several reasons for this. The community that is still managing this type of materials is quite heterogeneous, so it's not easy to reach all the different stakeholders that are involved in the process. In addition, the number of sites involved could be extremely high, I would say huge, if we consider, for example, the whole Europe. And in addition, the adoption or not of landraces is a very dynamic process, so it can change quite a lot year by year. So we do not have complete knowledge of the landraces where they are cultivated, and we are the stakeholders, and we don't also have the knowledge on how we can increase the adoption of landraces. That is very important if we want to increase their use across the region. So this is the framework in which the Farmers' Pride project was financed, a project led by University of Birmingham in the person of Professor Nigel Maxer, that is very active in promoting in situ conservation of both landraces and crop wild relative. So basically the general idea is that like we are in a situation like this, so where interaction among all the different stakeholders involved in plant genetic diversity conservation in situ are not very well constructed. I think this was also mentioned by the first speaker of this morning session. So the idea is to build, so to try to strengthen this connection to get out value of the improved connection among stakeholders. So the idea but the very last and main goal of the project was to lay the foundation for the development and establishment of an in situ network for conservation and sustainable use of plant genetic resources, including both land races and crop varieties. Indeed, during the project, we demonstrated that stakeholders that are involved in the process are really willing for such a network, because more than 70% of the stakeholders we were able to reach in ad hoc developed survey say that they were interested in this network. So what we did, basically, we developed an ad hoc template for recording the occurrence of land races in situ across Europe, and this template was spread to the different countries through the partners of the project, but also through the ECPGR that has been already named today, a national coordinator. So asking for records of sites where land races are still cultivated in Europe. All the received data went through different filtering and analysis, and we ended with 19,000 records of cultivation of land races across Europe. That is the highest number of records ever collected for land races in this region of the world, from 17 different institutions. So we were able to include both public and private companies and NGOs, universities. And this is a rough representation of the distribution of the cultivation sites of these land races in Europe. And among the most represented species, we had wheat, in particular spelt wheat, some common bean, and apple, so it's maybe very relevant for you, and that were among the most cultivated species across Europe, but also among the species of most relevance in each country that contributed with data, so this is also very important. As for the distribution of these records, we found that the Mediterranean area of Europe is the most relevant. So more than half of all these records are coming from the south part of Europe, so this part here in orange, that is the Mediterranean area, and in particular Italy, Greece and Portugal were the countries where the highest diversity is still present in situ. So that in the case of land races means in cultivation. The other biogeographical regions were also important, at least the continental one, but then the other less and less important. We then wanted to check the distribution of these land races, also taking into consideration their presence in protected areas of the Natura 2000 network. This is a big network of protected areas that is common to the whole Europe. And we were quite surprised to find that almost 20% of cultivation sites of land races in Europe are actually occurring in protected areas. So these materials somehow also experience some kind of protection. And these sites, in total, they host more than 70% of all the species we were able to record. That are almost 200 different species, crop species. Situation can be quite different in the different countries. So concerning both the area that is included in the Natura 2000 network, as well as the percentage or proportion of cultivation site in the protected area, as well as the coverage of the total number of species that is present in protected areas. And here in the figure are a rough representation of the cultivation sites occurring within the network Natura 2000. We then move to the identification of hotspots. So here in the map, what you see is the first presentation of land races hotspots and their distribution across Europe. And again, also in this case, the highest number are related to the south, so to the Mediterranean part of Italy. As in this case, hotspots were identified taking into consideration both the number of cultivation sites in a delimited area, as well as the number of different species occurring in that area. Of course, this is only a first analysis of the hotspots, so we want to reiterate the process, trying to include more sites, even more spread across Europe. But at the moment, this is a good starting point for identification of most diverse parts of this region. And also for the other countries that are represented in the project, we also find some areas that are particularly rich of diversity, not as much as in the hotspots, but still relevant in proportion to the number of land races present in these countries. As for tree species in particular, we ended with almost 4,000 records of cultivation sites. About 25% of these sites are, at the moment, we know that are located in the Natura 2000 network, and almost 50% of these sites are in the hotspots that we already identified. The most important species, of course, apple, but as well as pear, cherry, grape, and olive, according to the data we were able to collect. And again, also with special reference to tree species, the Mediterranean area is the most relevant across our European region. Another point we wanted to study during the project was how can we increase the adoption of landraces in the end, so but making some leverage on the added value of the product we can obtain from landraces and increasing at the same time the accessibility to these materials that is not always very easy to access. For this purpose, we create a collection of case studies of landraces that were basically provided by several of the partners involved in the Farmers' Pride project, and we asked to describe this conservation of landraces using a very well-defined standard template, so that they were able to produce some quantitative descriptors from the text they sent, trying to make a quantitative evaluation of the added value and the accessibility of this material. So because we wanted to test with statistical analysis to demonstrate if some factors can significantly affect, so increase the added value or accessibility. We ended with more than 90 case studies, almost 100, distributed across Europe, also in this case in covering quite well all the different biogeographic regions that are present in Europe. So we hope these case studies are representative of different situations. And applying a statistical analysis where we were able to demonstrate that added value of the materials can be statistically increased when the strong promotion activities develop for the resource, and this is very relevant. So farmers that work with landraces, they need the help to, the strength to promote their products. This is very relevant to increase the value of what they are growing. And also when the resource is managed by a consortium of farmers. So we think that it's very relevant also in this case to push, to help farmers get in contact, create consortia around these resources, because in this case they can earn more from the cultivation of landraces. And of course, I think that everyone knows, at least in this room, that the conservation must be strongly linked with the use. Otherwise, it will be very difficult to conserve all the diversity we have in Europe or in Italy, in these countries where landraces are still cultivated. As for the accessibility, we also demonstrate that promotion can positively, so that increase the accessibility to the resources. So what we can conclude from this study, so basically that landraces are still out there, they are still cultivated, but they are managed by a very complex stakeholder community, so it's not always easy to reach all these different different actors. Differences among the European countries are very strong. We think they are both real differences because, for example, the highest number of cultivation sites are from the south of Europe, and this is very logical. We know that in this part of Europe we conserve more diversity than in other parts, but we think that is also a difference of knowledge because for example, countries like Italy invested a lot of money in tracking these materials, trying to help farmers in keep cultivating and doing some characterization. So it's a difference in the number of resources, but also in the knowledge of such resources. Very interesting, we found that quite a relevant part of these resources are currently grown in protected areas of the Natura 2000 network, where also crop wild relatives are occurring. Very recently, we published a paper in this special issue that Professor Guarino was referring before, where we are demonstrating that also crop wild relatives of some of the key genera in Italy are occurring in Natura 2000 network. And this for us is very relevant because we could think to protect both the two most important components of plant genetic resources, so landraces and crop wild relative, using the same sites. That could give more value to money we invest in this important thing. We also were also able to find some factor we can work on to increase the value of land races. So I think this is an important perspective for the future, so try to help farmers and get more value from their land races to push them in still consider land races for their production, and also increasing the contribution that the cultivated part of diversity can give to the Farm to Fork and the European Green Deal, promoting again the adoption of land races. So as from our results, we think that it's possible to establish an in situ network for the conservation of land races and crop wild relative. I mean, at least from the scientific part of the problem, we are trying to accumulate evidences, so like for the identification of the best sites, so that in a, we hope, near future could be the basis for the development of the network. These are some resources that you can get for other information on the topic we have presented today. These are those partners that were involved in the project that I would like to thank you because provided data about cultivation of land races in their country. And of course, I would like to thank all of you for your very kind attention. So thank you.
Thank you, Lorenzo, for such unexpected and interesting lecture. The next speaker is Massimo Gardiman, scientist at the Viticulture and Enology Research Center of the Ministry of Agriculture in Conegliano. He is also the curator of the grape germplasm collection.
So, thank you, Chairman. I would like to thank Professor Guarino and the organizing committee to invite me. And I try to talk you about this particular crop that is the grape that is only partially used as food with the table grape raisins, but the major part is used to make wine. That is not food, strictly a food. Okay. No, this one. Perfect. So, as we see this morning in other crops, also grape wine has a very wide biodiversity, as is possible to see easily looking at the leaf, with an enormous variation in leaf. The berry, the bunch is an extreme variation in bunch size, berry shape, and color. But also other parameters that we don't look, we can see by eyes, is like a metabolic content and other phenotypic traits. In my opinion, is very important to start with some number or some figures, because these numbers are the benchmark of our work. It's very important to know how many of this variety exist in the world. So it's a very difficult task and exists only estimate. But for grape wine, for vitis, better to talk about vitis, we estimate that exist 25,000 prime name in the International Vitis Catalog. Prime name is a unique name of this of the variety. Among these exist 30,000 that are vitis vinifera. That is the vitis that we use to make table grapes, mainly table grapes or wine. I don't talk about vitis silvestris, that is the wild relative, that is also extremely important, but we have no time to talk about this. But of all this big number, only 1,500 varieties are cultivated. Also, this is an estimate, but you see the big tenfold less this number. And if we go deep, 15 varieties cover half of the world's entire area under wine, and 6 varieties cover the 31%. And these are the international, so-called international variety. Only looking at this number, you can say there is something wrong in this in this number. The number is the global overview, worldwide overview. The single country have a different figures. So I report you the example of Italy and Spain, and you can see in Spain resemble the world. Italy, fortunately, is one of the countries richest in grape wine biodiversity. And the major part of the surface of the area cultivated is of minor varieties. But in some Italian region, I talk here about my region, Veneto region, in the northeast, there is a similar situation that in the world. Very few varieties cover almost all the surface. The causes of this loss of grape wine agrobiodiversity are a lot. The first that was mentioned this morning from the colleague from USA is the arrival in Europe of the grape pathogens, phylloxera in primis, but downy and powdery mildew. These pathogens destroy practically the major parts of viticulture existent in this moment. And the growers need to replace the old variety with new variety resistant and to graft over rootstock the variety. Another important point is that in Europe exist very restrictive laws that do not allow to plant and market traditional wine. You can only cultivate and market variety registered in the national official list. And this is a problem because a lot of neglected and traditional varieties are not until now registered in the national. But the very big problem, in my opinion, is that grape makes money. So these are a figure for Italy. Wine sector in 2021 is valued at 13 billion euro of sales turnover and 7 billion euros of export. To have an idea, 30 billion euros is the gross domestic product of an entire country like Nicaragua. So this number is very, very, very impressive. And the growers have the right to plant only material that they can sell at a high price. So this increase of the international trade, the prevalence of a small number of variety, and the few clones within each variety is another big drive of this loss of agrobiodiversity. In the future, there are another problem that we are facing on. New resistant varieties created by the breeders will be preferred by wine growers and consumers, and will it be another serious blow to local variety? This is, in my opinion, an important point to take note of this point. But why do we need to conserve this biodiversity? For sure, I repeat from what was said in the previous talk, it can be a valuable gene pool for new breeding programs. Vitis agrobiodiversity represents a very huge treasure of useful trait to face climate change and to diversificate the product, the wine, and the table grapes. Vitis biodiversity can be also an interesting source of opportunity for economic, historical, and cultural valorization of traditional products that are linked to the territory. Wines from these neglected and rare varieties are nice products and thus provide a very high value. So if we can transmit this idea to the growers, biodiversity, in my opinion, is maintained by yourself, because if growers know that with biodiversity, using local or neglected variety can make money, I think is a good thing. So, the grape wine varieties linked also to iconic territory. I just an example of my region, the hills, iconic hills of Conegliano Valdobbiadene that are UNESCO World Heritage Site. And with the variety, the grape variety cultivated in this area, you can train tourism. You can have a big impact of economic aspect. Another interesting thing is that biodiversity can be used also to other purpose, to make a nutraceutical. You know the property of resveratrol, a lot of antioxidants, or also for the green chemistry. But the most important thing is one lost, it is no longer recoverable for present and future generation. I was happy this morning to hear that we use the same vocabulary, the same grammatics, the same grammar. So the verbs are explore, recover, conserve, characterize, identify, document, rationalize, valorize. And in the case of vitis, our work is to valorize in primis accession with useful characters and wines with historical memory of a territory, because I think this is the two most important thing. Exploration to identify wines across the territory, to recover. So the first steps is to make a DNA test. Is very quick. We use 12 SSR, and this say immediately if it's a new accession of an old one. Conservation is made, I think, I talk about my institute, in 4 sites, and we conserve about 6,000 accessions. That correspond to about 2,000 different variety. We choose to conserve different accession of some varieties because we believe, we are sure that there are some difference not identified by the microsatellite light, but from the phenotype, are different biotypes. You can see here the 4 stations. The most ancient station is experimental station in Conegliano, was founded in 1923, and the first commitment was to establish an ampelographic collection that was created in 1951, the collection in Susegana, the actual collection, where we store genetic resources, and we have also the living collection of all the varieties registered in the Italian catalog. Conservation is made in dedicated vineyard. We conserve 5 wines for the accession. For only few accession, we also use in vitro conservation under normal or slow growth condition, and we are starting to cryo conservation. We have not very good results, but the work are in progress. Here are some pictures of our collection in Susegana. Also, another important step is characterization. Characterization is made also of phenology, ampelography, also phenotypic traits, also DNA fingerprinting. That Professor Testolin was one of the pioneers of this work. And also agronomical traits, that was very important for the valorization, the metabolomics, the variety, and also the health aspect. This is an example of how the interest of the local minor varieties in my region. You can see in the last 5 years, almost all the minor varieties increase the surface. And this is a good thing, because a lot of this variety was recovered with the process that I showed you before. Another interesting is the main function is a gene bank for sure, but we can use ampelographic collection also for a lot of scientific work. And just show you two last work that we contribute, and we are very proud because half of the accession come from our collection in Conegliano. A very quick look at what's happening in Europe. Exists ACPGR, I don't talk about because we also know what is. And in the frame of ACPGR, there is AGIS, the Gene Bank Integrated System, and Eurisco, that is the catalog. Some numbers about VITIS. In Eurisco exist about 15,000 accessions. In AGIS, only 100 more. Of this accession, 13 come from my collection, our collection, and just to show you some figure. In the frame of SCPGR, there is a VITIS working group that work trying to do to give to all the people some standard for the conservation of VITIS accession and operational field gene bank collection materials. So I have finished. Some acknowledgement. Firstly, our Ministry of Agriculture for providing long-term support to the maintenance of the collection, to some regional administration that give us some spot fund to solve some particular problem, and for sure to all my colleagues that I try to coordinate in the four collection. And also thank you for your attention. Let me spend 2 seconds to wish a very happy birthday to my institute, that this year is the 100th birthday.
Thank you, Massimo, for your presentation. We realize that you are fond of grape, and this is good. Next speaker is Angelina Annunziata. She is scientist at the Research Center of the Ministry of Agriculture in Caserta, and she works on species like chestnut, pear, fig, and pomegranate. Please, the topic, the lecture is morphophysiological characterization for the identification and definition of autochthonous cultivars, a case study on the use of UPOF descriptors in pear. Please.
Okay, thank you for inviting me. As the speaker before me told, we share a common vocabulary, so we share the fact that we characterize cultivars for several purposes, among which the most important is the identification of the cultivars, and the second one is the documentation of the characteristic of a specific cultivar. This is a very badly posed question, which is the best method for variety identification. Obviously, there is not a better method for identification, but there is a fact that when you make a morphological characterization for variety identification, what you are practically doing is trying to isolate the effect of genotype from the effect of the environment, of the morphological characteristics of the plant you are observing. So, apart from all the differences that are related to economical and time aspects of the two methods, the most important differences among these two approaches are, in my opinion, the fact that morphological characterization with respect to genetic characterization gives you practical information about the cultivar. Because when you do a genetic characterization, you are sure you are observing a specific genotype, but you don't know nothing about this genotype if you don't compare it with other genotypes. Instead, when you do a morphological characterization, when you say that a fruit is big, you are saying that the fruit is big with respect to the other, so you are telling something about that genotype. Besides, a morphological characterization is still the only one which has a probative legal value, if I don't mistake. In fact, fundamentally, there has been a large consensus about the methods to be used for recognizing plant breeders' rights, for example, and the method is to observe by a morphological point of view plants in order to detect a specific list of descriptors. Besides, there is one contrary. If you make a morphological characterization, and you can be biased by environmental and growing condition. And this is the reason why when you do a morphological characterization, you have to conduct them in a test field. So this is what I already said. Descriptors, you choose descriptor accurately. You try to use descriptors independent from the environment. And you make a comparison. You always make a comparison. You never say this fruit is 10 centimeters big, but you say it is big as the other cultivar, it is small as the other cultivar. So if you observe these varieties in a test field, you will have the same responses independently from the position of the test field, the growing conditions. So the key of this method is the presence of a test field. But our problem was, in the Covale project, we didn't have a test field. Will it work? We had to make a morphological characterization without having a test field, because the test field was in building during our morphological characterization. And this happens very frequently, because very frequently you have to identify a cultivar before you introduce it in a test in an ex situ conservation field, or while you are introducing it in an ex situ conservation field. Obviously, we made the morphological characterization according to test guidelines suggested by the UPOV site. We used the TG015 for characterizing pear and the other one for other species. But now I make an example talking about pear. These TG test guidelines include 65 descriptors now. Okay, how are these descriptors? You can look at the list, and in the pie you can look that about a quarter of them are concerning the leaf blades. Another quarter is about woody part of the plants. A little part is about flower descriptors, and the major part of them is about in pale green and is about fruit characteristics. Now, if we have a look at all these 65 descriptors, we can classify them in 3 categories. The ones that are influenced by the environment are the ones that I mark in red. As an example, the length of internode is influenced by the environmental conditions. Instead, the way in which the one-year-old shoot grows, if it is right, wavy, or zigzag, is not dependent from the environment. A descriptor that is completely independent from the environment, and as an example is this, the size of the bud support of the 1-year-old shoot. If a cultivar is genetically programmed for having a large bud support, it will always be large, independently from the conditions in which the cultivar is cultivated. So if we made this classification on all the 65 descriptors of peers, we see that the major part of the descriptors are independent from the environment, but there is a quarter about of descriptors that can be sometimes influenced by cultivation conditions, and there is a small part that is highly influenced by the environmental conditions. The 10 cultivar peers that we characterized are spread in Campania region, but fortunately the major part of them were included in a previous project that was Frutta Antica del Matese, and therefore they were in a growing field already in cultivation on the Matese mountain. And it was the field that you see in corresponding to Borrelli cultivar, this first image. So the plants were at this stadium of growth. Instead, other cultivars were collected from the mother plant of this field because they died in this field. So evidently we were observing plants in very different ages. And another cultivar was out of this project and was grown up in a very, very different condition. This pennata is commonly spread in Amalfi Coast and is growing on a volcanic soil in very different conditions. So anyway, we make all the characterization, all the 65 descriptors. Fortunately, flower description is strongly independent from the environment, and in fact, there was a major part of the characters of the flowers that are independent from the environmental conditions. Instead, fruit are strongly dependent from the environment. These are the 10 cultivars we characterize. But also on the fruit, there are some characters that are independent from the environment, as the one that you see here. So the way in which the sepals are spread and mature fruits. At the end, we made a data collection that was made in this way. We have 65 columns. In each column, we recorded a number that you can see here. For example, for the character 55, 1 for the converging sepals, 2 for the erect sepals, and 3 for the spreading sepals. So in each column, you can read the value we recorded for each cultivar. For evaluating if this method worked, we also made a genetic characterization. We used 12 SSR picked from literature, the one that has suggested for variety identification for peers, and they were randomly distributed on chromosomes, and we had distinctive genetic profile. Again, we had a table, a numeric table in which on each line we had the cultivar, and on the columns we had the data we had collected. Okay, for comparing, for understanding if our morphological data were reliable, we simply compared them to genetic data in order to understand if the variability collected was comparable. And in both the principal coordinate analysis that we get, we have that about 70% of variability is represented on 2 axes, and we found some similarities in the way in which the cultivar spread on the data sheet, on the sheet. In fact, in both cases, we evidenced a green cluster of 3 varieties, and in both clusters, we evidenced that Scamorza is a part. Obviously, no one of these 2 principal coordinate analysis is the best one. We are also doing a more in-depth analysis by genetic markers. We are using a SNP detection, in-deep SNP detection, so that we will have a more accurate image of how diversity is spread in these cultivars. In conclusion, I can say that despite we didn't have a test field, it seems working well just the same. Thank you for your attention.
Thank you, Angelina, for your talk. I suggest you to pass your observation to UPOF, who doesn't accept almost anything, but we can hope your observation could be accepted better than the previous one. And you saved also 1 minute. Next speaker is Clizia Villano. She is scientist and plant geneticist at the University of Naples, and she works on grape biotechnology. The talk is Genetic Diversity and Adaptation Footprints in the Genome of Grapevine Clones of Southern Italy Varieties.
Thank you so much. First of all, my talk will be about the investigation of grape diversity in some varieties of southern Italy. First of all, I would like to thank Dr. Gardiman that was in a really good talking about this biodiversity, because grape wine is really complex, and this diversity, we can find it at varieties levels, at the clonal levels, and as we could see, we had different types of varieties, the international and the autochthonous ones. Italy is particularly rich of varieties, and the Italian growers tend to preserve those autochthonous and minor varieties. This diversity can be divided in 2 levels, the intervarietal level and the intravarietal level. The intervarietal level is the level that we saw when we compare different varieties. In the grape case, we can see, for example, Aglianico, Greco, Falanghina, or Malvasia. But at the intravarietal level, we have to look at the clones, because each variety is represented by clones. So we can see we can study the real genetic variability and identity of a variety only if we sample and represent it using different clones. Nowadays, there are a lot of works about the intervarietal diversity, but few studies are available on the intravarietal one. How can we work on it? As you could see from previous talks, we can do it using different tools, and the DNA-based ones are the most reliable ones, are the ones that we can use like fingerprints, because DNA molecular markers allow us to identify a genotype, a variety, a clone, in a unique way. Among all the different DNA markers that we know, the single nucleotide polymorphisms are the one with the highest resolution. So are the ones that make us able to distinguish not only varieties, but even clones. If you look at the graph, at the figure here, we have 2 sequences, clone 1 and 2. Comparing the sequences, we can find the differences, and those are actually the single nucleotide polymorphism, named also SNPs, and are those differences that are actually fixed in a population. How can we find them. We can use different technologies, and the high throughput ones are the technologies based on the extraction of DNA, the fragmentation, the digestion of DNA in fragments, and then the hybridization with adapters, and then the sequencing using next generation sequencing technologies, nanopore, or some other technologies. In plant, and especially in grape, have been used a lot of these technologies. In particular, the most used ones are the double digest restriction site association DNA-seq, DDRAD-seq, and the genotyping by sequencing, GBS. In our study, we collected more than 100 clones from Pupia and Campania in order to investigate for their diversity at the inter and intravarietal level, and in order to identify some genomic regions that are associated with their ability to adapt to climate changes or changes in the environments. In detail, we sampled 138 clones belonging to 3 varieties from Campania, Ianicolasco, Camaiola, and Greco Bianco, and 3 varieties from Apulia, Nero di Troia, Malvasia Nera, and Minutolo. Those grapes have been analyzed using DDRAD-seq technology for the Campania grapes and the GBS technology for the Apulian grapes. As you can see here, each variety has been represented by a different number of clones. So we did not sample just one clone per variety, but a different number of clones, because we needed to represent the variability of each variety. After first analysis, we were able to find almost 10,000 SNPs after filtering per each in average in our varieties. And looking at those SNPs, we searched for them that were landing within genes. And we found an average of 3,000 of SNPs in the Campanian grapes, and an average of 5, almost 6,000 of SNPs in the Apulian ones. These differences is made by the different technologies used, so DDRAD-seq and GBS. And so it was not unexpected. But it's really interesting that we were able to merge those data in line with the principle of the FAIR protocol, so to be able to merge data coming from different technologies. Now we had this set of SNPs. We could use this set of SNPs to look at our clones and try to find some duplicated clones. What does it mean? The duplicated clones are the ones that are sharing more than 99% of SNPs, and in all of our genotypes, we found 47 duplicated clones in Ianicolasco and 13 duplicated clones in Greco Bianco. So at the end, we got 78 individuals. It's really interesting because we were able to find the real number of clones that were representing that variety, and so it's really interesting for conservation of the genetic resources. This data set was used per each variety to study the linkage disequilibrium decay, and as you can see here, in the Minutolo, Greco Bianco, Camaiola, and Nero di Troia, the LD decay was very fast, while in Ianicolasco and Malvasia was slower at almost 200 kb, 250 kb for Ianicolasco and 100 kb for Malvasia. It's just meaning that those varieties got a selective pressure higher than the other ones on selected genomic loci. Now we could study the structured population of our varieties, and in this analysis we found a number of population of 7, not 6 as expected, because in Ianicolasco we differentiated 2 populations, AL1 and AL2. It's really it's actually reflecting the heterogeneous genetic reservoir of the Italian grape varieties. Indeed, we were able to identify identify 2 different varieties in a group of clones previously named Aia Nicolasco. And it has been also supported...
Time is gone, so...
Okay, just to finish, supported by the neighbor GENUINE-3. Among all the SNPs, 200 were not redundant and landing in genic regions and were identified that as signatures of divergence, and among all of them, the major part of them were involved in the primary metabolism, cellular component, and gene regulation, and among all of them, we selected some genes associated with adaptation, such as transposon mobility of genes under selection. To conclude, we were in line with the FAIR protocol, merging 2 different SNPs coming from 2 different techniques, and we were able to investigate the inter and intravarietal diversity, finding divergent genes that we will use for biotechnological application for grape breeding. So I would like to acknowledge my colleagues from University of Naples, from University of Bari, and CNR, and you for the attention.
Thank you very much for your presentation. You traced the road for the future to identify clones in the varieties. Thank you again. The next speaker is Maria, or Mariella Tortorella. She is Associate Professor in Information Technology at the University of Sannio, and the co-speaker is Prigioniero Antonello, who is a PhD student at the Department of Science and Technology. The lecture is New Holistic Database Concept for Agrobiodiversity Knowledge, Conservation and Protection, the DEGLI Experience. Prigioniero is the speaker, sorry.
Thank you. Thank you, Professor, for the presentation. Actually, we both performed the presentation. I introduced the frameworks, and then Professor Tortorella will explain to everybody the results of the DEGLI database. So, the problem to be the last presentation is that the risk is to be redundant, so I tried to synthesize my introduction, because other speakers just spoke about the issues that we are facing in this period. The modern agriculture system just flattened everything in all the biodiversity in the agrarian landscape. In the early 1999, just the FAO assessed that the most of the food need in the world is supplied just by 3 species: rice, maize, and wheat. And this is a problem because, as Dr. Nadozzi just spoke this morning, biodiversity loss induce an ecosystem service loss and a resilience loss. So less biodiversity could trick our survival in this world. So what we are doing to face these problematic issues. The first step was and is the ex situ conservation. However, only ex situ conservation could be considered as a static conservation. Removing plant genetic resources from the environment and put it in seed banks or in the field banks, it just frees their evolutionary potential. Another step in the right directions could be the integration between ex situ conservation with the in situ conservation. And the first step is the realization of the inventories of the in situ conservation. As Dr. Raggi, I use the same image, thank you, extrapolated from his works as just assessed. So, the Project DEGLI tried to explode this topic, tried to explode this approach. Our approach in the construction of the database is based on a multidisciplinary approach. This multidisciplinary approach involves the characterization of plant genetic resources and the data collection derived from this characterization, and all this data needs to be stored in a database, in an embedded database. This database will ensure the knowledge and the availability of this knowledge that, as Dr. Gutierrez said this morning, the most important part in the knowledge collection is that this knowledge cannot be freezed only in academic journal or in the academic rooms. So the knowledge needs to be available and fruitful to all the stakeholders at all levels. So we need to share the knowledge with the stakeholders and with the farmers. Only this sharing could ensure the valorization of plants' genetic resources, because only if a farmers know why for him it's valuable to cultivate a specific plant genetic resources, he will be how can I say it? He will be motivated to cultivate and preserve the plant genetic resource in field, active in determining an active conservation, a real active conservation. A real active conservation needs always needs a conservation network, a network that need in situ and ex situ conservation field. And this is the results of the conservation network of the EcoVale project for Campania region. We had 3 agricultural research centers, 4 universities inside the Campania region, 3 germplasm banks, 15 custodian farmers for in situ on-farm conservation, and 30 stakeholders. And the results of the interconnection of these partners, of these actors inside this project is depicted in the images. So the EcoVale project is structured with 10 targeted actions that you can see in the slide. These actions are all involved in the collection of data. In the collection of data derived mainly from the characterization. So with the characterization, genetic, morphological, biochemical, and agronomical, we can build our database. This database will be the base for the knowledge to be shared at all levels, at the researcher level, at the stakeholders level, and the farmers level. Only in this way we can reach the valorization useful for the active conservation, for the definition of an active conservation network. And with this, I stop my presentation and I left the stage to Professor Tortorella.
Thank you, Antonello. Good afternoon to everybody. I am the, how can I say, the out of chorus notes of this day, because I will not speak about the plant and about things that are cultivated, but I will speak about computer science. But it will last for a short time, so I will do quickly, don't worry. What I will present now is, I will shortly present, is the database, or better, the software system that has been developed within the project EcoVale. I say that it's a software system because it's not just a database, but integrates a set of tools that are used for adding information, for synthesizing information, for showing information. The database is achievable through the link that appears in the slide, and the aim, it has been designed and developed with the aim of providing a system that is useful within the project, but that is also useful for knowing and for understanding, for the people that do not work inside the project, for understanding what has been done, for using the data that has been collected within the project. For facilitating For facilitating the fruition of this data, the definition and the fruition of this data, have been chosen some technologies that made easy to the development of a tool that is easily adaptable to new exigencies and that is easily integrated with other with external application. So the technologies that have been used are listed in the slides. Are used last generation technologies like Spring Boot, Vaadin, and so on, but have also been used very diffused technologies such as SQL and Java that also the people that don't work in this field surely knew to speak about them. This brought to a tool that is multi-project, that is multi-language, a tool that integrates a different kind of data, different kinds of information, such as textual information, number, enumeration, images, files, and so on. And what is important is that this tool that we obtained is easily adaptable to new exigencies and is easily extendable to new needs. The aim that has been considered for developing it has been exactly this. It considers not just the researchers that worked inside the project. Many tools are defined just for the people that work in a specific field, and very often the information, the data that are collected are not diffused among the other people that from outside the system in the particular context, but the people that didn't work inside the project want to access. The tool is accessible to an anonymous user, a people that is not logged within the system, so everybody can use the results of the project. And for diffusing these results, it has been used a friendly interface for facilitating the understanding of the published data. An anonymous user can access to the data, but he cannot modify, obviously, the data, but can check the templates that are used for defining the database, and can access also to the collected data within the database. I didn't say that the database integrates all the information that Antonello spoke about. So it integrates morphological information, genetic information, and all the information of the different actions that compose the system. After, the logged user can access the system and can use it for inserting the results of his research. So by using an interface like similar to the one that you see in the slide, can evaluate all the species, the accessions, the genetic resources that have been charged in the database. After, he can generate some documents for showing the results of this research. So we have been careful to format the output of the insertion of the data in a way that the people that want to access this data can understand. Another important aspect of this tool is that localization information have been considered. So there is the localization component that permits to relate the collected data to the area where the species, the accessions, and so on have been cultivated. And this localization information are completely integrated with all the other data that have been considered, like genetic data, morphological data, biochemical data, and so on. In fact, going from the localization component, it's possible to access, with reference to a particular accession, can access to data like, such as the just clicking on the icon of the square that you see with the cherries, can access to all the other information that have been added in the system and that so are available. So a possible user can use this tool only also for increasing his knowledge regarding a certain resource, a certain species, and so on. Another component that on which I want to speak is something that is in phase of experimentation, is a component that can elaborate this data, because the single data is meaningless, but aggregated data can provide more knowledge about a particular phenomenon. So we are experimenting the possibility to integrate the application with the statistical component for obtaining this aggregated knowledge. And also in this case, the statistical component can be interfaced with all the other data that are collected within the database. So with the biochemical data, morphological data, and so on. We are also experimenting the use of tools for making the principal component analysis on the data that have been collected within the database, for understanding more some phenomena regarding the species that have been analyzed. So this is an ongoing process, an ongoing research also on the side of the software system component of the project. Even in this case, we analyze a different kind of data. So what I want to underline is that this software system go to integrate different aspects of a certain resource. And all these aspects are all available in the same time. So a researcher can switch from an aspect to another just with a simple click. Obviously, its usefulness is connected with the quantity of data that are inserting inside the database and with the quality of this data. If we can add, if we add data of good quality, we can obtain a resource of good quality. Obviously, there are many other aspects of the database that I didn't speak about, but with the time that ran, I said just the main things. What we can say is that the use of a structured database can enable the expansion of PGR's conservation network to various scale, up to the global scale, through communication and data exchange among different experiences. And we hope that our database permit to give a contribution in this direction. As I said, I just gave a quick description of the database. If somebody is interested, we are available also for making a demo of it, even after the end of this meeting. I hope I stayed in the time.
Yes.
Okay, thank you.
Thank you very much for your presentation. And I think many people will be excited about this software and will come to you for a demo, I'm sure about. Now, we can have a short discussion. Where is the boss? If there is any question, I leave you, where is the, I leave you my chair. I come here. If there is any question, please. You. Matthew.
Thank you, and thank you everyone for the talks. It was a question for Lorenzo, really, and I'm sort of thinking out loud as much as raising a question, perhaps, but I wondered whether you had any thoughts on the concept of land races in the world of tree fruit, well, what we refer to as clonal tree fruit. My understanding of much of the consideration around landrace conservation is based on an assumption that one's working with a population and a population that's under selection. And I wonder whether that matters or whether we need a slightly different definition in things like tree fruit, which are very heterozygous and not under selection in the same way, and they effectively randomize themselves on generation. So they're not under a consistent movement of selection in the way that an annual seed crop might be. Do you have any thought? Does it matter?
I think it is an excellent question, and thank you for asking, because I thought I didn't have time to put enough attention on this point that of course is very relevant. Also, as I said, I'm mainly involved in annual species analysis. So what you are underlining is perfectly true. I mean, the idea of variability, of evolving variability in situ, it easily applies to annual species where land races correspond to population with a certain level of genetic diversity. But for tree species, I think that it is still relevant, the idea of conservation in situ, because in that case, you can think to conserve different old varieties, or let's say land races, so that to increase the level of diversity in situ. Okay, we do not have this variety diversity because they are clones mainly, they are heterozygous, but still they are almost the same from a genetic point of view, even if Klitze demonstrated that there is kind of variability also between different clones of, different plants, individuals of the same clones. So, of course, differences are relevant between fruit trees, or let's say trees in general, and annual species when we talk about land races, but as I said, I think it's still relevant, this kind of in situ conservation. I hope this was, good for you.
Please.
Thank you so much. Just one question for Dottoressa Nunziata. I was thinking why technical guidelines to characterize, autochthonous varieties, autochthonous cultivars, because it seems to me quite strange to use a UPOV when you cannot claim any property rights on, public domain cultivars. Thank you.
There are several reasons for this choice. The first is that we wanted to give data that allowed us to compare to cultivars spread all over the world, so to identify our genotypes, even if they were taken abroad, and to point out eventual synonyms or homonyms. The second reason is that a local variety is, even if it is not protectable by plant breeders' right, is a common property of the people, of the local people. So it has to be correctly identified, so that if you make an essentially derived varieties from these or some other mating and some new varieties, you can have a good point of starting point for discriminating the new plant for plant breeders' right from the old varieties.
Thank you very much. I have three very brief questions to three different presenters. First to Ignacio.
Ignazio is connected.
If he's still online, yes, indeed. I would really like to hear his own perspectives about the outcomes of the COP15 on DSI, what, at least from his own perspective, maybe the European perspective, the implications for the upcoming negotiations under the international treaty, how that would impact those negotiations, or what directions it could go. And then for Lorenzo, very quickly, I wondered whether your project had any interface with some of the projects going on crop-wide relatives because of the co-occurrence of land races in protected areas with crop-wide relatives. Because to my mind, I think it would be an opportunity to really optimize resources if we were looking at crop-wide relatives within those protected areas as well, not just land races. And for Professor Tortorella, I wanted to ask quickly, what is new about the database that you're doing that existing databases are not providing? For instance, the ones that are either provided by UNESCO or Aegis or Genesis, which is much broader, global system of collecting information and data about plant genetic resources. And how do you hope to interface both technically and policy-wise with those pre-existing databases? Thank you.
Let's start from Ignazio, please.
Yes. Thanks, Ken. Yes, I read the resolution. I just highlight a few things that I think should be important, even for the FAO negotiation. One of the point of the resolution say that in the other fora might have independent rules. So I think in the FAO area, we need to move ahead and try to have our own rule about this issue, about the DSI. There is many other points, but I just highlight, I don't have the time, I just highlight the ones that for me it's really important for the treaty.
Okay, so maybe I didn't get perfectly your question. So you were asking why or how can we properly exploit the co-occurrence of land races and crop wild relatives in protected area? This was the question. Okay, for me this is a quite relevant point because when you talk about plant genetic resources, I mean land races and crop wild relatives, they are the two most important categories. And the fact that they are co-occurring in protected areas. I mean, we are now moving also from the Natura 2000 network, that was the first type of protected areas we considered because they are spread across all Europe. So it's quite relevant since the project was looking for establishing a network that was common to the whole Europe. So I think this is quite interesting because we have to think to these two types of resources, for me, also together. Because, for example, now also in the new call for a project from the EU, they are referring to crop wild relatives also in association with agriculture. So this concept of considering the two categories together, for me, is quite relevant. And it's relevant also in the light of protected areas that are already there, so we can leverage on these. Many of these we know the list of species that are occurring, so we can maybe in a more easy way try to move from a passive protection, that is what is happening right now, to an active protection where we can at least monitor the chances of this population. And that's my point of view.
Okay. Which is the difference of our database compared to the other? From the analysis that we did of the other database, what we saw is that each database is useful for a certain aspect. We believe that our database, the point of value of our database is that it comes from the contribution, from the suggestion of a variety of knowledge because the partner of the project, the people working inside the Eco Valley project have a different experience, study different aspects, and all their suggestions have been considered in the implementation of this database. Then the database, but I repeat, I call it more software system because it's something more of the database, but it integrates knowledge that are different. Very often the systems that are available are specialized on a certain aspect. In our database are considered different, all the experience come from different people. Not only the database has been implemented and the technologies that have been used has been chosen in such a way that a new experience, a new point of view can be, after an adequate characterization, can be integrated inside this database. So for us, the application that we developed, that is a result of the Eco Valley project, is not just a collector of data that have been developed during the project, but it's a tool that can help that can be expanded, that can be extended, that can be modified also for the aspects that are considered. It can be modified in the sense that a parameter, a value can be easily through the web changed by another research that can access to the application, to this software system.
So the next step will be to introduce the taste and flavor. Okay.
Why not? Next step.
Any further question? So, I thank all speakers. Thanks also to people who attended the meeting. I think that this meeting could be considered a think tank for the future of genetic resources. We had a lot of new ideas about how to keep going in the future. Thank you very much to everybody.
Short table at the end of the conference. I would like to congratulate all the speakers and the organizers for this very well done meeting now that it's done, it's over. And we will switch to Italian for this discussion because the main topic of the roundtable will be related to the project Eco Valley that you heard maybe during this conference. And there will be some of the representatives from the Ministry of Agriculture, the Italian Ministry of Agriculture and the Campania region. So that's why the language will be switched to Italian. Both this morning and today we heard a lot about some political issues related to the genetic resources, and so that's why we have invited the representative from our government. So I will switch to Italian. Abbiamo sentito questa mattina, anche oggi pomeriggio, come per qualsiasi strategia di conservazione, di valorizzazione, di raccolta di germoplasma, di risorse genetiche, sia importante la legislazione e gli indirizzi che ci dà la politica nazionale, internazionale e locale. Quindi per questo motivo abbiamo invitato, gli organizzatori hanno invitato a questa tavola rotonda rappresentanti del governo, dei ministeriali e della regione. Quindi con molto piacere inviterei il dottor Vincenzo Montalbano del Ministero dell'Agricoltura a dirci qualcosa sulla legislazione nazionale che attualmente impatta le risorse genetiche.
Grazie agli organizzatori per l'invito. Bene, parliamo un pochettino di risorse genetiche per l'alimentazione e l'agricoltura. Qual è il contesto nazionale allo stato attuale? Dopo la Convenzione sulla diversità biologica e il Trattato FAO, con la riforma del titolo V, le regioni hanno iniziato a legiferare in materia. Verso il 2010 c'erano circa 10 leggi regionali. Da lì è nata la necessità di un'armonizzazione a livello nazionale. Su richiesta delle regioni precedentemente c'era stato un lavoro che era stato portato in Conferenza Stato-Regioni, cioè il Piano Nazionale sulla Biodiversità di Interesse Agricolo, poi le linee guida per la caratterizzazione di queste risorse autoctone e successivamente nel 2015 è stata emanata la legge 194 del 1 dicembre dal titolo Disposizione per la tutela e la valorizzazione della biodiversità di interesse agricolo e alimentare. Strutturalmente la legge presenta 4 punti cardini, che sono l'anagrafe nazionale della biodiversità di interesse agricolo e alimentare, la rete nazionale, il portale e il comitato permanente per la biodiversità di interesse agricolo e alimentare. Altri articoli della legge riguardano principalmente tutte le azioni che vengono fatte a livello locale, quindi gli itinerari del cibo, le comunità del cibo, iniziative presso le scuole e soprattutto l'istituzione della Giornata Nazionale della Biodiversità di Interesse Agricolo e Alimentare. Su questo punto mi soffermerei un attimo perché quando si parla di biodiversità, stamattina abbiamo avuto modo di sentire più volte il termine biodiversità. Nell'opinione comune si tende sempre a pensare alla biodiversità naturale. Noi invece trattiamo la biodiversità di interesse agricolo e alimentare, l'agrobiodiversità, che sicuramente è un sottoinsieme matematicamente pensando, ma ha una sua specificità legata al fatto che l'uomo, che nel corso dei millenni l'ha selezionata, mantenuta e tramandata, così come i paesaggi. Stamattina si parlava di 300 generazioni che hanno tramandato queste risorse. Quindi a livello nazionale c'è questa legge che sicuramente ha una sua importanza. Non riguarda solo le risorse genetiche vegetali, ma anche gli animali e i microbi. Allo stato attuale l'anagrafe è in fase di completamento e anche il portale, quindi ci sarà un'interfaccia nazionale che raggrupperà tutte le iniziative a livello regionale, locale. Ci sarà quindi un unico punto di riferimento e sicuramente si andrà piano piano verso quella che è l'armonizzazione di tutte le iniziative che ci stanno a livello locale. Altre iniziative che porta avanti oggi il MASAF sono sicuramente tutte le attività che vengono fatte a livello internazionale per quanto riguarda il Trattato FAO. Il Ministero riferisce a livello internazionale sull'attuazione del Trattato FAO, che è stato ratificato con la legge 101 del 2004 e attualmente è impegnato, direi da diversi anni, soprattutto a cercare di far escludere le risorse fitogenetiche per l'alimentazione dell'agricoltura, non comprese nell'Annex 1 del trattato, dall'applicazione del protocollo di Nagoya. Voi sapete che il trattato FAO di per sé prevede un sistema multilaterale, stamattina è stato detto, mentre Nagoya è un sistema bilaterale con una serie di complicazioni non indifferenti. Il Ministero, riconoscendo proprio l'importanza delle risorse genetiche per l'alimentazione dell'agricoltura, oggi abbiamo visto che nella conferenza si parlava che non sono risorse che riguardano un paese, ma abbiamo avuto la possibilità di vedere come queste risorse hanno viaggiato nel tempo, ritornano, vengono valorizzate. E quando si parla di alimentazione, si parla di alimentazione che deve soddisfare un bisogno primario della popolazione mondiale. Quindi la politica del Ministero è stata sempre quella di dire c'è uno strumento giuridicamente valido, non dobbiamo ingessare il sistema, il mondo della ricerca ha anche la necessità di avere degli strumenti snelli e il trattato sicuramente dà la possibilità di poter scambiare queste risorse e valorizzarle in un contesto normativo sicuramente valido. Questo è quello che c'è a livello nazionale.
Va bene, grazie. Quindi ci fa piacere sapere che l'attenzione a livello nazionale sia sempre molto forte. Anche la nostra regione, la regione Campania, è molto attiva da un bel po' di tempo in questo senso, quindi chiederei l'intervento del dottor Casato e della dottoressa Di Mauro sulla situazione attuale della regione Campania e poi anche se ci danno qualche prospettiva, visto che sono i finanziatori del progetto di GOVALE.
Grazie a tutti per l'invito e grazie soprattutto a voi per essere ancora qui a quest'ora. Per quanto riguarda il modello organizzativo della Regione Campania a tutela della biodiversità, cioè delle risorse genetiche vegetali a rischio di estinzione, diciamo che il tutto comincia con il regolamento regionale numero 6 del 2012, reso poi attuativo dalla delibera di giunta regionale 260 del 2017. Il modello è basato su 4 strumenti fondamentali, cioè il repertorio delle risorse genetiche vegetali a rischio di estinzione, le banche del germoplasma, l'elenco regionale dei coltivatori custodi e la rete di conservazione e messa in sicurezza delle RGV. Per quanto riguarda l'elenco regionale delle risorse a rischio di estinzione, in pratica non è altro che, cioè il repertorio, voglio dire, non è altro che un registro in cui vengono di volta in volta inserite quelle varietà considerate a rischio di estinzione da un'apposita commissione tecnico-scientifica prevista dal regolamento e nominata con un decreto regionale, che ha fra i vari compiti anche quello di valutare se una cultivar effettivamente è da considerarsi a rischio di estinzione, quindi se è da inserire nel repertorio. Nel repertorio attualmente ci sono 260 RGV caratterizzati con i precedenti programmi regionali a valere sul PSR della misura 214 della programmazione 2007-2013 e grazie a quelle caratterizzazioni abbiamo quindi inserito nel repertorio 260 varietà, di cui ben 176, quindi più della metà, riguardano specie frutticole. Sì, confluite poi nell'anagrafe nazionale del Ministero. Se andiamo a vedere le diverse specie attualmente nel repertorio, abbiamo dei dati piuttosto preoccupanti per l'albicocco e anche per il melo e per il ciliegio, nel senso che di queste 176 varietà, 66 sono rappresentate dall'albicocco, 39 dal melo e 35 dal ciliegio. Questo ci fa fare delle riflessioni, cioè l'albicocco, cioè il ciliegio e il melo, che sono delle specie tipiche delle aree interne, ci fa capire che in queste aree probabilmente c'è un abbandono, a seguito dell'abbandono un po' dei territori, probabilmente stanno abbandonando anche la coltivazione di queste varietà. Ma il dato ancora più preoccupante è quello dell'albicocco. Se consideriamo che nei 10 anni di raccolta del germoplasma, che vanno dal 1992 al 2002 più o meno, quando abbiamo iniziato questa attività, abbiamo messo in collezione ben 125 varietà di albicocco, per la maggior parte proveniente dall'area vesuviana, e 66 sono a rischio di estinzione, cioè più della metà. Questo ci fa riflettere sulla possibilità di perdere un grande patrimonio varietale proprio nell'area che è da considerarsi il centro genetico principale dell'albicocco, non solo in Campania ma in Italia e forse in Europa. In parte a causa magari dell'eccessiva urbanizzazione che si ha avuto in quell'area, ma in parte anche per i vari problemi sia fitosanitari che di redditività scarsa della coltura in quelle zone. Un dato che può sembrare non preoccupante è quello del pesco, nel senso che abbiamo in conservazione soltanto 7 varietà di pesco, quindi a guardare così il dato sembra un dato non preoccupante, ma in realtà questo pesco è ancora più preoccupante dell'albicocco, nel senso che sempre in quei 10 anni noi abbiamo messo in conservazione 98 varietà di pesco. Dopo averle messe in coltivazione, in collezione in campo, dopo 7-8 anni il campo di pesco praticamente è stato attaccato da sciarca. Ora, come sapete, la sciarca è un virus da quarantena, quindi siamo stati obbligati ad abbattere il campo. Pensavamo di recuperare tutte le varietà che avevamo abbattuto, cioè dopo 10 anni di quelle 98 varietà ne abbiamo recuperate 7 e ancora oggi sono 7, quindi significa che in certi ambienti il depauperamento delle varietà a rischio di estinzione è spaventoso e quindi ben vengono tutti questi programmi a tutela della biodiversità. Per quanto riguarda l'elenco delle banche del germoplasma, noi abbiamo fatto in modo in questa programmazione che le banche del germoplasma fossero almeno 2 per questi problemi del pesco, fossero almeno 2 per ogni specie in conservazione in ambienti separati. Attualmente abbiamo 2 banche del germoplasma per quanto riguarda le erbacee, che sarebbe il CREA Orticoltura e Floricoltura di Ponte Cagnano e Arca 2010 SCARL Cooperativa di Acerra, e 3 banche per quanto riguarda le frutticole. In pratica abbiamo la prima banca presso il CRA in provincia di Eboli, dove stanno le 5 specie che hanno l'RGV a rischio di estinzione, cioè albicocco, ciliegie, susino, melo e pesco. Poi abbiamo il CREA OFA di Caserta, dove ne abbiamo 4 tranne l'albicocco, che invece è dislocato presso il Dipartimento di Agraria di Portici. Un altro aspetto che abbiamo dato molta importanza in questa programmazione è che fra banche del germoplasma e coltivatori custodi ci fosse un'integrazione continua e dinamica, cosa che non avevamo fatto nella precedente programmazione. Cioè, come avviene il rapporto fra coltivatori custodi e banche del germoplasma? In realtà l'elenco che abbiamo dei coltivatori custodi non è altro che un elenco di potenziali coltivatori custodi a cui può essere affidato poi successivamente l'incarico da parte della banca del germoplasma. Perché dico di potenziali? Perché quando l'agricoltore custode fa la sua istanza e che arriva in regione, una apposita commissione andrà a valutare se quel coltivatore custode ha i requisiti per poter diventarlo. E una volta inserito poi nell'elenco, la banca del germoplasma, che può consultare l'elenco con delle credenziali fornite dalla regione, va a vedere, in base alle necessità che ha la banca di moltiplicare quel materiale in quel periodo, va a vedere qual è l'agricoltore custode che è più idoneo a quella riproduzione e affida l'incarico. Quindi l'incarico avviene mediante una convenzione fra banca del germoplasma da una parte e coltivatore custode dall'altra. Quali sono gli impegni fra le 2 parti? La banca del germoplasma fornisce all'agricoltore custode soprattutto un'assistenza tecnica, sia dal punto di vista fitosanitaria che dal punto di vista dell'identità varietale di quello che coltiva l'azienda. Nel senso che la banca fornisce all'azienda un materiale sicuramente sano e di identità certa, però aiuta l'agricoltore a capire se nel corso della coltivazione ci sono poi problemi fitosanitari, cioè qualche pianta fuoritivo da scartare nella coltivazione stessa. L'impegno da parte del coltivatore invece qual è? Noi abbiamo fatto in modo che per ogni coltivatore al massimo potesse moltiplicare 5 RGV. 5 RGV con 5 piante per ogni RGV, quindi massimo 25 piante. Per ogni RGV il coltivatore deve fare una parcella quindi di 5 piante da tenere sotto controllo nel corso della coltivazione. Piante che possono essere ex novo oppure piante anche già detenute dal coltivatore che verranno poi etichettate in campo e seguite. In cambio il coltivatore fornisce alla banca buona parte del materiale riprodotto, quindi buona parte delle mazze che produce, e in cambio dell'assistenza tecnica data dalla banca. Una parte del materiale può usarlo nella propria azienda per moltiplicare ulteriormente le varietà nell'ambito dell'azienda stessa. Quindi come vedete è un rapporto veramente questa volta diciamo, molto continuo e integrato fra coltivatori custode e banca del germoplasma. All'interno della rete poi il materiale può circolare, diciamo che in prima istanza avevamo pensato di farlo circolare liberamente, ma poi ci siamo posti il problema dei controlli fitosanitari e come dire, dell'identità varietale. Quindi in questa fase noi stiamo facendo in modo che tutti gli iscritti nella rete di conservazione, quando vogliono accedere diciamo, a una RGV, la chiedono direttamente alla banca del germoplasma. Quindi diciamo, le banche si stanno sobbarcando anche diciamo, questo impegno aggiuntivo di dare, oltre non solo diciamo, agli agricoltori custodi, ma anche al resto della rete, le RGV che sono richieste. Prospettive future. Noi ci auguriamo che con questi progetti, sia con la vecchia programmazione che questi quadri attuali, dalle informazioni che riusciremo a tirare fuori, la speranza è che riusciamo a costruire delle piccole microfiliere magari che possono creare reddito, diciamo, lavoro e soprattutto presidi del territorio, e in particolare nelle aree interne. E l'altro auspicio è che ci possa essere la diffusione di alcune varietà, magari diciamo, particolarmente resistenti ai cambiamenti climatici che abbiamo attualmente o alle fitopatie, in un contesto diciamo, dove quindi in un ecosistema agrario dove si può aumentare la resilienza del sistema stesso.
Bene.
Grazie.
Non so se la dottoressa Di Maro vuole aggiungere qualcosa.
Velocemente, perché il collega ha già esposto, quindi non mi soffermo sul sistema. Il sistema diciamo che è stato come dire, implementato con la misura 10.2.1 da cui parte il progetto di Covale. Voglio dire soltanto che questa tematica, anche come ha testimoniato la presenza dell'assessore stamattina, ci tiene molto la biodiversità, tant'è vero che anche nella futura programmazione ha inserito di nuovo questa tematica e ha investito per questa specifica tipologia diciamo, di intervento. Per intenderci, questo è considerato un intervento a investimento, non a superficie, anche se sta nelle misure agroambientali diciamo, perché per la funzione che svolge la biodiversità sull'ambiente, come sappiamo. Non mi soffermo su questo, Valenti sono stati molto ben esposti le tematiche stamattina. Quindi la tematica è molto sentita ed è stata tramutata e diciamo, è stata anche questa volta, farà parte anche questa volta, è stato messo nel cosiddetto PSP, questo programma adesso nazionale, adesso c'è un programma unico nazionale di sviluppo rurale e poi le varie regioni, non si chiama più PSR ma si chiama complemento di sviluppo regionale, sarebbero i PSR regionali, diciamo così. Ha inserito questa scheda che appunto prevede ancora azioni di conservazione, di caratterizzazione, quindi le cosiddette azioni mirate, e azioni di concertate e di accompagnamento. Le azioni concertate, per intenderci, ne abbiamo adesso come dire, un esempio concreto, questa concertazione che valentemente dell'Unisani insieme al CRA, insieme all'Unina, insieme al CREA, a tutte le altre università e i centri che fanno parte, stanno creando questa concertazione anche con paesi sia UE che extra UE. Quindi queste iniziative, dicevo, potranno far parte saranno parte integrante della nuova programmazione. Però questa volta noi vorremmo, come diceva il collega, noi stiamo cercando di, faremo tesoro, come abbiamo fatto nel passato, dei vecchi risultati per organizzare, per programmare il nuovo. E ci piacerebbe molto, vorremmo fare una scommessa, che lo so che a volte chiediamo molto agli enti di ricerca, che già di loro devono fare delle attività di ricerca, diciamo, che li impegnano tantissimo, però noi ci teniamo molto a quello che poi col trattato FAO si intende fare, cioè a portare all'utilizzo di queste risorse genetiche, utili, non tutte magari, ma utili per l'alimentazione, no? Perché noi pensiamo che solo l'utilizzo delle risorse farà in modo che queste ne scompaiano, non muoiano del tutto, si mantengano. Il collega ha parlato del sistema che la Regione ha messo in atto per le risorse genetiche a rischio di estinzione che abbiamo messo in questo repertorio, ma noi stiamo con questo progetto di Covale si stanno studiando molte altre risorse genetiche che non sappiamo se sono a rischio, lo sapremo alla fine dei risultati, quando avremo tutte le caratterizzazioni e le descrizioni. E quindi è questo che noi, diciamo, qual è la sfida? La sfida e vi prego di provarci insieme a noi, fare in modo che possa accadere, che di costruire dei progetti per alcune produzioni, dei progetti di filiera, dei progetti territoriali, dei progetti, come dire, integrati, cosiddetta la progettazione integrata, che non è soltanto quelli di cooperazione, no? I progetti della cooperazione con la ex misura 16 che hanno messo insieme più soggetti, ricerca, aziende agricole e altri stakeholder, ma anche mettere insieme più misure del PSR. Se noi riuscissimo e la Regione, devo dire la verità, su questo ci sta lavorando, che nel nuovo programma di sviluppo rurale, nel complemento di sviluppo rurale, quello regionale della Campania, questa tematica sta dentro, diciamo, questo. Chiaramente è un metodo, la progettazione integrata è un metodo, non ci saranno dei fondi specifici per la progettazione integrata, perché ogni misura avrà la sua dignità, la sua, no? Però la sfida è quella di riuscire a metterle insieme queste, presentare un unico o un soggetto unico che presenta un progetto su più misure, oppure più beneficiari che attingono, appunto, come può essere come quello che si è strutturato per Dicovale, ma anche allargato ad altri, che metta dentro anche quei soggetti che possono farlo sviluppare veramente la filiera, perché quello che manca, molti ci chiedono, e così potremmo popolare quel database bellissimo. Faccio i complimenti al progetto e a tutti voi che ci fate rincuorare quando vediamo queste cose che fate. Potremmo aggiungere dentro quel database altre informazioni, che potrebbe essere dove si trova l'azienda che coltiva quella risorsa, chi la trasforma, dove posso trovare il prodotto, perché poi alla fine i consumatori a volte questi ci chiedono: sì, vabbè, abbiamo tutta questa biodiversità in Campania, lo sappiamo che siamo ricchi di biodiversità, ma io se volessi trovare, se volessi mangiare o se volessi mettere in coltura, dove la trovo questa risorsa? Ecco, la nostra sfida che vorremmo fare insieme a voi, speriamo che, e io proporremo di fare anche degli incontri specifici di come poterli, per la nuova programmazione, come è possibile fare queste interazioni, no? Questi progetti integrati specifici anche per la biodiversità. Mi auguro che possiamo raggiungere anche quest'altro importante pezzo.
Va bene, grazie. D'altra parte penso che con questo progetto si sia messa su una rete che è un peccato poi far perdere, quindi penso che tutti quanti noi siamo con voi, quindi se voi siete con noi siamo con voi, ci sono tanti enti coinvolti, per cui...
Sapendo che l'azienda agricola, gli agricoltori, i coltivatori sono i veri custodi di questa biodiversità, le banche ci servono, per carità, servono anche per gli studi, per fare quelle cose che diceva Gennaro, anche per vedere se ci sono delle varietà che abbiano delle caratteristiche utili per far fronte a questi cambiamenti climatici che ci stanno addosso, però ecco, noi speriamo che con l'azienda agricola vivono, la biodiversità vive attraverso le gambe e la cultura e la coltura delle aziende agricole.
No, magari fare delle filiere con queste varietà più, diciamo, che hanno caratteristiche particolari. Io mi rendo conto che queste varietà, per essere abbandonate, qualche difetto devono pure averlo, no? Spesso, diciamo, le varietà che dal punto di vista, diciamo, organolettico sono le migliori, dal punto di vista aromatico, di sapore sono le migliori, hanno altri difetti, quali ad esempio, non so, la polpa, cioè il colore della buccia sbiadita, la polpa bianca, sono deliquescenti, quindi non adatte ai trasporti, e siamo d'accordo, quindi, diciamo, non possono andare su grandi distanze e quindi non possono essere conosciuti altrove. Però fare delle filiere, delle microfiliere locali, dove il prodotto magari può stare sui mercati locali velocemente, o se non riusciamo a far viaggiare il prodotto tal quale, il prodotto naturale, riusciamo a far viaggiare il trasformato, cioè riusciamo a fare da queste varietà, non so, dei succhi di frutta, delle confetture, delle crostate con queste marmellate particolari. E diciamo, fare degli angolini nelle GDO, diciamo, immagino io, questo è un percorso, diciamo, che ho in testa io, degli angolini in una GDO con prodotti provenienti dalle nostre RGV, sarebbe una bella cosa, però dobbiamo capire intorno al tavolo poi chi dobbiamo mettere, diciamo, nella futura programmazione. Quindi probabilmente dobbiamo mettere non solo il produttore, ma anche il trasformatore e anche magari il consumatore, anche le GDO. un discorso non semplice, però speriamo di farci. Noi speriamo che ce la caviamo. Che ce la caviamo. Okay.
Gli strumenti li dovete legare tra di loro, diciamo.
Sì, sì. Va bene, quindi in questo ambito, vabbè, ci hai dato dei dati per il pesco impressionanti, da qui l'importanza di questi progetti e poi avete nominato... no, infatti...
E la cosa preoccupante adesso è per l'albicocco nella zona vesuviana, che anche lì la sciarca sta facendo i suoi
il problema.
Anche lì nella zona vesuviana la sciarca il professore qui ha cercato di recuperare delle varietà che abbiamo perso, non è riuscito a recuperarle, ma non perché non si trovano, ma perché sono affette da sciarca. Quindi il problema sta diventando molto molto serio.
E quindi DEGLI si inserisce proprio in questo ambito. Da qui adesso tocchiamo dei flash sul progetto che penso sia stato sia ancora un progetto di successo. Quindi avete nominato gli agricoltori custodi. Chiederei a Massimiliano Mercede di dirci qualcosa che rappresenta un fiore all'occhiello, penso, per DEGLI, no? Quello degli agricoltori custodi.
Sì, buonasera a tutti intanto. Il mio intervento si unisce perfettamente a quanto detto dal dottore Casato e dalla dottoressa Di Mauro, perché si è parlato di futuro, di programmazione futura, di progettazione territoriale mirata. E in questo momento, ad esempio, io sono politicamente impegnato nel mio territorio, essendo assessore all'ambiente, proprio dell'agro-nocerino sarnese. Quindi i dati che sono stati tirati fuori da questo progetto di Covale, posso avere l'opportunità di poter iniziare dal nostro territorio a fortissima vocazione agricola, proprio per vedere come recuperare le specie che si sono estinte nelle nostre zone. Perché stiamo parlando di specie in via di estinzione, coltivatori custodi, quindi come responsabile scientifico dell'azione A1 del progetto collettivo abbiamo selezionato dal repertorio regionale 15 coltivatori custodi nella regione Campania, un po' di tutte le province, 4 in provincia di Caserta, 4 agricoltori in provincia di Napoli, il resto nelle province di Avellino, Benevento e Salerno. E a questi 15 coltivatori custodi quindi sono state assegnate 30 RGV appartenenti alle 5 specie elencate prima, e di ogni RGV abbiamo dato 5 marze. E abbiamo seguito in questi anni quelle che sono state le varie operazioni condotte dagli agricoltori, quindi le operazioni di innesto, le cure culturali, i vari trattamenti, quindi tutto annotato sul registro che è stato consegnato a loro, il registro delle attività, delle operazioni, e alcune attività per alcuni agricoltori sono andate avanti, per altri meno, però siamo intervenuti perché siamo in continuo contatto con gli agricoltori, quindi abbiamo sostituito le marze che non avevano attecchito, quindi ad oggi bene o male tutti hanno in campo queste varietà. E siccome il progetto è stato prorogato fino a gennaio 2024, quindi continueremo a fornire, se ci fosse la necessità, le marze quindi a quegli agricoltori che qualora ne hanno bisogno. Quindi diciamo che questa attività sugli agricoltori custodi è strettamente quindi correlata all'attività che abbiamo in campo presso quindi l'improsta, quindi con la banca di germoplasma, e quindi abbiamo individuato le piante madri, sono state individuate, curate, seguite e censite soprattutto nell'azienda, e da lì ricaviamo quindi le varie marze per poterle poi distribuire sul territorio.
Vabbè, grazie. DEGLI, oltre alla conservazione, prevede anche un'importante caratterizzazione, no, del materiale. Qualcosa abbiamo anche ascoltato oggi, quindi chiederei alla dottoressa Annunziata di dirci qualcosa sulla caratterizzazione fenotipica come rappresentante del CREA.
Come in parte ho anche anticipato prima, la caratterizzazione di tipo fenotipico è stata soprattutto di tipo morfologico e di tipo agronomico sotto la direzione del professor Di Vaio. Quindi la caratterizzazione morfologica ad integrazione di quanto detto precedentemente si è basata sui descrittori UPOV, ma per un'istanza di internazionalizzazione fondamentalmente dei risultati, ma si è accompagnata ad una accurata documentazione fotografica, e anche le fotografie, che sono comunque in alta risoluzione e consentono una revisione critica dei descrittori così come rilevati grazie ai dettagli che forniscono, sono integralmente consultabili sulla banca dati di cui ci parlava la professoressa Tortorella. Dal punto di vista, oltretutto, ecco, mi occorre precisare che il caso del pero è un caso particolare, perché è un caso in cui effettivamente la collezione che noi comunque avevamo al CREA era stata persa, per questo abbiamo dovuto ricorrere a un nuovo recupero di cultivar. Per altre specie invece noi avevamo un campo di conservazione già allestito, già in fase di fruttificazione, per poterlo osservare. E questo ci ha consentito di fare anche una caratterizzazione di tipo agronomico, che ovviamente va presa per quello che è, cioè è fatta in un campo in cui le parcelle, per quanto contengono un numero sufficiente di piante, non sono randomizzate, per cui ci potrebbero essere diciamo delle ulteriori evidenze, c'è molto da approfondire. Però ci siamo concentrati su dei parametri che insomma aveva senso caratterizzare in queste condizioni, per cui ci siamo focalizzati soprattutto su caratteri come il grado Brix, la precocità di maturazione, le dimensioni, quindi il calibro dei frutti, e tutte queste osservazioni sono state fatte in condizioni di allevamento tali da garantire diciamo un basso input dal punto di vista degli interventi colturali, per cui si sono preferiti porti innesti diciamo sicuramente non nanizzanti, che consentissero uno sviluppo della pianta secondo la sua naturale propensione, e anche le forme di allevamento si è preferito il vaso insomma ovunque fosse possibile, in modo da ridurre al minimo gli interventi di potatura e quindi l'impatto delle attività di controllo agronomico su quella che è poi la performance produttiva dei frutti. Anche tutti i dati agronomici saranno disponibili sulla banca dati, lo sono già in parte, come ha detto la professoressa, e corredati anche loro da una documentazione fotografica.
Va bene, e c'è da dire che a fianco a questa caratterizzazione fenotipica che ha descritto la dottoressa Annunziata c'è anche una importante caratterizzazione dal punto di vista biochimico, nutrizionale, che poi va in linea con quelli che sono i desiderati della regione, cioè avere poi un risvolto pratico e applicativo dei risultati delle attività svolte. E poi un'altra importante attività che è stata più volte richiamata stamattina è quella che fa riferimento alla caratterizzazione molecolare, che da una parte assiste la caratterizzazione morfologica, dall'altra anche va incontro a quello che è una possibile utilizzazione del materiale, che potrebbe presentare dei difetti o mancare di alcune caratteristiche importanti che invece l'analisi genetica potrebbe mettere in risalto, e quindi consentire poi l'avvio di programmi di miglioramento genetico che potrebbero portare a nuove importanti varietà. Quindi chiedo la cortesia alla collega dell'Università del Sannio, con cui collaboriamo, la professoressa Sciarrella, di dirci qualcosa su questa caratterizzazione.
Allora, buonasera a tutti. L'azione A7 è appunto la caratterizzazione molecolare delle specie che fanno parte del progetto di GLOBALE, è svolta sia da Unisannio ma anche da Unina e dal CREA, sotto la direzione quindi del professore Carputo e del professore Guarino, che ne è coordinatore di questo progetto. Sostanzialmente abbiamo creato l'impronta genetica delle singole di ciascuna RGV di cui fa parte il progetto mediante microsatelliti e SNP, al fine anche di ottimizzare quelle che sono le strategie sostanzialmente di conservazione, visto che in realtà il progetto ha ben 3 azioni definite proprio su questo tipo. E quindi, ancora di più, in queste azioni abbiamo cercato di identificare un set di marcatori molecolari che noi denominiamo genotipo specifici, appunto per tracciare scusate il termine di parole, la tracciabilità di ogni singola RGV all'interno di una filiera già in parte inserita in certificazioni, al fine anche, come si diceva prima e come diceva la Regione, di valorizzare ancora di più queste che sono sostanzialmente le RGV campane che fanno parte del progetto di Covale. Anche noi, come del resto tutte le azioni mirate, concertate e di accompagnamento sono state inserite all'interno del database precedentemente illustrate, per cui possiamo dire che il progetto per quanto riguarda la caratterizzazione molecolare dell'RGV si può dire essere quasi, se non del tutto, completato.
Sì. E poi c'è da dire anche che nel database i dati molecolari saranno fruibili non soltanto per gli esperti del settore, ma anche per un pubblico un po' più che non conosce molto bene l'argomento, quindi questo aspetto sarà anche fruibile per, diciamo, per tutte le platee. Questo penso che sia molto importante. Il database è stato progettato anche per questa duplice funzione. Vedo una mano in evidenza del dottor Verde. C'è qualche domanda oppure è un errore di battitura sulla tastiera? Forse era... vabbè. Ok, quindi...
No, volevo fare... No, ci sono, volevo fare una domanda e un'osservazione. La domanda è rivolta a Vincenzo. Se avete finito il giro, ovviamente, se è finito il giro della tavola rotonda intervengo dopo, non è un problema per me.
Non abbiamo capito bene, può ripetere per cortesia?
No, allora ho una domanda per Vincenzo Montalbano e un'osservazione da fare generale. Però dico, se voi stavate facendo ancora la tavola rotonda, se c'era un giro di chiamate, posso intervenire dopo? L'ho alzata semplicemente per dire che volevo dire qualcosa. Quindi se posso intervenire ora va bene, altrimenti intervengo dopo.
Prego. Se è una cosa veloce sì, altrimenti rimandiamo alla fine.
No, vabbè, allora la domanda veloce a Vincenzo Montalbano è a che punto siamo con il recepimento di Nagoya? Questo è un punto molto importante che attendiamo ormai da diversi anni. Al limite l'altra osservazione la facciamo alla fine, facciamo fare il giro e intervengo alla fine.
Dice a che punto siamo con la ratifica del protocollo di Nagoya, mi pare di aver capito, giusto?
Sì, esatto.
Ok, come ben sai la ratifica dei trattati internazionali dipende dal Ministero degli Affari Esteri. Più volte hanno trasmesso dei disegni di legge di ratifica del trattato fino all'ultimo. Uno degli articoli prevedeva proprio quanto io ho poco fa annunciato, cioè che tutto ciò che è di interesse agricolo e alimentare viene di fatti escluso dall'applicazione del protocollo di Nagoya, quindi coerentemente con quanto previsto nel trattato. Questa è una battaglia che facciamo dal 2015, le posizioni dei ministeri sono state sempre diverse. Il Ministero oggi, il MASAF, quindi il Ministero dell'Agricoltura, della Sovranità Alimentare e Forestali, ha sempre sostenuto che tutto ciò che riguarda la risorsa fitogenetiche per l'alimentazione e l'agricoltura, per l'uso ovviamente agricolo, perché se parliamo di uso di farmaceutici industriali ovviamente si applica Nagoya, deve essere escluso dall'applicazione proprio dal protocollo di Nagoya. Mi risulta che dovrebbero mandare un altro disegno di legge, perché non ti sto a dire quanti sono i ministeri interessati, a parte il Ministero oggi della transizione ecologica, il Ministero dell'Economia, lo stesso Ministero degli Affari Esteri. Sicuramente noi manterremo sempre quella linea. Non intendiamo arretrare. Oggi tra l'altro questa conferenza ha confermato l'importanza delle risorse fitogenetiche per l'alimentazione e l'agricoltura, quindi aspettiamo che arrivi il disegno di legge. Non sappiamo. Sai benissimo, hai un po' seguito la vicenda dal 2015, 7 anni per ratificare un trattato, comprendiamo bene come è complicato.
Le mie perplessità che vedevo in faccia erano queste. Sono 7 anni che aspettiamo questa cosa. È importante, è importantissima questa cosa.
Lo so.
È stato appena accennato, ma è importantissima. Va bene. Aspettiamo, poi al limite intervengo alla fine. Finite per favore, scusatemi se ho alzato la mano prima del necessario.
Nel frattempo, per non restare fermi, le regioni possono... Nel frattempo, dico, che venga ratificato questo protocollo, noi per esempio abbiamo fatto una sperimentazione grazie anche all'aiuto del dottor Marino e anche sentito il Ministero dell'Ambiente. Abbiamo esteso l'accesso a una risorsa a rischio di estinzione che avevamo del pomodoro, che come sappiamo come specie non è inserita nell'ANNE 1 e quindi doveva rientrare nel protocollo, sarebbe dovuto rientrare nel protocollo di Nagoya se non passa questa linea natura, però la Regione ha scelto di dare libero accesso alle risorse genetiche iscritte al repertorio. Fino a che non c'è una legge che ce lo vieta, noi continueremo a farlo. Quindi forse se non hanno questa linea conviene che non la ratifichiamo proprio.
Prima o poi dovrà essere ratificato.
Potrebbe essere una scelta non ratificarlo. Se non passa quella linea che noi condividiamo, che tutte le risorse genetiche, interesse agricolo e alimentare, debbono essere escluse dal protocollo di Nagoya e rientrare nel trattato FAO, cioè usarle allo stesso modo con l'accesso che concediamo. Scusate,
no, va bene, grazie. Va bene, allora concluderei col professore Di Vaio perché parliamo anche nell'ambito del progetto di campi catalogo, c'è un'importante attività, quindi prego.
Buonasera, io mi aiuto un attimo con una breve presentazione perché a questo punto veramente siamo un po' tutti quanti stanchi. Comunque, un attimo che parte. Vado direttamente alla parte che ci interessa perché altrimenti... Che cosa dire? Che sia io che il mio gruppo nell'ambito di DICOVALE ci siamo interessati di 2 aspetti. Uno è, già detto, è la caratterizzazione agronomica. Io ho coordinato questa azione, abbiamo lavorato su 135 accessioni di 12 specie che qui vedete elencate, dall'albicocco, ciliegio, susino, melo, pero, limone, cachi, fico, melograno, noce, nocciole e vite. Hanno partecipato a questa azione non solo noi del gruppo della Federico II, quindi di Portici, ma anche il CREA con la dottoressa Annunziata e la dottoressa Petriccione. Ovviamente questo è stato già detto, un aspetto molto importante in quanto si è voluto fare una valutazione, diciamo, produttiva di queste accessioni in termini sia di quantità che di qualità del prodotto, oltre a valutarne anche gli aspetti vegetativi. Ovviamente non mi sto a dilungare su questo aspetto perché sicuramente prossimamente faremo un incontro specifico e lì porteremo i dati che poi in buona parte sono già stati inseriti nel database e là possiamo fare tutta una serie di elaborazioni e di esposizione dei dati. Altro aspetto su cui abbiamo lavorato a Portici è stato sulla conservazione delle RGV. In particolar modo si è andato a completare il raddoppio di tutte le accessioni conservate da parte della Regione Campania. Quindi insieme all'azienda Improste e all'azienda di conservazione del CREA abbiamo costituito un nuovo campo catalogo presso il Dipartimento di Agraria. Qui nell'ambito del Parco Cussoni abbiamo individuato un'area di circa 1,5 ettari e abbiamo individuato una serie di aree, come vedete in questa slide, che hanno riguardato la collezione del nocciolo, della vite, dell'albicocco, del limone e dell'olivo. Per quanto riguarda l'albicocco, abbiamo in collezione a Portici circa 83 accessioni, per 4 piante, ogni accessione è moltiplicata per 4 piante, innestate su Mirambolano 29C, allevate a vaso. Sono state prelevate in buona parte dalla collezione dell'improsta e per un'altra parte invece sono state da noi individuate, diciamo, sia nell'ambito di tutta la regione Campania, ma in particolar modo della zona vesuviana. E qui purtroppo ci siamo scontrati anche col problema che si diceva precedentemente della sciarca e quindi ci siamo dovuti fermare e quindi non siamo andati oltre per circa 6-7 accessioni. A questo riguardo ci sarebbe ovviamente da intraprendere un'azione di risanamento di queste varietà proprio per poterle poi, una volta risanate, portarle in collezione e quindi in conservazione. Ecco, qui vedete alcune foto di queste accessioni, molte di queste sono di origine vesuviana, anche i nomi ce lo fanno ricordare, come la pellecchiella, la persechella e così via. Qui è riportato, diciamo, per le 13 varietà che riguardava la caratterizzazione agronomica all'epoca di raccolta, e si vede come queste accessioni si distribuiscono in un periodo piuttosto limitato che va dal 15 giugno all'8 luglio. Qui invece è una parte dei dati della caratterizzazione agronomica, vedete un'indicazione per quanto riguarda, diciamo, la vigoria della pianta misurata come area della sezione del tronco oppure della produzione per pianta, oppure per indice di produttività calcolato fra un rapporto fra produzione e area della sezione del tronco. Per quanto riguarda l'olivo sono state messe in conservazione 60 accessioni, qui ci siamo rifatti anche qui in parte all'improsta, perché alcune di queste già erano in conservazione all'improsta e altre invece abbiamo fatto ricorso alla banca del CREA di Rende, dove gentilmente, diciamo, i ricercatori della sezione di Rende ci hanno messo a disposizione le talee e qui l'abbiamo messe a radicare. Abbiamo qui, diciamo, complessivamente 240 piante allevate, in questo caso a monocono. Qui vedete alcune schede di queste varietà molto diffuse nell'area, diciamo, interna della Campania, come il beneventano con l'ortolana, e anche della zona, per esempio, dell'avelinese come la ravece. Infine, oltre abbiamo un campo che riguarda la vite con 50 accessioni, questi sono innestate su 110 richter e qui ci siamo rifatti in parte sempre al campo catalogo dell'improsta, quindi del CRA, e un'altra parte ci sono stati concessi diversi vitigni da parte del campo di Turi, quello del CREA, diciamo, sito in Puglia. Ecco, qui vedete alcune di questi vitigni, sia a bacca bianca che a bacca rossa. Per il nocciolo abbiamo in collezione 8 accessioni, fra le più diffuse a livello campano, come la Tonda di Giffoni, la San Giovanni e quant'altro. E qui è stato il campo di Caserta che ci ha messo a disposizione queste accessioni, sono state propagate per polloni e quindi poi portate in collezione da noi. Qui vedete, diciamo, i frutti delle diverse varietà. E infine l'ultima specie di cui abbiamo in collezione a Portici riguarda il limone, con 5 accessioni, fra le più conosciute a livello campano come l'ovale di Sorrento, lo sfusato amalfitano, il limone di Procida, questi tutti quanti innestate su arancio amaro. Queste sono alcune delle caratteristiche dei frutti, come il peso, il volume, il peso del seme, il numero di semi e la resa in succo. Ancora qualche particolare per quanto riguarda i frutti, e poi voglio un attimo ringraziare tutti coloro del mio gruppo che mi hanno ovviamente aiutato in questa analisi, in questo studio. Grazie.
Va bene, se c'è qualche commento veloce a questa parentesi che abbiamo aperto un po' contestualizzando DEGLI al convegno di questa mattina, se c'è qualche commento possiamo velocemente svilupparlo, visto anche l'orario, forse. Sì, sì.
Vediamo se ci sono mani alzate.
Va bene, allora io ringrazio di nuovo gli organizzatori, il professore Guarino in primis, tutto il gruppo dell'Università del Sannio, ringrazio tutti quelli che sono stati...
Ignazio forse.
Ah, va bene.
Ignazio.
Prego.
Sì. No, buongiorno, io volevo fare una piccola osservazione, un po' in controtendenza se volete. Qualcuno ha detto, credo la dottoressa Di Mauro, che la conservazione va fatta preferibilmente in azienda, quindi in coltivazione. Ora, io sono perfettamente d'accordo che se qualcosa viene coltivato sicuramente non lo perderemo, su questo non ci sono dubbi. Però vorrei un attimo che guardassimo i numeri. Stamattina Massimo Gardiman in una delle sue diapositive ha mostrato i numeri in Europa, ad esempio. Noi in Europa nel sistema EURISCO sono incluse 2 milioni di accezioni. Ora, non possiamo pensare che noi dobbiamo coltivare 2 milioni di accezioni. Nel momento in cui noi coltiviamo, si parla delle accessioni delle varietà antiche coltivate, parliamo di centinaia. La conservazione ex situ è importante tanto quanto la conservazione on farm. Su questo non ci sono dubbi. Noi dobbiamo conservare, dobbiamo fare tutti gli sforzi possibili per conservare. Anzi, io direi che è più importante la conservazione ex situ della conservazione. Capisco che è forte come cosa, quindi questo è quello che voglio far passare. Se noi non avessimo conservato in ex situ FS17, che era una delle varietà che attualmente un semenzale anonimo è resistente a Xylella, l'avremmo perso, per cui è importantissimo secondo me la conservazione del sito. Le banche di germoplasma sono uno strumento indispensabile. Pensare di poter sostituire le banche di germoplasma con la coltivazione on farm secondo me è utopico. Questa è la mia visione. Faremmo quello che è successo dalla notte dei tempi, dalla domesticazione fino a Vavilov. Se queste varietà sono state abbandonate, qualcuno ha detto, lo riprendo, vuol dire che in qualche modo erano obsolete. Tutto ciò che negli anni, nei secoli, nei millenni è diventato obsoleto perché c'era una novità, gli agricoltori innovano sempre, se trovano qualcosa di migliore lo adottano. Negli anni, nel corso dei secoli e dei millenni, tutti questi geni sono stati persi perché non sono stati coltivati. Oggi abbiamo uno strumento in più, che sono le banche di germoplasma. Quindi io non vorrei sminuire né l'uno né l'altro. Questo era la mia, forse un po' polemico, però questo è il mio pensiero.
Dottore, rispondo io, ma non perché per qualcosa, perché sono direttamente interessato a questa conservazione delle frutticole. Non mi sembra che abbiamo detto che non è importante, anzi io ho ribadito che il programma è iniziato nel 1992, io avevo appena 30 anni, adesso ne ho 60, quindi la Regione sono 30 anni che sta investendo, diciamo, soprattutto sulla conservazione, cioè i primi 20 anni li ha investiti sulla conservazione. Se oggi possiamo fare tutte queste caratterizzazioni è proprio grazie, diciamo, all'impegno che la Regione, diciamo, sia di personale che economico ha messo a favore della conservazione. Quindi diciamo, siamo convinti che anche nella prossima programmazione la conservazione sia uno dei punti cardine.
Anche io ho capito in questi termini. Va bene, allora io ringrazio tutti per la partecipazione, ringrazio di nuovo gli organizzatori e auguro una buona serata a tutti. Arrivederci.
Arrivederci.